Hello, everyone. Hello? Hello, everyone. I would like to invite you to our conference, Kubernetes Community Days 2024, here in Prague. This is the third time we have this conference. The first conference was virtual. Last year, we were in Bratislava, and now we are here in Prague. At first, I would like to say thank you to all the organizers. Here are the names of the organizers, and we also, as are the animals of the CNCF, and each one of us acquired one animal. So thank you to all your guys for this event. Also, I want to thank you, the sponsors, Cybers Labs, Labyrinth Labs, Pure Storage, Red Hat, Prusha Research, Dynatrace, Ondrej Čika, and Perfect Scale. And now I would like to get the stage to Pan Jakub Novak, Vice-Decan for Cooperation for Industry. The stage is yours.
Thank you, Juraj. Nice to meet you. I'm very proud that on the behalf of our dean, I can see you here at our faculty at the CTU. We know that it's your third year, but I hope it's not our last year in here. I was talking to Juraj that maybe we can make it a tradition, and every second year we can meet here again. Feel free to use whatever they have prepared for you. Enjoy the social event, and have a great 2 days at our faculty.
Thank you for your words. Thank you very much. Okay, I would like just to say some things about, or some little story about the CNCF Cloud Native definition. Here you can see on the screen the definition, but I think that the definition is really hard to explain to somebody who is not working with the technology. The definition is quite hard. There are really strange things. And how do you explain to somebody who do not know much about IT what you are doing? This is the other part of the definition. And how do you explain the CNCF Kubernetes to somebody who do not know anything about IT? How you can explain it really simple? And for me, I had this idea, and I explained the CNCF and Kubernetes. For me, it's Lego. This main plane, on this plane, it's like Kubernetes. You can make almost everything. You can make a simple infrastructure, something like this, just some basic services and basic infrastructure, or some more sophisticated infrastructure when you take more parts from the Lego box, or to even such really crazy things. Imagine that this is your cloud-native infrastructure, really complex, really a lot of services, and you came to company and you have to manage it and to maybe upgrade some small detail on it. It would be, I think, really pain. Or you can make something really nice, easy to upgrade, and easy to use. And I think that this conference should be about it, to get to all of you, the best practices, how to make a good infrastructure, how to prepare something like this, and not such really strange things. And the Lego box, I think, is here. All the services, all the small boxes, all the small pieces of the puzzle, and it's up to you what you build from these small pieces. Okay, so now let's skip this. We are also working in Slovakia and Czech Republic. We are organizing meetups in Slovakia, in Czech Republic. There is Danek, really cool organizer. And now I would like to say some things about today's event. Thank you all for coming, and we have today 2 days, 2 stages. One stage is here, another stage is right there on the right side from this part. And we have 35 sessions today, more than 35 speakers. There will be one panel discussion, more than eight sponsors, and 5 workshops. Everything here in these 2 rooms will be recorded, and it's online streamed on the internet, so everything is streamed. Today, in the evening, we also have social event. The social event will be in the pub named Na Kotlášce. It's today at 18:30, and there is a limited number of attendees. When you, as an attendee, want to go to the social event, go to the booth, and the stands have the tickets, some rings for you, and ask them for them. We also have a raffle. In a raffle, it will be tomorrow at the end of the event, and there are some really cool prizes like the 3D printer, some merchandise from the Cloud Native Computing Foundation, and some other stuff from the sponsors. Also, we have lightning talks. They will be today, and there are still 3 slots open. Hope so. Don't know if somebody has written there. So when you have some kind of project or some idea, please write there your name, some kind of topic, and you can talk on this stage in front of everyone. There is also a creativity board and job offer. So when you have any ideas about Kubernetes, about your feelings, about whatever you want, you can write there whatever you want. It's our team from tomorrow when we almost everything completed, so please enjoy the event, and I would like to give the stage to Filip Pohronsky. Thank you very much for your attention.
Good morning, everyone. I'm thrilled to see microphone. Good morning, everyone. I'm thrilled to see such a fantastic tomorrow for Kubernetes Community Days here in Czech and Slovak. Your presence today is a testament for thriving community we have in this region. Kubernetes Community Days are all about fostering collaboration, learning, and innovation. These events provide a unique opportunity for developers, operators, and enthusiasts to come together, share their experiences, and contribute to the future of Kubernetes. Our goal is to strengthen the community bonds and inspire each other to push the boundaries of what's possible with cloud-native ecosystem. Before we dive into today's exciting agenda, I will to extend a warm thank you to our sponsors and contributors. Without their generous support, even like this wouldn't be possible. Let's give a round of applause for our sponsors for their trust and commitment to the Kubernetes community. Now, let's take a moment to reflect on Kubernetes' journey since 2014. Kubernetes builds upon years of experience at Google running production workloads at scale using a system called Borg, combined with best-of-breed ideas. Had its first major release in 2015. By 2018, it graduated from CNCF, marking its maturity. Today, Kubernetes is a global standard used by 90% of Fortune 500 companies. It's revolutionized how we develop, deploy, and scale applications, making processes more efficient and reliable. So, at the beginning of the universe, there was a big bang. Then, long time, nothing really interesting happened. Long story short, half of the world's population stopped understand what's going on in the cloud with containers. Let's recap some building blocks of Kubernetes. Kubernetes' open source nature is one of the greatest strengths. It brings transparency, flexibility, and community collaboration. Thousands of contributors worldwide enhance the platform, ensuring it evolves with our needs. This open source model drives continuous innovation and improvement, making Kubernetes a robust solution for managing applications. One standout feature of Kubernetes is its extendability. It's designed to integrate seamlessly with a variety of tools and services. Whether it's syncing with CI/CD pipelines, monitoring tools, or other cloud-native technologies. Kubernetes adapts to meet specific needs for developers, providing a flexible and powerful platform. The Kubernetes ecosystem is vast and growing, with tools like Helm for package management, Prometheus for monitoring, and Istio for service mesh. CNCF plays a crucial role in fostering innovations and collaboration. Projects like Envoy, gRPC, and Fluent shows how this ecosystem supports diverse and powerful cloud-native solutions. The landscape is wide and includes areas such as application definition, image build, database, streaming, messaging, scheduling, orchestration, service mesh, remote procedure call, service proxy, API gateways, coordination and service discovery, cloud-native storage, cloud-native network, runtime container, and the list is so long, I bet. Let's continue. Kubernetes employs a declarative model, simplifying the process of defining and managing the desired state of applications. This approach means that you specify what the system should look like, and Kubernetes ensures it matches that state. It's efficient and reduces errors, making it easier to manage complex systems. One of Kubernetes' strengths is its support for event-driven automation and continuous reconciliation. Kubernetes monitors the system and automatically adjusts resources to match the defined configurations. This ensures stability and predictability even in dynamic environments. GitOps leverages Git as the single source of truth for managing infrastructure and applications. In Kubernetes, GitOps enhance collaboration and transparency. Changes are tracked, reviewed, and deployed using version control system, ensuring everybody has visibility into the system state and history. This widespread adoption of Kubernetes has resulted in a rich knowledge base and a large active community. From documentation to forums and meetups, there's a wealth of resources available. Organizations can tap into the expense of optimize their Kubernetes deployments and solve complex challenges. Kubernetes is built to ensure high availability and scalability. It automatically balances loads, heals itself, and scales horizontally to handle varying demands. These make it ideal for mission-critical applications that require continuous uptime and the ability to scale effortlessly. Security is a top priority in Kubernetes, which includes robust features to protect applications and data. Role-based access control manages the user permissions. OPA, Gatekeeper, and Kyverno enforce policies. Spire handles its identity and encryption, and Istio provides mutual TSL for secure communication. Falco and Sysdig offer runtime security, and Notary ensures that only trusted container images are deployed. Observability is crucial for managing applications, and Kubernetes provides excellent tools for this. Prometheus helps with monitoring, Fluent and Loki handles logging, or Jagger offers tracing capabilities. These tools give you deep insights into your system's performance and health, helping you to quickly identify and resolve issues. Everybody loves the success stories, I bet. In the cloud-native world, we have some incredible examples. Graduated projects like Kubernetes and Prometheus have been quickly adopted and well established in the industry. Let's look for the latest news. Several projects highlight the success of the Kubernetes ecosystem. Cilium has graduated to CNCF project, enhancing networking with eBPF. Kubernetes GPT uses AI to simplify Kubernetes management. Istio Ambient Mode offers a sidecarless architecture, and OpenCost monitors carbon cost for sustainability. These projects showcase innovation and growth within the cloud-native community. At KubeCon and CloudNativeCon 2024, we saw exciting announcements. SpineCube leverages WebAssembly for better performance. FluentBit 3.0 introduces new log parsing and HTTP2 support. Docker Build Cloud offers fast image builds, and Captain and Persis enhance deployment and observability with better integration and new features. These innovations show the ecosystem's continuous evolution. Kubernetes plays a crucial role in AI, ML, and edge computing. It integrates seamlessly with AI and ML workflows using tools like Kubeflow, enabling scalable infrastructure for model training and deployment. In edge computing, Kubernetes manages real-time data processing and IoT devices. This is particularly useful in autonomous vehicles, smart cities, and other IoT applications where low latency and efficient resource management are crucial. Sustainability is a growing concern in the cloud-native ecosystem. Projects like OpenCoast help monitor and reduce carbon emissions. Best practices include optimizing resource usage and using energy-efficient data centers. By adopting these practices, we can ensure that our cloud-native operations are both high-performing and environmentally friendly. The Kubernetes community succeeds through collaboration. Contributions come from all levels, from novices to core contributors. Programs like the Kubernetes Contributor Experience, mentorship initiatives, and diversity efforts help support and grow our community. These programs ensure that everybody has the opportunity to contribute, learn, and advance, fostering a vibrant and an innovative ecosystem. Now look to the new future. Can you predict the direction? I bet you have your own version of cloud-native ecosystem. future. Looking ahead, Kubernetes continues to evolve with exciting developments. Emerging trends like serverless architecture, service meshes, quantum computing, and multi-cloud deployments are shaping the future. The CNCF remains committed to supporting innovations and new projects, ensuring that Kubernetes stays at the forefront of cloud-native technology. Continuous collaboration and contributions from the community, so members like you, will drive these advancements. Engage, contribute, and collaborate. Let's take the lessons learned and the inspiration gained from this conference to drive the next wave of cloud-native innovation. Together, we can shape the future where technology empowers us to solve complex problems and create a more sustainable, efficient, and inclusive digital world. Thank you all for being a part of this journey, and I'm looking forward to the amazing development ahead. So do not fasten your seatbelts and turn on your devices to online mode, and let's start.
Raz, dva, tri. Tak krásne dobré ránko ešte raz všetkým. Ja by som rád uviedol ďalší talk. Chalani zo Cyberlabsu nám porozprávajú, ako využiť Kubernetes v energetike, čo znie ako hodne zaujímavo, takže všetci pozorne počúvajte. Nejaký pár základných informácií, konkrétne jedna. Tam máte QR kód, tam druhý vedie na to isté miesto, je to slajdo, môžete tam pokladať svoje otázky. Po skončení prezentácie všetky odpálime a speakery budú na rošte a všetko nám odpovedia. Díky za pozornosť a chalani, prosím na stage.
Kdy jste naposledy strčili něco do zásuvky? Asi to není úplně dlouho. Všichni používáte nějakou elektřinu, nějaký zařízení, který máte, ať už jsou to telefony nebo počítače. A asi se ta elektřina k nám nějak dostane. To, aby se k nám dostala, k tomu máme nějaký energetický sektor firem, který se zabývají dodávkou energií, distribucí, měřením a tak dál. Kdo jsme? Já se jmenuji Láďa Čapka, je tady se mnou Jožka Rudiak. Budeme vám chvíli povídat o tom, kde se dneska energetika nachází, jak to v ní vlastně vypadá. Jsme tým lidí, který se zabývá energetikou, řekněme, více než 10 let. Řešíme spoustu projektů, které jsou v této oblasti vlastně definovaný. A to zejména v oblasti měření. To znamená, že je to taková ta oblast, kde když se k vám elektřina dostane, tak máte elektroměr, v tom elektroměru se měří něco, spousta různých údajů a tyhle ty údaje je potřeba nějakým způsobem sbírat. Ten sběr dat, který se tam dělá, tak vy ho možná znáte z domácností tak, že přijde jednou za půl roku nějaký odečítač, který něco odečte. To je takový ten historický case. A dneska už je to trošku jinak. Někdy je tam simka, odečítá se to na dálku a konkrétně v průmyslu tohle platí už dlouhý roky. To znamená už někdy z 90. let byla poměrně velká povinnost legislativně odečítat elektroměry na dálku a dělá se to poměrně sofistikovanými systémy. Již dodáváme, distribuujeme a nějakým způsobem operujeme. A to, kde se pohybujeme se zkušenostmi, je víceméně z oblasti regionu EMEA, to znamená, že jsou to oblasti, které jsou primárně Evropa, ale není to jenom, takže patří tam některé arabské státy, kousek nějaké Asie a podobně, takže těch zkušeností s těmi projekty máme poměrně hodně. A ta variabilita toho deploymentu, to, jak to vlastně vypadá, se poměrně velmi liší. O čem si tady dneska povíme? My vám tady dneska povíme o tom, jakým způsobem energetika pohlíží na software, jaké problémy tam jsou v rámci dodávek, co to vlastně skýtá, co to vyžaduje, co je za různé takové ty typické casey, které je potřeba vyřešit. A řekneme si něco o tom, jak typická taková distribuce těch systémů nebo deployment těch systémů dnes probíhá. A pak si ukážeme nějaký takový proof of concept nebo takový návrh řešení, které zapadá do toho dnešního tématu, a to je Kubernetes. To znamená, ukážeme si nějaký takový příklad nebo nějakou takovou ukázku toho, jakým způsobem můžeme Kubernetes využít v energetice, jak ho začínáme využívat a jak ta věc vlastně vypadá. A já bych tedy předal slovo Jožkovi, který by nám pověděl něco o tom, jak to dneska v energetice vypadá, protože má do energetiky blíž než já. Já jsem spíš z té oblasti toho softwaru, návrhu, deliveries a podobně. A Jožka je z té oblasti energetika, má zkušenosti z ní, takže by nám řekl, co to skýtá, jaké problémy tam jsou, co to znamená pro to dodávat tam software a jaká to má vymezení, omezení a specifika.
Jo, dík za slovo. Takže moje jméno je Jozef Dudiak. Ja vlastne v energetike sa pohybujem už viac ako 10 rokov, ale stále na tej strane biznisu, nie na tej strane IT. A s Láďom možno vytvoríme práve tú synergiu, o ktorej chcem hovoriť, a to je synergia energetiky a IT. A tak ako bolo na začiatku povedané, že máte doma elektrínu v zásuvke, tak ono vlastne, keby ste ju nemali, tak ani tie IT technológie fungovať nebudú, tie Kubernetes klastre fungovať takisto nebudú. A Ako sa vlastne na to pozerá energetika z pohľadu legislatívy? Je to vlastne dosť konzervatívny sektor, ktorý je riadený do určitej miery štátom, ktorý musí garantovať stabilitu, aby naozaj v každom okamihu bola elektrina v každom bode, aby každý zákazník mal prístup k elektrickej energii. A samotná legislatíva stanovuje alebo zaväzuje a zväzuje jednotlivé energetické spoločnosti v tom, aby implementovali technológie, ktoré budú stabilné a budú naozaj fungovať. A ako v takomto prostredí presadiť nejaký open source, alebo ako v takomto prostredí presadiť nejaký malý projekt, ktorý nebude vždy postavený len na enterprise, tak je to niekedy zložité. Je to zložité hlavne aj z pohľadu procesov, pretože energetika, ako sa vyvíja v čase, tak častokrát niektoré procesy sa nabaľujú na seba aj 10 rokov, aj niekedy aj viac. A takéto lastovičie hniezdo, kde sa stále lepí a dolepuje a ten proces už je potom tak strašne zložitý, je niekedy ako náročné rozbiť a pozrieť sa na ňo z pohľadu toho, ako to urobiť inak, ako využiť trebárs open source. Ja som počas svojej nejakej praxe zatiaľ sa mi podarilo proste implementovať rôzne veci nad práve meteringovými systémami, kde sme v spolupráci aj konkrétne aj s Laďom a s ďalšími sme implementovali rôzne open source od Pythonu, od rôznych Kubernetes klastrov cez Dockery a snažili sme sa pozrieť na procesy inak. A prečo sme to vlastne celé robili? Je to preto, aby sme mohli zbierať dáta, ktoré máme v sieti, máme niekde v teréne, máme rôzne senzory, ktoré sú nasadené naprieč celou energetickou infraštruktúrou. A z tých dát, ktoré vyzbierame, potrebujeme urobiť informácie, aby sme robili správne rozhodnutia. Rozhodnutia, ktoré nám pomôžu v prevádzke jednotlivej infraštruktúry energetickej, aby sme sa vedeli rozhodnúť, kedy ktoré zariadenie správne, v akom čase obnoviť a podobne. Keď sa pozrieme na energetiku, tak kým prejdeme k samotným tým smart riešeniam, ktoré Láďa bude celé popisovať, tak ja sa stále tak pýtam, že či ako môže byť energetika smart. Ona musí byť smart, pretože keď sa pozrieme na množstvo dát, ktoré tam prúdi zo všetkých možných senzorov, tak musíme ich využívať na to, aby sme sa posúvali vpred. A jedna z oblastí, ktorej sa budeme tu teraz v tejto prednáške aj venovať, je práve smart metering a využívanie smart metrov na to, aby sme boli efektívnejší pri spotrebe elektrickej energie a zároveň aby sme vedeli zdieľať elektrickú energiu v rámci komunít a podobne. Takže samotné riešenie, ktoré bude za chvíľu predstavené, je niečo pokrokové, je to open source, ktorý v energetike nemá obdobu, ale v zásade je implementovateľný v rámci jednotlivých koncernových spoločností, ktoré sú obrovské, minimálne tu v Česku sú to vlastne 3 veľké trebárs distribučné spoločnosti, kde práve sa nasadzuje smart metering a je podmienený legislatívou, či už vyhláškou o mnežení, ktorá vlastne o 138, ktorá aktuálne bola updateovaná a práve to podlieha tomu, aby sme boli smart, aby sme sa posúvali vpred. Takže za mňa asi toľko k technológiám a energetike a odozdám vlastne slovo Láďovi, aby predstavil to samotné riešenie.
Já než se dostanu k tomu představení toho řešení, tak vás trochu vyděsím. A vyděsím vás tím, jak ty věci vypadají dneska. Protože my jsme tady na konferenci o Kubernetes, všichni očekávají, že jak tady všichni máte vyzkoušený spousty technologií z Kubernetes a jeho okolí a z Cloud Native a podobně, že začnu tímhle, nezačnu. Začnu tím, jak to vypadá dneska, protože dneska, když přijdete do energetiky, a to skoro kamkoliv, jak bylo řečeno, že to je konzervativní sektor, tak tam narazíte úplně na něco jiného, než jste zvyklí tady z těch přednášek, nebo než čekáte z těchto přednášek. Bude to klasická farma serverů, ležících někde v serverovně té energetiky, velmi typicky, protože energetika říká, my si to budeme podávat sami, protože musíme a protože chceme. Na té farmě serverů bude nějaký vSphere, VMware, nějaká virtualizace, úplně klasická, jaký možná znáte z předchozích dob, nebo možná už ani třeba už ani nepoužíváte. Za ní bude velmi pravděpodobně řada nějakých Windows virtuálů nebo Linuxových virtuálů a tak dál. A na těchto řešeních, nebo respektive na těchto strojích a těchto prostředích dneska tyhle systémy běží. Jako bez srandy. Jo. Velmi často se tam stále potkáváme s tím, že jsou to jako enterprise věci, takže když tam přijdete z databází, která není enterprise a není Oracle, ještě před 8 lety jste neměli šanci se tam prosadit, protože bylo řečeno prostě, hele, to musí být enterprise a neexistuje, že by tam jste dodali řešení, který jste s nějakým open sourcem. Dneska se to mění, už tam ty možnosti jsou pomalu, ale stále těch energetik, který tento způsob deploymentu, jak je popsaný nahoře, nebo toho klasického řešení, toho setu, pořád je běžně používaná věc. Pomalu se někam dostáváme, takže pomalu, ale jistě se začínají objevovat v praxi ty řešení typu, že už to třeba není databázově centrické řešení ve smyslu, že na každém z těch Windowsích nebo Linuxových serverů je nějaká služba připojená k databázi, začínají tam být něco jako message buses a podobné věci, které určitě znáte z historie už jako z dlouhé doby, tak v energetice to prostě jako nebývá. Tak ty věci už tam dneska začínají být. Ale nicméně ty požadavky v energetice se stále zvyšují, to znamená množství dat, velikost procesingu, to množství, co s tím musíte udělat, je den ode dne větší a i s legislativou, i s potřebami těch energetických firm se vlastně neustále zvětšuje. A to i proto, že energetika občas říká, my bychom chtěli experimentovat sami, a někdy říká, dobře, máte nějaké API v tom vašem systému, nebo existuje v tom řešení nějaké API, my bychom si třeba vedle toho napsali Python script. Tady Jožka zmiňoval, že zkoušeli něco dělat, tak to je třeba jeden z těch případů, kdy měli napojeno Power BI přes Python skripty k řešení, který mělo restové API. Jo. A to samo o sobě byl poměrně jako velký pokrok, ačkoliv to může v tom prostředí tady působit jako velmi zvláštně. A ten důvod je prostě ten, že elektřinu chceme všichni každý den a energetika, jak je velmi konzervativní, tak na to kouká tak, že říká, hele, my vlastně chceme ty technologie radši o hodně později a chceme je mít nějak jako stabilní. Proč ty řešení nestačí? Já už jsem to trochu zmínil. Je to zejména proto, že ta komplexita se zvětšuje. Ty věci se tam dějí způsobem, jakým se dějí. Je tam spousta požadavků a spousta věcí, které se mění ve smyslu třeba četnosti odečtu, takže dřív stačilo odečítat jednou denně. Dneska v energetice vám někdo řekne, jednou denně nám to nestačí, my to chceme ty data třeba 2krát denně, nebo jednou za hodinu, nebo podobné požadavky přicházejí. Takže tam potom začínáme narážet na to, že stabilita těch systémů a komplexita těch systémů je natolik velká, že vlastně ty klasické řešení těch monolitů, které byly někde deploynuté na těch Windowsových nebo Linuxových mašinách, vlastně nedostačuje. Takže my přicházíme s něčím, co je kousek posunuté a chceme na to koukat jinak. Dali jsme si několik takových jednoduchých premis. Ta jedna je taková, že říkáme, ano, OK, asi chceme něco víc mikroservisního, asi už jako nechceme ty monolity tam mít. Jo? To znamená, že chceme vytvářet nějaké služby, které řeší jednotlivé části těch systémů nebo toho celku, toho systému. A dají se, dejme tomu, jednoduše upgradeovat, což bývá jeden z problémů. Dají se jednoduše upgradeovat fyzické servery, eventuálně virtuální nebo cokoliv dalšího. Nechceme downtime, to znamená, nechceme mít nějaké výpadky, chceme ideálně bezvýpadkový systém a tak dále. A hlavně chceme to řešení decentralizované, to znamená, nechceme úplně mít někde databázi, která je centrálním bodem nějakého velkého systému, který následně jako neběží, když ta databáze neběží a nedá se nikam replikovat a tak dále. Já bych tomu ještě podotknul, že velmi často se v tom prostředí setkáváme i s tím, že energetika často říká, že fyzické servery má ve 2 lokacích, nebo ve více, často je to ve 2. A většinou je to ve smyslu high availability, ale s downtimem. To znamená, že často je to řešeno tak, že máte aktivní sajtu a pasivní sajtu, která je offline a je offline až do té doby, než umře ta primary site. A když umře primary site, tak se prostě pustí do nějaké doby ta druhá. A my jsme si řekli, no jo, ale proč? Jako proč vlastně máme takováhle řešení, když se podíváme dopředu a podíváme se tady mezi vás, kteří máte zkušenost s Kubernetes a podobně, proč vlastně vůbec tyto řešení ještě jako takhle divně stavíme? A začali jsme navrhovat něco, co nazýváme dneska cvičně OpenHashem. OpenHash je řešení, které je postavené nad některými vybranými technologiemi, které znáte z CNCF, to znamená z těch, o kterých tady dneska povídáme. Je to řešení nativní pro Kubernetes, to znamená, že je vyloženě určeno pro ten běh v tomhle prostředí a je zamýšleno tak, aby vlastně splňovalo, nebo respektive dovolovalo, umožňovalo ty řešení v tom energetickém sektoru posunout o nějaký řád dopředu. Takže na čem stavíme? Stavíme samozřejmě na platformě Kubernetes, to je asi přirozená věc, čekám, že jste asi nic jiného nečekali, to je asi v pohodě. Co se týká služeb, viděli jsme spoustu řešení, většina z nich byla napsaná v Javě nebo v .NETu nebo v podobných poměrně jazycích, které produkují poměrně velký kód, poměrně paměťově náročný kód. A my jsme začali jít trošku někam jinam a řekli jsme si, že zkusíme použít něco, co je víc Kubernetes Native, nebo je to k tomu blíže a začali jsme koukat po Go. Takže náš kus řešení, který máme, tak je v Go. Co se týká monitoringu a dalších věcí, tak tam používáme v tuhle chvíli Grafanu, Prometea. Jistě znáte některé z těch věcí, které neznáte, tak doporučuji se na ně podívat, jsou super. Dá se s nimi poměrně hezky pohrát. Co se týká databází, zahodili jsme velký monolity a řekli jsme si, že asi nechceme veliký orákl pro celý systém, který tam budeme nějak deployovat růzostrašně do Kubernetes a zvolili jsme jiné. Jako příkladem může být například NAC, nevím, jestli ho znáte, já o něm něco povím o pár slajdů dál. Je to jedna z malých, není to úplně databáze, je to spíš streaming systém, ale jako databáze na krátký dočasný uložení dat jako key value storage se použít dá, takže najde svoje řešení u některých těch mikroservisních částí. Kubernetes. Proč Kubernetes? Jednoduchá platforma, všichni ji znáte, v energetice už ji viděli, což je super. Takže už se tam s ní dá pomalu operovat. Ne všude, podotýkám. Ne všude, protože setkali jsme se třeba s projektem, kde jsme navrhovali, pojďme tam dát Kubernetes a zákazník říká, ne, to je moc, ale můžete Docker, jako na Linuxu, jakože v pohodě. S Kubernetes můžeme být konečně highly available, takže si říkáme, dobře, pojďme teda stavit ty klastry tak, že když máme klastr, tak neřešíme, na kterým nodu běží, neřešíme, jestli má 2 sajty nebo nemá. Pojďme se na to podívat klasickým světem Kubernetes. Takže určitě doporučuji pro ty z vás, kteří ještě Kubernetes nevyzkoušeli, ale věřím tomu, že jich je málo, tak Kubernetes se na nějakou platformu podívat, protože opravdu skýtá super věci. A jedna z těch neposledních věcí, jak energetika říká, že chce být zabezpečená a je potřeba, aby zajistila nejenom jako bezpečnost z pohledu chodu, ale i bezpečnost z pohledu jako zabezpečení dat a tak dále, tak na rozdíl od toho, aby jsme řešili zabezpečení na fyzických serverech, tak v Kubernetes můžeme využívat ty nativní podpory jako security kontexty a podobně a dá se s tím poměrně víc hrát a celé to řešení může vypadat, řekněme, definičně lépe. Go. Proč Go? Tuhle otázku já jsem si položil taky nedávno a říkal jsem si, proč Go? Teď vlastně jako máme ten .NET, je to super, ne? A pak jsme začali dost experimentovat a zkoušet v tom, jak ty věci vlastně vypadají. Napsali jsme si pár základních věcí, takže jsme začali psát první driver pro komunikaci s elektroměrem. Je tam nějaký protokol DLMS, je to poměrně komplexní binární záležitost. A když jsme ho napsali, tak jsme zjistili, že sice nás tam spousta věcí trápí, protože v Go nemáte třeba výjimky a podobně, na který jsme dneska zvyklí ze všech možných jazyků. A je to taková ta jako věc, která jako je super a říkáme si, jo, to vlastně chceme. A oni tam nejsou, jo, jako, takže tam je prostě nenajdete. Jo. Tam klasicky to vrací error z každé metody a musíte to řešit jinak. Ale to je jako takový jako jeden z takových downsideů, na který si musíte zvyknout u Go, ale to neznamená, že je to horší řešení nebo horší jazyk. Ty benefity, které jsme tam objevili, jsou jako poměrně upřímně magický. Jo. Jeden z těch magických benefitů je třeba jako správa memory managementu a vůbec celkově zdroje. Go tím způsobem, jak je udělaný, je naprosto boží věc, jako úplně jako boží věc na to, aby když píšete jakýkoliv software, tak abyste v rámci distribuovaných systémů a distribuovaných řešení v Kubernetes nesežrali všechny zdroje hned. Memory management funguje v Kubernetes tak, že když alokujete nějakou proměnnou, tak ona je alokovaná jenom po tu dobu toho, co v tom kódu vidíte, těch pár řádků, který potřebujete. Ten memory manager je velmi efektivní. Takže, jak říká zkušenost třeba z .NETu, když si budete sledovat paměť, tak jsou tam takové píky, vždycky zabere garbage collector a ten to smaže, ten programek se pozastaví na nějakou dobu, jo, a zas to jede dál, to je taková pila většinou, to tak tvoří, takový hruzostrašnosti. V Go to není, jo. V Go prostě, když pustíte Go, tak ono to jako je paměťově velmi efektivní a to je jako jedna super věc. Druhá super věc, která je v Go, je jako paralelismus. V tom prostředí té energetiky je to většinou tak, že když říkáte, my chceme odečítat nějaké zařízení nebo zpracovávat data, tak vzhledem k tomu, že máte krátký časový prostor, krátký časový okno, řekněme třeba, uvedu příklad, máte 200 000 elektroměrů v síti na GPRSách a máte 2 hodiny na to, nebo 1,5 hodiny na to, abyste z nich pozbírali data. Víc prostě nemáte, těch dat je hodně, řekněme, že jsou to plácnu desítky megabajtů z každého zařízení, musíte je zpracovat. Je tam řada výpočtů, takže musíte poměrně masivně řešit nějaký paralelismus. Ve spoustě jazyků existují vlákna, to znáte, takže si naspouštíte ve vláknech, co potřebujete, můžete mít konkrétní přístup. Ono je to celkem super, ale to, co je v Go, co se týká konkrétního přístupu, je jako magic. Pořád pro mě je to jako velký magic. Jo? A to jsou gorutiny. Gorutiny jsou super věc, která je velmi paměťově efektivní. Není to úplně nativní vlákno, je to abstrahovaný nad tím. A můžete jich mít strašně moc, takže bychom experimentovali s tím, že říkáme dobře, máme prostě 2000 paralelních odečtů, pojďme pustit 2000 gorutin jako paralelních vláken. A kolega mi říká, ty jsi se zbláznil, jako jo, to bude strašně moc, to sežere všechny zdroje. A ono se to nestalo. Jo, prostě ono to funguje fakt jako báječně a je to jako mega rychlý. Takže pro ty z vás, kteří Go nevyzkoušeli, jako jo, tak pro tyhle řešení je to fakt super věc. Pojďme dál. gRPC. Když budeme mluvit o tom, jak komunikovat mezi těmi službami, které v tom řešení máme, tak existuje řada různých protokolů, jak se k tomu postavit. Můžeme si vymyslet vlastní, to asi nechceme, že jo? Energetika říká, použijte nějaký standard. Můžeme použít REST, my říkáme dobře, je tam JSON nebo XML. XML je veliký, v JSONu říkáme, tam je zase problém třeba s číslama, nevím, jestli jste to někdy potkali. Když děláte deserializaci JSONu, tak nevíte, jestli integer je integer nebo float a úplně se jako nedá dobře vyřešit ta typovost. Jo. Takže je to takový, skýtá to tyhle problémy s těmi typy. A tak jsme řekli, dobře, tak pojďme kouknout na gRPC, jestli by to jako nebylo řešení, protože to má svou serializaci, je to binární, generují se k tomu modely z protobuffu a hle, ono to funguje. Takže gRPC, další věc, na kterou doporučuji se podívat, je to super. My to dneska používáme v rámci toho našeho řešení pro veškerou komunikaci interní mezi službami, takže všechny ty služby mezi sebou komunikují gRPC. Navenek dneska máme vystavený REST a to jenom kvůli tomu, že přece jenom REST je pro ten svět, okolní svět toho systému je praktičtější nebo přirozenější. NAC. Už jsem tady zmínil, že NAC je něco jako databáze, my ho v té formě trošku používáme. V řešeních, který jsme viděli dříve, nebo který pořád vídáme, tak je to velmi často tak, že tam potkáte opravdu jako Postgres a Kafku a RabbitMQ a nějaké takové frontovací systémy. Tady to není úplně pravda, my jsme si řekli, pojďme se na to podívat jinak a pojďme nemít jeden velký frontovací systém, pojďme za každou tu službu, nebo podle potřeby, ne nutně za každou, dát něco, co vlastně ta služba potřebuje. A jelikož Kafka je veliká na zdroje, a jelikož RabbitMQ nám způsobil řadu vrásek na čele při deploymentech, hlavně v HA řešeních a tak dál, tak jsme si řekli, hele, pojďme hledat něco jiného a objevili jsme NAC. NAC není databáze, už jsem to říkal, je systém, který je implementován nad Jetstreamem. Jetstream je streamovací, řekněme, implementace uvnitř toho NACu. Takže primární je jakýsi storage, který řeší primárně subscribe, publish fronty, ale nejenom. Má další dvě věci, dva způsoby, jak se dá využít. Jedním je key value storage a druhým je object storage. Což znamená, že v rámci toho obsahu, když máte nějakou službu, kde chcete zafrontovat nějaké joby, nějaké úlohy, tak je tam můžete dát. A když tu úlohu splníte a dokončíte, tak pořád do tohohle můžete uložit výsledek, můžete tam mít definice a podobně. Takže my jsme s tím trošku experimentovali Funguje to dobře a ku podivu světadivce je to dokonce jako poměrně hezky stable, takže se do toho dá fakt jako narvat poměrně dost dat. Má to hezkou propustnost, je to pěkný a hlavně je to jako nativně distribuovaný, má to nativní podporu Kubernetes a jak CNCF v názvu slajdu napovídá, tak to taky říká, že pravděpodobně to je poměrně hezky podporovaný, takže kdo z vás nevyzkoušel, tak NAC určitě doporučuji vyzkoušet nebo se na něho podívat. Už jsem zmínil, že pro monitoring používáme Grafanu a Prometheus. Z CNCF je to Prometheus, možná jste všichni potkali. My ho používáme nejenom pro monitoring a logging, my ho používáme i pro analýzu. Takže jsme si začali vytvářet nějaké grafy, kde máme heatmapy toho, jakým způsobem nám performují jednotlivé části systému, aby jsme si dokázali říct, jak to vlastně vypadá, kde máme nějaké bottlenecky, kde to stojí a tak dále. Takže opět jako dá se s tím hrát poměrně hodně a Prometheus je super věc.
Ja ti možno na chvíľu zoberiem slovo. Kým prídeš k samotnému zhrnutiu, kde je vlastne tá naša motivácia k tomu, aby sme v energetike vedeli využiť OpenHAS? Keď sa pozrieme na to, že v oblasti meteringu budeme mať v horizonte 3-4 rokov cez 100 000 smart metrov v sieti. Čo to vlastne znamená 100 000 smart metrov? To je samotný profil zaťaženia má 96 hodnot denne. Ak sa na to pozrieme z pohľadu toho, že tie dáta chceme využiť len pre nejakú fakturáciu, ktorá nám káže legislatíva, tak to je v pohode. Môžeme využiť aj rôzne zastaralé systémy a rôzne databázy, ktoré sú bežne dostupné. Ale keď sa na to pozrieme, že chceme využiť tieto dáta aj pre riadenie siete, aj preto, aby sme boli smart, aby sme vybudovali tú smart grid, tú sieť, ktorá dokáže v reálnom čase riešiť akékoľvek problémy, tak sa musíme na to pozrieť inak. A práve to riešenie OpenHASu je niečo, čo je z môjho pohľadu prevratné a stojí to za to skúsiť to. Takže len toľko k motivácii a môžeš to kľudne zhrnúť teda.
Ja děkuju. Takže tak to nějak je, tak to vnímáme. Jo. To znamená, že tahle přednáška vlastně pro vás měla být takovým jako insightem, takovým jenom ukázkou toho, jak to vlastně vypadá, jak se ty věci dějí, že je to konzervativní sektor a není to jako úplně sranda, nedá se tam úplně jednoduše dostat. Současně měla být ukázkou toho, kam se dneska pohybujeme a na co chceme koukat. A v neposlední části bych vás rád v rámci této přednášky pozval na workshop, který je dneska po obědě. Protože dneska po obědě Vojta Mareš, kolega tady sedící v obecenstvu, a já budeme ukazovat, jak se takový OpenHAS dá postavit, takže budeme mít tady klastr prázdný, respektive ještě ani ne klastr, ten budeme spolu stavět a ukážeme si, včetně nějakého základního jednoduchého odečtu, jak ty věci vypadají, jak se to dá deployovat, jak se s tím dá hrát, jaké to má benefity, jak to vlastně vypadá. Jo. Takže tady bych jenom využil toho, že jestli máte chuť a čas, tak po obědě neváhejte přijít za náma, nebo na workshop a za náma můžete přijít kdykoliv, takže jestli máte jakýkoliv otázky, myšlenky nebo představy, tak neváhejte využít té situace, že jsme tady z oblasti energetiky, z oblasti konzervativního softwaru a pojďme se bavit o tom, jestli ty věci jako můžeme třeba posunout dopředu, nebo jestli vidíte nějaký potenciál nebo možnosti v tom, co vás tady zaujalo a tak dále. A já koukám, že se nějak blíží asi čas 5 minut před koncem a předpokládám, že 5 minut máme rezervovaných pravděpodobně na otázky, takže já bych to tady pravděpodobně teď zakončil a nechal bych pole působnosti asi otázkám.
Tak díky za skvelú prezentáciu. A otázky, ak ste náhodou niektorí prišli za jazdy, tak prosím buď do slajda, prípadne budeme tu nás si šerovať mikrák. Ale jednu otázku už aktuálne v slajdu máme. A je to prosím pekne. Či staviate tento systém nad virtualizáciou alebo priamo na bare metlu? A prípadne prečo zrovna tento spôsob?
Ani, nebo spíš obojí. Ono je to tak, že my říkáme, my chceme Kubernetes a ve spoustě případů se v té energetice jako tam přijdete s řešením, ale dostanete nějaký vymezený borderlines. Jo? Máte tam nějaký IT, který říká, tohle my neznáme, to nechceme, tohle nám něco nedovoluje, v některých státech to legislativa nedovoluje. Takže my říkáme dobře, může to být virtualizace, klasický virtuály, na nich dejme tomu Ubuntu, na nich nainstalovaný RKčko nebo nějaký podobný Kubernetes. A je to pro nás validní case, přičemž my koukáme na to řešení v těch Kubernetes a dovnitř, nekoukáme na tu platformu, na který to běží. Ale současně říkáme dobře, pojďme se na to dívat tak, že můžeme, nebo spíš můžete v té energetice, jako už na tu virtualizaci zapomenout a pojďme stavět jako multiklásterový prostředí, které jsou cross 2 lokace a podobně a pojďme na to koukat tak, ať nepotřebujeme tu virtualizaci jako takovou. Takže můžeme a nemusíme. Jo? Nevymezujeme se v tom, jak by tato věc měla vypadat a poměrně necháme volné pole působnosti tomu názoru nebo tomu omezení ty energetiky samotné, který se fakt liší, jak se podíváte skrz svět, tak je to po každý něco jiného.
Super, dík. Otázky z publika nějaké?
Ahoj, dík za prednášku. Ja sa chcem spýtať, ako náhle organizácia vstúpi trošku do open sourceu, tak ten počet tých komponent sa môže ako diametrálne zvýšiť proti tomu, na čo byla ta organizácia zvyknutá. Tak či máte z pohľadu security a updateov nejaký updateovací plán, alebo či ste to už riešili, ako vlastne udržať ten celý ekosystém, ktorý vlastne hrozí, že narastie do desiatok až stoviek komponent. Tak či ste už nad tým premýšľali?
Tak my jsme nechtěli úplně růst do desítek až stovek komponent. Teď nevím, jestli mluvíme o instancích nebo mluvíme o typech.
Skôr v momente, keď človek vstupí do toho ekosystému, tak zrazu zistí, že máme Prometheus, máme Gočko, máme prostě stovky jako podporných systémov, ktoré vám niekde dajú certifikát, niekde za vás niečo vyriešia, ale každá z nich je jako samostatný software, ktorý niekto spravuje a je to jako bezpečnostné riziko, alebo bezpečnostné riziko je potreba sledovať, čo sa okolo toho deje a nie je toho málo. Veľmi rýchlo sa človek dostane do stoviek takýchto komponent.
Rozumím otázce. Je to v podstatě tak, že naše zkušenost tady v té oblasti jako není veliká, úplně na rovinu. Jo? Prostě je to tak, že my říkáme, pojďme to zkusit jako open source a uvidíme, co se stane. Takže předpokládáme na této frontě za první teda diskuzi, že si budeme povídat o těch věcech, jak můžou vypadat a jak mají, nebo by měli i z pohledu security. Na druhé straně to prostředí, ve kterém se pohybujeme už delší dobu, tak i když to Kubernetes nebyl, i když to nebylo open source, tak všechny ty softwary vždycky jako říkali, nebo energetika říkala, hele, ten váš software musí mít certifikaci, musí projít nějakou certifikací oficiální, musí projít nějakou kontrolou a tak dál. A to se od toho open sourceu neliší. Energetika sama říká, které z těch softwarů můžete použít a nebo nemůžete, když tam přijdete úplně s čímkoliv, tak vás s tím taky možná vyhodí. Jo? Takže se občas stává i to, že v rámci těch řešení, které dodáváme, tak to není většinou jeden software, ale jako je to často integrace proti řadě softwarů. A ten výběr, který vlastně jako můžeme nebo nemůžeme použít, jako skutečně jako je nějak zúžený. Jo? Takže je to takový, nevíme úplně na rovinu, je to prostě pro nás jako nová oblast. Jo? Chceme to vyzkoušet a vlastně proto jako využíváme konzultací vlastně přímo s energetikou a říkáme, hele, pojďme se dívat na tyhle věci, tohle to vlastně nabízíme a když se nepotkáme na tom, že dejme tomu, já nevím, nelíbí se NAC, jo, protože není dostatečně secure z nějakého důvodu, jo, tak buď se budeme bavit o tom, jak ho používáme a že je to jako v rámci jednoho boxíku interně zabezpečené nějak vhodně, aby jsme ho použít mohli, anebo budeme muset udělat krok a říct, dobře, prostě to bude jiný typ databáze nebo jiný typ věci. Jo. A tam se dneska nepohybujeme, protože my dneska vlastně řešení my jsme ve stavu, kdy to řešení nenabízíme, ale kdy vlastně teprve vytváříme prototyp v rámci konzultací a povídání toho, jak by ty věci mohly vypadat. Jo. Takže je to super otázka, je to super na diskuzi. Určitě jako bychom si o tom mohli jako povídat.
Já se mluvám, že to vstoupím. Já jsem taky ze Cyber Labsu, nicméně mám k tomu nějaký komentář. Tu oblast, kterou jste zmínil, ta je poměrně specifická a není jediná. Těch oblastí, které jsou takhle k diskuzi, je asi 15 a prostě v té energetice je potřeba diskutovat. Jo? A není to jednoduchý. Je to třeba data rezidenci, je to právě sekurita a jak manažovat více komponent. Jo? Takže je to o komunitě v energetice, která by se tomu měla věnovat, protože ten svět je zcela odlišný. Děkuju.
Tak jo, díky. Celkom sa nám tam rozmohol nejaký nešvar na slajdu, takže to skúsime trošku rýchlejšie prebehnúť, nech stihneme ďalší talk. Takže ďalšia otázka. Dostačujú vám kubernetosné bezpečnostné primitíva?
Tuhle otázku bych si možná jako nechal na workshop a na Vojtu, nebo jestli chce Vojta
to je hodně dlouhá odpověď.
Bylo by to super. Já se přiznám, že v tuhle chvíli ano. Protože ve spoustě případů ta energetika říká, hele, my vám tam nainstalujeme nějaký antivirák a budeme na to koukat, jak to je tam nějaký firewall a v této rovině se vlastně jako pohybuje velmi často, jo? Nejde většinou hlouběji. Takže v tuhle chvíli ano, ale je to jedna z předmětů diskuzí, do jaké hloubky ty věci budeme potřebovat. Jo? Takže uvidíme. Ale každopádně na workshopu určitě o tom Vojta může povídat od nás víc a říct, jak ty věci, jaké mají definice, jak to vypadá a kde se vlastně jako z té technologické strany pohybujeme, protože já na tuto otázku úplně sofistikovaně odpovědět upřímně neumím.
OK. Dík. Ďalšia otázka. Prekvapil ma multiregión, čekal bych spíše problémy okolo Edgeu, takže prosím vysvětlit techniku sběru koncových dat.
Ještě jednou můžu poprosit?
Překvapil mne multiregión, čekal bych spíše problémy okolo Edge. Můžete možná více vysvětlit tu techniku, kromě techniku sběru koncových dat?
Jo, rozumím. OK. Ty problémy okolo Edge, na straně toho Edge tam jsou elektroměry, takže tam vlastně jako se pohybujeme v tom, že máte tam zařízení, který vyrábí společnosti, které vyrábí hardware primárně. V těch je nějaký firmware, který vám tam běží, na který vy nevidíte a je tam dnes poměrně nějaký standardizovaný protokol, typicky je to DLMS. Takže na straně toho Edge tam vlastně jako žádnou sofistikaci my neřešíme, ale to, co my řešíme z pohledu systému, je to, jestli se k tomu elektroměru dokážeme vůbec připojit, to, abychom z něho dokázali ty data vyčíst, to, abychom nezhodili síť. I takový případ tady kdysi v minulosti byl, že operátor nepřežil noční odečet a tak dále. Takže ze strany Edge vlastně ty problémy my úplně nemáme, ale je to taky dáno tím, že my nejsme výrobce, řekněme, těch fyzických zařízení jako takových.
Tak jo, díky. Už to musíme uťať, takže smola posledné 2 otázky. Boli určite veľmi zaujímavé. Ak máte niekto ďalšie otázky, tak si chalanov chyťte niekde medzi kafičkem a podobne a díky ešte raz za talk a ideme ďalej.
Díky moc.
So good morning, everyone. This next talk will be held in English. The speaker will be Matej Liner from Labyrinth Labs, and he will tell us how to save some money during our sleep.
Thank you. Can you hear me? All right. So again, good morning, everyone. Welcome to KCD 2024. My name is Matej, and during this presentation, I will talk about the topic of saving money while sleeping, where we will discuss the concept of scheduling scaling. First of all, let me introduce myself a little bit more. I'm from Slovakia. I work for a local company called Labyrinth Labs for 2 years, basically. For last 10 years, I work as an IT specialist, and during that time, I was basically helping customers to migrate their applications and run those in cloud. I have a strong passion, I would say, in standardization and process automation, and one of my key allies is Terraform. Something about Labyrinth Labs. Labyrinth Labs is a one-stop shop for DevOps, Kubernetes, and cloud. We are a bunch of IT experts, especially 20 of us, and we have some missions. One of those is to transfer businesses to become cloud native and future ready, and the other one is to help our customers to seamlessly move to cloud with their workloads into cloud. Yeah. So let's go to the problem of this presentation, and that's the money waste. To better grasp the problem, let's start with some statistics. So I took those from various surveys. One of them is saying that cloud spend is growing by average of 35% year over year. Another one is that many organizations waste almost 32% of their cloud budget. It means that basically most or 32% of their workload is not correctly used or it's unused at all. 72% of organizations are setting resources too high, so it's also one of the common problems. And right-sizing infrastructure can cut costs by 36%. Another set of statistics is that 64% of organizations are not fully utilizing autoscaling. This means that basically they are running the static number of their resources without any automation to scale in or scale out. Only 13% of provisioned CPU is actively used, so this means that we are just wasting money by idle resources. Kubernetes platform is usually over-provisioned by 30%. Again, over-provisioning, so it means that a lot of resources not being used, and those are basically idle. And the last one, and basically the one we are going to talk about during this presentation, is scheduled shutdowns can save around 60% of non-production costs. Based on those statistics, we can basically define some common problems, and I have mentioned those many times. One of them is over-provisioning. What over-provisioning means that we are excessively allocating resources to some workloads, and those resources are not being used. Different way how to look on it is also underutilization. So it's when you take the problem from a different way or from the other way, it also means that the resources are being used in low rates. And to actually commonly call it, it's inefficient resource allocation. Another problems that we can actually understand from those statistics are lack of automatic scaling. I mentioned this, there was one statistic specific for that. And that's it. That's the problem of inability to scale in or scale out based on the current load. So it's a quite common problem for many organizations. And the last one are the idle resources. So it's also the way how to actually how to describe all of those before. All right. So the money waste equals idle costs, or the other way around. Idle costs equals money waste. So idle cost means that we are paying for something that is not being actively used. We had a problem, or we have a problem, so it's money wastage, and there is also a way how to fix that, and that's by using the concept of scheduled scaling. There is one of the common rules to actually get rid of idle costs is to don't run it when you don't need it. So it's one of the golden rules of scheduled scaling. What is scheduled scaling? Basically, in a common tongue, let's say, it's an automatic process that is trying to adjust resource allocation at the predefined times, you know. And these help us to optimize performance and also lower costs. We have some scheduled scaling types, let's say. One of them is time scale in and out based on some minimal or desired state. So if I want to do a scheduled scaling based on what I want to have. For example, I want to have at that particular time only one instance or one replica of a Kubernetes pod, then I will do it in some way, which we'll discuss in another slide. So that's one of the types. The other type is to completely shut down or start up the environment or some deployment on some predefined time. These two types are different for every environment. So let's go to environments. We are, in this case, for scheduled scaling, we are talking about two kinds of environments. One is non-production environments, and the other one is production environment. For non-production environments, we are talking mainly about dev, test, staging, or any other sandbox that we have. These kind of environments or non-production environments, they make about 60 to 70% of environments that usually organizations have. 44% of cloud spend is on non-production environments. So you can see the scale of it, that when you have so many environments, then you can, if you have a lot of money waste on those environments, then you can save a lot of money. And 76% of time these environments are idle, so they are not actively being used, and yeah, that also means the money wastage. Let's have a typical example. So we have a non-production environment which is being called, for example, dev, which is running 24/7. It's quite common for companies which are developing some solutions that they are just simply letting their developers to run also outside of working hours and during weekends as well. So it's basically running 24/7. And if we take that the standard business hours or working hours are from 9 to 5, then we can say that the environment is being actively used only 40 hours a week, right? So if we can count it, it means that there is around 67% of running time that is being actually wasted. How to optimize this? We can do multiple things that are related to scheduled scaling. We can set up automatic scheduled shutdown of the environment or of a certain workload. It means that we need to set the desired state after working hours to 0, so basically shut it down. And right before the working hours or business hours, we want to scale it out, so start the environment to at least some desired minimum. And after that, we just let the auto-scaling do its job. So when I get back to the previous example, again, we have developers which are working from 9 to 5, and outside of these hours, the environment is basically turned off, and there is no, almost no cost related to that. Production. Production is one of the typical cases for over-provisioning, and that's because organizations or companies are trying to over-provision their production environments just because they wanted to be able to handle a sudden peak in a load. So during the business hours, right? You might think that the automatic scaling or auto-scaling is sufficient for that, but when you imagine that there is a sudden load, for example, I don't know, there is an event or something like that, and there is a lot of new users trying to connect to your service, then the auto-scaling, which is basically a gradual adjustment of assigned resources, cannot handle such load in a short time. So that's why you need to buffer an extra resources to actually remain running. Examples for production. For production, there are two kinds of examples. First one is related to planned events. So, for example, there is one of commonly used events in e-commerce is Black Friday. So during the Black Friday, you know that Black Friday starts at, or the sale starts at 5 p.m. and you can basically pre-scale the environment to handle the sudden load. So you will just increase the resources that are allocated to that service. And after the event, which ends during the night time, let's say, you can just scale it down to save costs. And also, the other example is, for example, very similar. It means that before the business hours, you have, for example, you have some application, and you know that during the business hours, the load is 2 times higher, let's say, and you just pre-scale the environment right before the business hours to match the load, and after the business hours, you will just lower the resources to handle just the minimal load, which is usually there. All right, schedule scaling in Kubernetes. That's a topic. You can do it in 2 ways, basically. I will mention this one, the first way, and I will mention it, but I will say that it's not that safe to do. You can do a scheduled scaling of the whole cluster, so it means that you will basically create or remove the whole cluster with all the nodes, all the workloads, and data control plane, and everything that is related. It brings you the biggest cost saving, of course. For example, if you are running on AWS, you don't pay for EC2 instances, you don't pay for the control plane, so it's the biggest cost saving. However, this brings you a lot of problems. One of those is that it's slow on creation. and it has a negative impact on the dependent services. So if you have some pipeline, for example, very good example is a Terraform code. So if you have a platform which depends on some AKS cluster, for example, and you are depending on that based on some outputs, then you are not able to continue with another deployment because, for example, the ID of AKS cluster is changed. So yeah, that's one of the main negatives for this kind of schedule scaling. The other one is workload specific, and this is far more faster and far more safer option than the previous one. And what you can do, you can basically scale down or scale up deployments, stateful sets. You can, for example, shut down the cron jobs and so on. You can do it also namespace based, so you can do it in a bulk way, let's say. So you will define that you want to shut down this namespace and you need to postpone all the cron jobs, for example. Or you can, for example, do it in a node-based, so you will scale down the nodes that are part of your cluster. What kind of Kubernetes tooling are being used or is being used for schedule scaling? So let's talk about that a little bit more. KubeGreen. KubeGreen is an open source and part of a CNCF landscape tool. It's a Kubernetes operator that reduces CO2 emissions by suspending pods and cron jobs during off hours. And also it resumes those pods when we need them. And under the hood, it uses a lot of cron jobs. So that's it basically. It also has some limitations. So it supports only scheduled startups and shutdowns. So it's not able to do a schedule scale in or scale out if you want to lower your replicas to a smaller number, for example, based on time. The other limitation of KubeGreen is that it targets only deployments and cron jobs. So if you have some CRDs that you have developed, you are not able to actually handle those with KubeGreen. And the last one is inability to set dependencies between the scaled down objects. So for example, you have two namespaces and you want to shut down all those two namespaces, but you are not able to specify which has a precedence over the other one. So this might bring some problems when you have dependencies, real dependencies with your services. All right. Let's go to examples. So example one, you can see a Kubernetes manifest for KubeGreen, where the definition says that you want to suspend your cron jobs, and that should be suspended from 8 p.m. to 8 a.m. And it should also, this means that it will suspend all the namespaces, all the pods in your cluster, but you want to exclude some deployments of services. So you will say that you want to exclude from that turn shutdown, you want to suspend a deployment called API Gateway, for example. All right, so the other tool that can be used for scheduled scaling, shutdown or scaling out are the Kubernetes built-in cron jobs. It's meant to be for scheduling of regular tasks using cron syntax. Can be used to schedule resources with the help of custom scripting. And these cron jobs are commonly part of the application definition, so it means Helm charts, for example. There is an example for cron jobs. This is also a Kubernetes manifest that is saying that at 7 a.m. daily, I want to shut down or scale the replicas to 3 on deployment up yet 1. So this is an example when you are actually using the custom script or custom program that you want to, which we want to use to actually do the scale up or scale down or shut down, whatever. Another tool, Sleeper. It's a Kubernetes wrapper, I will call it. It's a Labyrinth Labs in-house built-in tool, and it's a wrapper over KubeGreen with some additional functionality, which is mentioned below, and we are actually doing a startup or shutdown of nodes, because KubeGreen is not able to do shutdown of nodes. So we are aiming to do EKS managed nodes shutdown or startup, and also Carpenter nodes startup or shutdown. Here is an example. So in this particular example, we are trying to scale down and EKS manage nodes, which are part of the, I'm not sure if you are familiar with EKS, but it's Kubernetes service in AWS. And here you can say that you want to shut down the environment for a node pool profile system. So system nodes will be shut down at a certain time. The another example is related to Carpenter nodes. So it's almost the same as the managed nodes in EKS, but this one is aiming for Carpenter nodes. Also the same time and same behavior, basically. Here we are aiming to scale down 2 Carpenter pools. One is called system and the other one is called app default. And there is also a third example, and this is about scaling a namespace. So it means that I want to scale down a namespace's default app 1 and app 2. I want to also exclude a deployment or specific deployment which is called test. And also I want to suspend cron jobs which belong to the namespaces that are mentioned here. So as you can see, it's quite, you can quite easily do a scheduled scaling with these tools that I have mentioned. We also plan to do plan to add some additional functionalities to Sleeper, and it's about pausing managed databases like RDS, or schedule a scale-in or scale-out of managed services like Redis or Elasticcache, and also do some pre-provisioning of throughput for Lambda functions in AWS. All right. And the last tool I will mention here is KEDA. KEDA is even though it's an event-driven autoscaler, it can also be used for schedule scaling. So KEDA actually extends Kubernetes autoscaling capabilities. As I mentioned, it's an event-driven scaling for deployments and stateful sets. It allows us to scale in or scale out based on some external sources or triggers, let's say, let's call it like that. And those can be HTTP requests, message queues, Kafka topics, cron jobs, for example. And with these cron jobs, it can also support the scheduled scaling as such. Here is an example of that. So also Kubernetes manifest for Kafka scaled object. And it says that you want to do a scale in or scale out based on a queue, which is mentioned down below. So if you have a message in a queue, you will read it, and based on that, you can define if you want to scale out or scale in. The other example is about KEDA using time scaling. So the trigger, which is actually triggering the KEDA to scale, is a cron job. So again, at 6 a.m. or it starts and it ends in 8 p.m. And I want to say that there is a minimum replica count to 0. So yeah, between the time it will be there will be 10 replicas running basically. So from 8 p.m. to 6 a.m. it will be only there will be no replicas running, and the environment will be basically shut down. All right, that's about it. Any questions? I can read it.
Yeah, we have many of them.
Isn't such time schedule scaling up and down a large step back since there are pod instances in the town? No, because you still have to pay for those pod instances, so that's basically the answer. Are work hours really relevant? Work time could be very flexible, someone working at night, and there could be a couple of maintenance night jobs, and 3 dots. All right, so yes, it's a good question. There is a way how to actually wake up the environment if you shut it down. So basically, there are some possibilities how to tackle this. But for my experience, also from my previous work, where there was like plenty of developers running outside of working hours, it's not good practice to do outside of working hours. That's the main answer that I wanted to give you from. Yeah. In your experience, are your customers already that far in Kubernetes journey that you can discuss autoscaling, or can they currently consider only cron scheduled? If you stop by our booth, we can talk about our platform, which is called Lara, and basically the platform is cloud ready, and we are having autoscaling in place. So every customer which is running on our platform is trying to use that autoscaling. So yeah, most of our customers do already use autoscaling. Totally understand the node scale down savings, but what are you really saving when scaling down deployments for certain periods of times? Can you give example? Yes, I can. For example, I will mention Carpenter again. You have a certain load or certain workload on Carpenter. Let's say you have a deployment with 5 replicas, and outside of working hours, you want to you want to scale down those replicas to 0, and basically Carpenter will see it, and it will scale down the instance, or basically shut down the instance. So by scaling down the number of replicas, you can also scale down the number of nodes you are having as part of your cluster. So that's the answer. I know a cloud native PG function, suspend resume, which kills pods but keeps storage. Are these similar functions in other projects except Knative or KEDA? I'm not sure about this one. We can talk about it after the presentation. And the last one, what to do in case of sleeper and autoscaler conflicts on node management? CAS should be disabled or special node groups used. Yeah, it might be. It might happen that there will be a conflict. However, I think that here, lowering the number of replicas by changing the deployment will make precedence over autoscaler, I guess. Okay.
Okay, so
Thank you.
That's it. Thank you very much for the talk. And now it's time for a 15-minute break. So grab a coffee.
Okay, hello everyone, and welcome to our presentation. My name is Jakub, and I'm here together with my colleague David. We are working in Red Hat as a quality engineers, and today we would like to share our insights and our knowledge about GitOps approach that we use in our testing environments. At first, let's talk a little bit about the presentation timeline. At first, we would like to get a brief interview what is GitOps and what is the GitOps pattern. Then we would like to share you which other tools we are using, so which platforms we are using, how we set up the platforms, how we do the automation all around. Another step will be cluster management. We don't have just one cluster, we have a fleet of clusters, so it's kind of important to manage these. So this will be another step. And then we will move to Argo CD and Tekton. One of the main parts is also monitoring and logging, so this will be part of the presentation as well. And some useful insights into Argo workflows and Argo events, which are really great tools, and everyone should be aware of it. Then we also prepare some demo, so we will be able to see how our whole infrastructure and basically the whole environment works. And we will also show you some visualization of our metrics and logging that we have depicted in Grafana. Okay, that's it. Over to David.
So let's start with our GitOps pattern. What is a GitOps pattern? It's basically a set of principles and practices which use a Git as a source of truth of all your configuration and manifest for applications. It uses Git as a source control and as a version control. So you always know what the last commit is running on top of your infrastructure and who this commit made. Some key principles. Declarative configuration and manifest for Kubernetes in our application, version control, automation deployment, in our case using the Argo CD. And what are some benefits? I can highlight the collaboration because there is a great opportunity to share the knowledge between the developers and DevOps. And they all can, collaborate in one repository and share their knowledge. We use a platform, in our case, is a Kubernetes, so all of our application, automation, and other stuff running on top of the Kubernetes. We have two kind of platform Kubernetes. We have infrastructure part and let's say the data plane part, which is which is a fleet of the clusters. You can imagine it is a production cluster, a staging environment, and so on. And for the automation, we use Ansible because we don't like the shell scripting. We love the declarative way how to Ansible declares the steps and other stuff. And also we like the libraries. For example, the Kubernetes libraries for Ansible is great. It allows you to do almost everything. Another part for the managing the clusters, we use the advanced cluster management, which is based on open source project, Open Cluster Management. We have the ability to manage all our cluster fleet. We can spawn or delete the clusters using the Hive. We can perform and control the upgrades of all our clusters, and what is really benefit for us is a central monitoring solution. We know what is happening with the clusters and so on. So let's move to the automation and deployment part. We use Argo CD. Argo CD is a GitOps tool for deploying your declarative manifest and operators. We love the native experience, which is a Argo CD operator. It allows us to simply declare the application set and create the Argo CD servers. What is also fine is the customized support and the metrics. For the running pipelines, we use a Tekton. Tekton is a cloud-native CI/CD system. All the pipelines, tasks, and steps are declared as a custom resource, so it's easy readable. It's written as a YAML manifest. You can reuse the task between the pipelines and so on. And also it's run inside a Kubernetes cluster as a pod. And the pod of the pipeline can be multi-container. So if you need, for example, the Git tool for downloading and cloning your repository, you use the Git container. If you need the Maven or Java, you use the Maven container, and all these containers shares the work files. And that's yours.
One of the crucial part of our infrastructure is monitoring. I mentioned, or David mentioned, that we have several clusters in our fleet, and each cluster hosts basically different workloads. We are tied, or in our work, we are tied to Streamzy project, and so we use it as a system under test in our workloads. And we are running Streamzy for quite a long time. We are trying to, let's say, simulate the customer environment, try to hit the problems that users could hit when the pods or the workloads on Kubernetes clusters are running for a longer time than just several minutes that we have in our end-to-end testing. To understand potential issues that could occur during the, let's say testing, but it's just running the workload. We have to have proper metrics collected and keep them for some time. To achieve that, we have set up a Prometheus instance on each of the cluster that collects all metrics from each pod that is available on the cluster. This is a great solution. However, we have a fleet of clusters, so it would be nice to have it somewhere in the central point and have it available only just at one place in, for example, one Grafana instance. To achieve that, we have Tenos instance available on an infrastructure cluster that is used as a central point for running Argo CD, Tekton pipelines, Tenos, logging, and some other stuff. Tenos itself basically communicates with each of the Prometheus instance available on fleet clusters and collect all the data from them and use it in, or store it in S3 bucket on AWS or in your specific implementation. You can use, for example, Minio for that. It's basically up to you. These data are then available in our Grafana, so we are able to check what was happening like 10 days ago, 20 days ago. It's basically up to the configuration of Tenos. I also mentioned logging. It's a very important part as well. From time to time, our operator or any different workloads that we have on our clusters basically crash. So it's very important to understand why it happens, what was happening before the crash itself. So we have to analyze the logs. Without any proper solution, it will be kind of hard to get logs, for example, for last, let's say, 2 days. And when we will observe the problem just after some time, it will be mostly impossible to get this. To achieve proper logging, let's say, schema, we use OpenShift cluster logging. It's basically orchestration that deploys a daemon set of vectors. A vector is a tool that running on Kubernetes node and collect all logs from all pods that are running on the cluster. You can also use, for example, Fluentd, which basically do the same thing. These logs has to be stored somewhere. It's a huge amount of data, so to make it working properly, we use Loki stack, which is implementation of log aggregation inspired by Prometheus. Logistack basically stores all the data that are collected by vector in S3 bucket. So again, you can use AWS or any different implementation. It's up to you. And you basically specify the data retention based on your needs. So if you want to have logs from a specific applications to keep them, for example, 1 year, you can do that. And for different application or different type of workloads, you can drop the data after 10 days, for example. It's basically up to you and up your configuration. Loki also have a native integration with Grafana and Prometheus and Kubernetes because it's developed by a Grafana team, as far as I remember. Argo workflows. David mentioned Tekton, which runs Tekton pipelines in your Kubernetes cluster and provides Kubernetes native experience to running it. Argo workflows is something very similar. It's a native engine for Kubernetes workflows, so you're able to specify a workflow with specific steps that will be executed on your cluster, or it can connect to different cluster. Again, it's basically up to you and your use case. Argo workflows allow you to trigger not just via cron, which is great. For example, Tekton doesn't have a cron, so you have to a little bit hack it with cron job. However, Argo workflows itself has cron support, but what's the most important part here is event trigger. I will talk about it in a few as part of Argo events. Each step could be executed in parallel in workflows, and you can also share the data between the containers. So you can each step imagine as a container, so you can share data. Each container can wait for results from another container. So it's basically, again, up to you what kind of workflow you want to execute. Argo workflows allows you do a templating, so you can have one template and then just reference it in different triggers with different parameters and arguments. There's also exit handlers, so in case there is a problem with your workflow, you can call exit handler and get notification to Slack, for example. As a use cases, you can imagine it as a CI/CD system, use it for infra automation or basically for machine learning. Argo events. Argo events is an event-driven automation framework. Basically, you have several parts deployed next to the Argo workflows, and you basically listen to some events, for example, from GitHub, GitLab, Slack, PubSub from Google, Kubernetes events. There's plenty of event sources that you can use, or you can extend the possibility with writing your own and just use your custom one. As part of Argo events, you also deploy Event Bus. Event Bus is used as a transport layer for events. So basically, you get an event from GitHub. It will be sent to event source that pass it to Event Bus, and then I think it's called sensor. Yeah, the sensor itself will react on the event and trigger the specific workflow based on your configuration. As an event bus, we use Kafka. More specifically, Kafka managed by Streamzy. So next to it, we also have an instance of Streamzy operator that manage our Kafka instance for these purposes. This is basically our architecture about Argo events and Argo workflows. So as I mentioned, you can see here that the Argo events, mainly the event source is waiting for some events from external sources. In that case, GitHub, Slack, Webhook, it depends. And then send the messages or the events itself to Kafka. Then there we have two sensors that react on the events that are available in Kafka. And when the event is here, the sensor consumes it and trigger the specific workflow based on the configuration. Here you can see our deployment on Kubernetes cluster. On the left side, you can see Stringy deployment and event bus, which is Kafka. We also have a drain cleaner here, which basically takes care about moving Kafka pods from nodes that are being upgraded to keep Kafka cluster up and running and operational during Kubernetes upgrades. And on the right side, you can see the deployment of Argo events, Argo workflows, and some already finished workflows that were triggered by events from GitHub.
Okay, so let's move on our overall architecture, where we will show you how the whole infrastructure is installed on the greenfield. So let's start with the first repository, which is called Automation Hub. There are stored all the Ansible playbooks and Argo CD application manifests and other configuration and tweaks. And the Deployment Hub, which stores all the Kubernetes manifest of our applications, which we test and running on production and staging environment clusters. So, firstly, we need the infrastructure cluster. We use the OpenShift, but it's a Kubernetes cluster. And on the beginning, you need to trigger the automation from the repository Automation Hub on your own laptop. So, installation process will install the Argo CD operator, Tekton, Argo workflow, and all the other stuff like advanced cluster management, logging, and monitoring. Now, ACM steps in and start to spawn the worker clusters. So the ACM using the Hive install both, in this case, worker clusters. The first one is a staging environment, let's say, and the second one is the production environment. Now the Argo CD steps in and start getting the files from the deployment hub, because the application and application sets are already in Argo in infrastructure, and Argo CD start to reconcile it. So Argo CD deploys the managed apps on the worker cluster 1 and worker cluster 2. In the next step, we have also the repositories from the Strimzy, so Strimzy Kafka operator and Quay registry, where the Strimzy Kafka operator images are pushed. Our automation in Tekton gets these changes from the repository and Quay, and if there are some changes, let's say on the main branch, it gets the new manifest and images and update files in the deployment hub, which is the trigger for the Argo CD, and Argo CD roll out the staging environment and tries to deploy the latest Strimzy Kafka operator. Tekton also contains another pipelines for the running some automation on the worker cluster and worker cluster 2. Let's say in our case right now it's an upgrade. And now you see the Argo workflow has the new pipeline, the workflow, which gets the data from the automation hub and run the installation process every time when new changes are pushed into the automation hub repository. So we don't need the first laptop for the running the whole automation, but the Argo workflow will take care about upgrading the infra cluster applications and operators for Argo CD, Tekton, and so on. And yeah, and Argo workflow also, because we need to manage, because we need also some cron trigger jobs, so we implemented some secret copy workflow, which is called periodically, and updates some secrets in workflow cluster 1, 2. And also on infra cluster. Yeah, so let's see how the Argo workflow UI looks and how it works when we push the new changes into the automation hub. So we have the Git repository, and I opened the PR, which just changed the scale of nodes for advanced cluster security. I merged these changes and opened the UI of the Argo workflow. So after a short time, the new workflow run will be triggered, and we will see that the Ansible will be run in the pod, and it's running, and I can also see the logs from the pod in the UI. So yeah, we are waiting for pod creation, and if I open the logs, I can see it. Yeah, after a while, there will be the end of the pipeline, and yeah, we will see the steps. Steps, and the not notify step, which is our notifier for the select, because we only want to see if the pipelines or workflows failed, so we want to have the notification in our Slack channel. So in case the pipeline is okay, we don't receive the Slack message. Yeah. Another short demo is about the Tecton. I will show you how it looks in OpenShift console, and how looks the pass pipeline and the successful pipeline and the failed pipeline. So the pipeline definition, as I said, is a Kubernetes manifest, so it's defined declaratively in YAML file. You can specify the container for the running the Git and for the running the rest of the steps. We use our own image because we need more tools for running, for example, this pipeline. And if I open the pipeline and UI, I can see there were the 3 steps, and pipeline was successful. This is the pipeline for updating the manifest from Streamzy in our deployment hub. And I see also that notifier step is skipped because the pipeline was success. The second pipeline is of our small test suite, which just check the application is up and running correctly. You can see the application is not running correctly. This pipeline ran the Java JUnit 5 test using the Maven. The tests are failed, and so the final task, this notifier Slack, was triggered, and we received a message on the Slack channel about it. Yeah, the notify was triggered. And the last demo is about Argo CD and the UI of Argo CD and how it changed the application after the changes in the Implement Hub repository. You can see the many applications which we have managed by Argo CD. On the left side, you can specify the label. We have label Streamzy, and also we want to filter the application which are running on the staging environment, which is the worker cluster 1. We will pick the application, the client application. It simulates the load of the messages. We have many of pods of running the simple messaging on the Kafka clusters, and we will be interested in the IoT. In the UI, you can see the old stuff. Also, you can see how the pods are spread across the around the worker nodes, and you can also see the logs and other stuff. If you click, you can see also the number of the pods and so on, which will happen right now, if I'm not wrong. I will speed up a little bit. yeah, there are the pods. So let's move to the GitHub. There is a small change. We changed the message, the IoT message. I changed the battery level from 99 to 50. And after I merge it, we will see how the Argo quickly behaves and roll all pods of the IoT externals deployment. So we will refresh the UI to see the changes. Now you can see that the application out of sync and it's right syncing. So yeah, the pods are started rolling, and it will be really fast because it's a simple application. And after that, application is up and running. All pods are running. And if I open the logs from any pod, I can see that the changes were applied, and the message is modified, and battery is on 50 level, on 50%. Yeah. You can also see that what is the latest change, and so we are always sure which changes are running on top of the cluster. And you can play basically with the view and so on. So that's it. Yeah.
Okay, now let's check how our Grafana looks like. We have several different dashboards. Here you can see dashboard that is mostly for Streamzy operator. We are filtering our existing clusters in the Grafana dashboard, so we will get the proper data from Thanos based on this label. So in that case, the cluster value is set to Scotiop Infra, and the data are about our Event Hub deployment. Next one could look like this. It's a Kafka dashboard that is provided by Streamzy. This deployment is on our worker cluster. It's one cluster from our fleet, and it's basically the latest version of Streamzy deployed as a software under test, where we play with it and check if everything is working fine in the long term. This is Loki dashboard. Loki itself provides a way for going through the logs, so you are able to specify which application or which pod should be picked, and the data will be shown in the dashboard. You can also filter the data, so in case you want to see just info log level, for example, you can very easily filter this out in our dashboard. And this is our custom dashboard about the whole infrastructure and deployed stuff. Okay, let's wrap up. We just wanted to show you that there's a lot of ways how to use great Kubernetes native projects that are part of CNCF, and you can easily manage your infrastructure and your applications with them, even in a great scale, and also in the long term. We are performing zero-touch upgrade. We have metrics depicted in Grafana, and we also didn't mention that we have configured alert manager as part of Prometheus in case there are some troubles with the applications or workloads. We'll get a notification from alert manager as well. Okay, that's it. There are some links, so if you are interested in the configuration that we have deployed in our testing environment, you can find everything on GitHub, in Scotiop organization. And that's it, and I think we can answer the questions.
Okay, I can take the first one. If you have multiple clusters in production, yeah. Okay, the second one. If you have multiple clusters in production, for example, in 20 regions, how do How do you roll out changes to be able to define strategy for it? Basically, we don't care about it in our testing environment, but there is also another project which is the Argo rollouts, and it can take care about it. So you can specify the rollout policy, and the Argo rollout will take care about it.
How do you manage multi-cluster deployment? Do you have repo for each cluster? Do you copy or somehow extend base configuration? Yes, this is part of our Automation Hub repository. We just specify there some basic configuration, like size of the cluster, which machine sets should be available on the cluster, and the scale of cluster, and Hive instance that is available on a cluster will provision the cluster and set up the configuration on it based on the info from Automation Hub. But you can definitely have the configuration stored in different repository, and in case you want to have different configuration for each cluster, you can achieve that. You can also manage it with Argo if you want. Can Argo workflows be triggered by BFU? I'm looking for some UI-friendly tool for user-triggered automation. To be honest, I'm not sure what is BFU.
Me neither.
Okay, that's great. I don't think so. You have to have some event or cron defined to trigger Argo workflow.
No. You can trigger it from the UI. Yeah, it's possible. Just trigger it from the UI, and yeah, it's like a Jenkins or other systems where you can click on the pipeline and it's running.
Can Argo workflows events be used also for generic event-driven processing and workflow execution, or can it be used only for GitOps and kube management? Definitely we can use it for everything you want, not just for GitOps and kube management. It's just our use case, basically.
And we are also running the testing pipeline on it, so for us it's a replacement for Jenkins, for example. Okay, so if there is no other question, thank you all for the attention.
Thank you, everyone.
Raz, dva. Dobre, asi začnem. Tak ahojte, vítam vás na mojom talku, ktorý sa volá It's Always DNS. Neviem, či sa to tam zjaví, alebo nie. OK. Chcel by som vlastne, toto bude téma, ktorá bude trošku smutnejšia ako iné. Chalani z Labyrinth Lab sa ma pýtali, že či mám nejaké smutné príbehy s touto témou, tak áno, myslím, že viacerí z nás máme smutné príbehy s DNS-kom. Ale prečo DNS, prečo som si vybral túto tému? Lebo toto tričko. A toto tričko som dostal, lebo som si prežil nejaký príbeh s DNS-kom, čo ma donútilo vlastne sa na to pozrieť a rozobrať si to a trošku to pochopiť. Ono, keď sa povie DNS-ko, tak človek si predstaví, že je to celkom nuda, ale no nie. To vám a snať dneska pochopíte, že asi aj prečo. Ale v prvom rade nie len DNS. Nie je to stále len DNS, niekedy je to aj BGP. Vlastne, a prečo? Lebo celý náš technologický svet je zlepený žuvačkou a polepený páskou. A tá žuvačka je DNS a tá páska je BGP proste. Ináč o BGP bude rozprávať Rasto z Valentu po obede, takže si môžete urobiť také bingo. Takže si dáme teraz DNS-ko. Ale moje meno je Zdeno Vrabel, pracujem ako konzultant vo spoločnosti, rakúskej spoločnosti ByteSource. 110% môjho pracovného času trávim v Go. Občas si nájdem čas a napíšem niečo o kontajneroch. A keby som neprogramoval, tak spájam kabliky. Čiže to som skrátka ja, ale poďme vlastne, urobíme si taký warm-up, lebo keď chceme hovoriť o stromoch, tak najprv treba vidieť les. Myslím, že toto nikomu akože nebude cudzie, ale preventívne. Čo je DNS a aká je pointa? Máme nejakú domenu, vlastne je to telefónny zoznam internetu. Tak to nejakým spôsobom začalo pred 40 rokmi. Point of DNS je preložiť niečo zmysluplné, čo mu rozumieme, na nejakú IP adresu. Vlastne domenu na IP adresu. A táto domena, asi všetci poznáme takúto domenu. Je tu však jeden zadrhel, maličký zadrhel. Keď si z toho celého toľku odnesiete niečo, tak chcem, aby... Dúfam, že si odnesiete tú poslednú bodku na konci, ktorá je nenápadná, ale veľmi dôležitá. Táto bodka sa volá root. Vlastne, keď sa resolvuje DNS-ko, to je miesto, kde sa začína. Toľko k domene. A teraz, ako sa... ešte, aby sme si... Keď budem používať nejaké slovo, tak FQDN je vlastne... Tá domena s tou koncovou bodkou, volá sa to Full Qualified Domain Name. A väčšinou, čo my poznáme, tak poznáme tzv. Partial Qualified Domain Name. No a už keď tu máme takto rozobratú domenu, tak tá posledná vec, to com, EU a neviem, čo to volajú, že top level domain. To sa volá top level domain. To je skrátke v domene. A ako to celé funguje? Máme nejakého klienta, my chceme si pozrieť, že www.google.com alebo mycompany.com, to ide na nejaký DNS server, ktorý sa volá resolver. Je to recursive resolver a ten za nás vlastne čo robí? On sa pozrie na tzv. Root server, to je ten, ktorý rieši tú bodku, že poznáš túto vlastne domenu, on povie, že nepoznám, ale poznám .com a odkáže vás na ďalší server. To sú tie tzv. TLD servery, ktoré vám zase povedia, síce áno, toto je com, com domenu, alebo ten TLD, a on vráti vlastne server, na ktorom by už mal byť, že company.com. A to sa volá, ten posledný step je vlastne autoritatívny server, kde už je potom tá samotná domena, akože tá IPčka pre tú samotnú domenu. Tá vráti vlastne IP adresu, resolver zase prepošle tomu klientovi a to je vlastne princíp. Toto je vec, na ktorej stojí internet 40 rokov a v podstate nič sa tu veľmi tragicky nezmenilo. A je to vec, ktorá funguje veľmi dobre, povedzme si. No, veľmi dobre. Keď sa riešil Kubernetes, alebo vlastne nielen Kubernetes, ale keď prišli do mody všetky tie dynamické infraštruktúry, kontajnery, ale celý ten šialený svet, tak vlastne trebalo riešiť nejakým spôsobom aj service discovery. No a práve tí otcovia toho Kubernetu vlastne, keď si povedali, že service discovery, tak si povedali, nebudeme vymýšľať kleso a použijeme DNS-ko na to. Ešte jedna vec. Ten resolver server má takú moc, že keď máte nejakú internú doménu alebo čo, tak vlastne on to vie nejakým spôsobom, keďže je to taký man in the middle, tak on to vie nejakým spôsobom redirectnúť na niečo. Buď vám tú adresu, nejakú tú internú adresu, ktorá nie je zo sveta, vie resolvnúť, alebo to prepošle na nejaký ďalší autoritatívny server, ktorý je dedikovaný pre danú zónu. Tak to vlastne fungujú tie private hosted zóny. No, a ako som hovoril v DNS, vlastne v Kubernetes, keď riešili Kubernetes, si povedali, že DNS je dobrý spôsob, ako riešiť service discovery. Čiže ja mám nejakú službu traffic a keďže ten Kubernetes je veľmi dynamické prostredie, tak vy potrebujete riešiť nejakým spôsobom, že IPčka, aby to vrátilo nejakú IPčku, ktorá je zmysluplná. Čiže na to máme v tom Kubernetes svete vlastne existuje nejaký KubeDNS, ktorého rola je vlastne resolvovať tieto interné veci. Je to trošku modifikovaný obrazok toho, čo som vám pred chvíľou ukázal. A funguje to takým štýlom, že pody, keď potrebujú nejak akože pristupovať k nejakej službe, tak všetky tieto DNS požiadavky posielajú na KubeDNS, dneska je to najčastejšie Core DNS. A ten povie, dobre, toto je požiadavka, ktorú viem ja resolvnúť, že ja mám túto službu, napríklad moja služba .svc.namespace.cluster.local. Alebo je to niečo, čo potom ďalej preposielam na resolver. Nejaký upstream resolver, záleží zase. Či ste v cloude, tam to rieši AWS, GCP za vás, alebo keď ste on-prem, tak máte nejaký svoj vlastný. Toto je taká akože pointa v rámci toho Kubernetes sveta, ako to tam je. Veľmi primitívne, jednoduché. No, jednoduché. Poďme sa však pozrieť, ako to je vo vnútri toho podu. Aplikácia, keď potrebuje resolvnúť nejakú doménu na nejakú IPčku, tak to vlastne robí cez taký tzv. Resolve.conf súbor, ktorý je v tomto prípade veľmi zaujímavé miesto, kde sa oplatí pozrieť. Čiže aplikácia skôr ako získa tú IPčku, pozrie sa do Resolve.confu a to sa vlastne nejakým spôsobom resolvne. Podľa toho sa zariadi. A tento Resolve.conf vlastne je injektnutý práve Kubernetom pri vytvorení kontajnera. Čiže tam máte vlastne tú informáciu, že choď na ten KubeDNS. Dobre, chvíľočku. Raz, dva. Tu si urobíme malú ukážku, ako to vlastne v takom klastri vyzerá. Ja tu mám... Vlastne mne tu bežia dve pody. Ja sa exeknem do jedného. Dobre. A čo sa udeje? Ja napríklad chcem www.google.com. Vlastne to je ako keby moja aplikácia robila. V podstate dostanem správnu IPčku. Ja chcem ns lookup traffic kube system. Vlastne chcem resolvnúť IPčku, ktorá je v rámci môjho klastra. Opäť. Získavam IPčku, ktorá je interná. Čo tu však nevidno, je taká vec, keď sa pozrieme do etc resolve, áno. A tuto začína byť zaujímavé. Myslím, že name server netreba predstavovať, je to IPčka toho core DNS, kde sa vlastne request pozrie. Ale je to taký, že search a je tam niekoľko domén. A vlastne čo to znamená? Znamená to, že my sme vlastne použili nie full qualified domain, ale tzv. Partial domain a ono, čo nebolo vidno, tak to si hneď ukážeme. Teraz to začne byť celkom zaujímavé. Takto. No, tento výstup je trošku dlhší, ale je z neho pekne vidieť, že ten request nebol jeden. Totiž to, čo to spravilo? To, čo som ja dal hľadať, že www.google.com, keďže som použil tzv. Partial query domain name, tak on to začal lepiť ku každej vlastne tej search doméne. Čiže urobil www.google.com default svc cluster local. Nevie nájsť, ide ďalej. www.google.com svc cluster local. Ide ďalej. A tak toto ďalej ide, urobí asi 4 alebo 5 requesty, a ktorý až posledný to resolvne, lebo urobí vlastne question www.google.com, až vtedy to resolvne. Čiže teraz tie aplikácie, ktoré dneska máme a robia milión requestov na rôzne milión servisov a potrebujú každý connection vlastne vytvárajú DNS požiadavku, 4-krát alebo 5-krát sa zduplikuje vlastne DNS request a to sa posiela na nejaký core DNS, ktorý beží v rámci klastra, ktorý to musí resolvnúť. Čo je trošku moc. Aby to nebolo jednoduché, tak sa pozrieme, ako to je v cloude, tak cloud providery si tam ešte docapú svoje, aby neboli 4, ale aby boli 5. Napríklad toto je z EKS, kedy vlastne tam cloud provider vám ešte docape nejakú EU West Compute Internal. Toto je z GCPčka, ktorý tam dočape ďalšie 3, aby ich nebolo málo. Taký maličký parameter options n.5, o tom si ešte povieme. Výsledok je, že aplikácie robia hromadu requestov, DNS requestov na core DNS. A keď sa pozrieme na tento obrázok, vlastne zistíme, že každý ten request je vlastne nejaký paket, ktorý musíme posielať niekde na nejaký úplne iný node, vrátiť sa a teda. Zistíme, že vytvorenie connection nie je také lacné, sú tam nejaké latencie, potom, že máme zahltenú sieť a podobné veci. A aby to nebolo málo, tak z toho vzniknú potom ešte ďalšie zaujímavé problémy. Ale preto vymysleli nejaký node local DNS. Vlastne autori z Kubernetu prišli s takýmto riešením, kde si povedali, že OK, my tam strčíme niečo na ten lokálny node a čím eliminujeme vlastne tú komunikáciu skrz na skrz, aby sme nezahlcovali ten core DNS alebo ten kube DNS. A je to vlastne zabalený tiež core DNS, ktorý je nakonfigurovaný takým spôsobom, že tie interné veci, pre ktoré cluster potrebuje, napríklad ten trafik, ako ste videli, tak ho pošlem na core DNS. A napríklad www.google.com pošlem napríklad na resolver toho cloud providera, alebo to, čo máte tam. Veľmi zaujímavým spôsobom je, ako to riešili, a riešili to cez REST IP tables. To znamená, že v tom resolve.conf sa nemení žiadna IPčka. Stále je to IPčka vlastne toho core DNS, ale na tom node je proste pravidlo v IP tables, ktoré povie, že táto IPčka nech nejde na ten resolver, ale nech ide lokálne na node local DNS. A toto má celkom akože zaujímavé, tam je ešte pár zaujímavých vecí, ktorými vlastne vyriešili. Preto keď sa pozriete do etc resolve, tak síce tam máte node local DNS, ale vidíte tam stále tú IPčku toho core, toho resolvera, ktorý je niekde na mastri alebo niekde. Toto je zaujímavé miesto aj riešiť caching. Proste, že to začne cachovať, lebo na čo budete preposielať všetky tie requesty ďalej. To DNS-ko, to je taká obľúbená vec, že keď je requestov veľa, tak tam strčme cache, bude ich menej. A cache je taká zaujímavá vec, že ono to je strašne dobré riešenie na začiatku a potom zistíte, že invalidovať cache je celkom triky. A podobne to funguje aj tu. Čiže keď pod chce urobiť nejaký request, potrebujem takúto doménu, tento resolver to bude ten node local DNS, on to pošle na nejaký ten upstream resolver, ten mu vráti IPčku, local DNS to zakešuje a pošle naspäť. Ďalší request vlastne pôjde takisto, akurát, že resolver, vlastne ten node local DNS to má nakešované, tak to vráti. Super. Problémy sú, že keď sa tá IPčka zmení vlastne nejakým spôsobom dynamicky, tak máte tam nejaký timeout a invalidovať. Čiže môže sa stať, že vám vlastne vaša aplikácia dostáva IPčku, ktorá už v klasteri napríklad neexistuje. To je ten menší problém, lebo dajme tomu, že vieme žiť s tým, že dobre, nastavíme tú invalidáciu na nejakých 10 sekúnd alebo 5 sekúnd a tolerujeme mu to. Problém, na ktorý som natrafil, je NX domain. NX domain je návratová hodnota DNS resolvera, keď povie, že doména neexistuje. A čo vtedy vlastne ten resolver môže urobiť? Zase depends on configuration. Vy sa opýtate na doménu, ktorá neexistuje, resolver to prepošle na upstream a upstream povie NX domain. Takáto doména neexistuje. Lenže žiadny cache, vlastne toto ide mimo cache. Ďalší request znamená to isté. Čiže zase vlastne vy tento request prepošlete na upstream. No a veľa problémov, fakt skutočne veľa problémov nastáva vtedy. Toto, aby fungovalo, to sa volá vlastne v tej konfigurácii, keď budete volať alebo hľadať, aby to fungovalo dobre, aby sa cacheoval NX domain, to sa volá tzv. Negative cache, viete to nastaviť. Problém, nastavíte príliš veľkú, napríklad 900 sekúnd, zase, ako služba tam už bude, aplikácia o nej nebude vedieť, lebo stále bude mať nakešované. To je proste problém invalidácie cache. Keď ju tam nemáte, ono to takto prebúble. No. Teraz ako si vybrať z toho, Ďalší problém z tohto vychádza, vrátime sa k tomu obrázku, že čo sa stane, ak ja urobím, že www.google.com, ono to odpáli asi tých 10 requestov, z toho polovica ide vlastne napríklad na Google, tie interné domény. www.google.com.google internal neexistuje, čiže vráti NX domain. Prvý request prebehne cez node local a pôjde na upstream resolver. Ono to vráti pekne NX domain, node local o tom nič nevie. Ďalšie 3 requesty prídu a zase. A takto to funguje vlastne. Čo vám sa stane, alebo čo je také typické práve v cloude, je, že tie resolvery, tie upstream resolvery, alebo tie cloudovské resolvery, oni majú často nejaké limity. A vy ani neviete, jak a hitnete ten limit. A veľmi škaredo a veľmi vtedy, keď ho nepotrebujete. Čo sa stane? Side effect je to, že okrem Google servisov, vlastne Kubernetes servisov, my používame často aj nejaké iné servisy, napríklad databázy, ktoré sú manažované Googlom a teda. A zrazu sa dostanete do stavu, že vidíte, že vaša aplikácia ide, nejde. A práve connectiony na databázy a na tieto externé služby, respektíve služby cloud providera vám začnú vypadávať nejakého dôvodu. A robí to random. A to je len kvôli tomu, že vlastne ten NX domain nie je nakešovaný. Naopak, keď ho nakešujete, zase máte iný problém. Čiže je to také... je to trošku alchymia. Tu neexistuje žiadne dobré riešenie, by som povedal. Tá bodka, ktorú som vám na začiatku ukázal. Ak tú bodku dáme k vlastne tej domene, vlastne celé to resolvovanie funguje tak, že on pôjde rovno na resolver iba s jedným requestom a to si hneď môžeme aj tu ukázať, že keď ja urobím tak môžete vidieť proste, že ten request je len jeden a ide tam, kde má. Čiže ja tam neposielam 10 requestov na to DNS, ktoré nejakým spôsobom musí sa vyhalúziť z toho. Chcieť zase, áno, vošiel som do takého problému, proste, kde sme sa s developermi, ako moje riešenie bolo, dobre, tak používajte FQDN. A developeri na to, ale my to máme naharkodované všade. Akože, nemôžeš chcieť od nás proste, že budeme prepisovať teraz hromadu kódu, to je bežná situácia. Možno ste si všimli, je tam jeden ten parameter, o ktorom som už niečo povedal, ten n.5. n.5 je veľmi zaujímavý parameter v tom resolve.conf, ktorý vám povie, že od koľkých bodiek vlastne pri tej domene, od koľkých bodiek to už považujú za tzv. Full qualified domain, aby som tam nemusel hardkodovať. Čiže jedným z riešením môže byť Jedným z riešení môže byť, že vlastne do podu pridáme niečo také. DNS config, options, týmto vieme vlastne ovplyvniť ten resolve conf, name and dots a dáme 2. To číslo je zase alchymia, záleží, čo má vaša aplikácia nahardkodované. Neexistuje žiadne, že toto urobte a bude to fungovať stále, bohužiaľ. A výsledok tohto vlastne je, to dám takto. Aby ste si nemysleli, že keď sám resolve conf. Áno, vlastne tá konfigurácia sa mi pretavila do resolve confu a teraz keď urobím ns lookup debug. www.google.com, kde mám vlastne tie dva, kde som naplnil tú pointu tých 2 bodiek. Bez toho, aby som dal tú poslednú bodku, krásne mi to vystrelilo vlastne jeden request. Samozrejme, keby som dal len google.com, zase to robí to isté. Zase, keď tých bodiek bude veľa, akože dáte n-dot späť, alebo takto. Nie je tam zase dobré riešenie, ako ideálne riešenie, že toto vtedy bude fungovať. Lebo môžete si napríklad odpaliť interné domény, hej. Je to také, no. Treba vedieť, čo tá aplikácia robí, ako to tam je nakodené a teda, no. Tak zo všetkých tých riešení žiadne nie je dokonalé. Takže tak, to je vlastne resolve conf. Asi jedna z tých najdôležitejších vecí. A áno, node local DNS je veľmi zaujímavá vec a keď sa lepšie do nej pozriete, vlastne uvidíte nejaký takýto log, čo mňa tam celkom zaujímalo. Ináč, kedysi dávno som riešil nejaký úplne iný problém, ja sa k tomu ešte vrátim. A vlastne, ako som hovoril, node local DNS setupuje nejaké IP tables. Tu zase 2 problémy môžu byť. Dnes máme rôzne moderné cény, ktoré vyrábajú vlastne, ktoré sa snažia tie IP tables nejakým spôsobom obchádzať ako Cilium. Máte nejaké kube proxyless a teda. Node local DNS, keď vám tam nasype IP tables, tak môže sa stať, že vám prestane node local DNS vlastne fungovať, lebo tá IP table nezafunguje. Lebo napríklad Cilium v kube proxyless mode úplne obchádza tieto veci. Hej. Na to treba tiež, vlastne to je ďalší spôsob problému. Hej. Ale čo je ešte zaujímavejšie, toto bol starý problém, ktorý som akože dlho nechápal a vlastne keď sa začal používať node local DNS, tak zmizol nejakým spôsobom. Je vlastne, že sa tam dáva tzv. No track. A nikdy som tomu nerozumel a až potom nejak svitlo, že contract. Neviem, koľko z vás poznáte contract. Je to v Linuxe, jadre, celej tej halúzy. Je to taká tabulka, ktorá si drží stav ku každému connections. Ono tým, že vlastne chceli, aby to bolo, vlastne tí autori, aby to bolo, jak to povedať, protokol agnostik, tak sa ten contract vlastne drží jak pre UDP, tak pre TCP protokoly. A vieme, že DNS cez UDP to je veľmi jednoduchá vec, to je request sem a respondence naspäť. 2 pakety, to je všetko, hej. Lenže tento kontrakt sa začne naplňať tým, že vlastne my vystrelujeme tieto požiadavky. Side effect je taký, že zrazu začnú vypadávať pakety. Toto som v produkcii, priznám sa, nevidel. Trafil som na to pri performance teste na nejakom environmente a dlho som tomu nerozumel a som si povedal, dobre, asi nejaký limit, hej. Ale pointa je, že vlastne bol to contract. A ako som hovoril, toto je veľmi populárny obrázok, vlastne ako vyzerá ten netfilter a celé to v kerneli. A tie také šedé, čo tam vidíte, také tie bodky, to je vlastne ten contract. A na to, aby nátko fungovalo, aby to vlastne fungovalo, tak cez ten contract musíte prejsť. A node local DNS toto vyriešil tak, že vlastne v IP tables nastavil vlastne ten node track. Čiže kernel povedal na UDP 53 ignoruj vlastne celý ten contract. A toto vyriešilo pomerne dosť veľa problémov, ktoré sa tak tiež náhodne vyskytovali. Čiže contract. Ináč, keby tu bol niekto z Cloudflare, tak on by nemal tričko It's Always DNS, on by mal asi tričko It's Always Contract, lebo oni tam furt hitujú tieto limity. To je vlastne výpis, môžete si pozrieť, ako je ten kontrakt nastavený. Väčšinou o ňom sa nemusíte starať, lebo je pomerne štedrý, on sa nastaví podľa toho, aká je ramka a teda, ale práve to UDPčko, to spôsobí to, a ešte to, že ako je tam nastavený ten kontrakt, že on si to drží, ten stav toho connection, napríklad 180 sekúnd, čo je príliš veľa, tak to zaplníte raz, dva. Myslím, že v novších jadrách je to práve riešené, že ten čas je nižší a boli tam aj nejaké race conditions. Ono sa to dosť fixuje a dosť sa to posúva, ale stáva sa. Node local DNS rieši tento problém celkom elegantne. Posledný taký zaujímavý problém je, že vlastne tie aplikácie, keď potrebujú IP, vlastne vytvárame nejaké spojenie na nejakú restovskú API. Celý ten pseudokód by sa mohol napísať takto, že vlastne celé, a to je úplne jedno, skoro asi aký language používate, ale v pozadí sa urobí niečo také get addr info, funkcia, ktorá vlastne má resolvnúť Google.com na nejakú IPčku a potom sa vytvára socket. Get_info nie je systémové volanie, to znamená, nie je služba kernelu. Je to funkcia, ktorej implementácia je v libce knižnici, ktorá je asi v každom jednom imidže. Problém je, že tie implementácie sa môžu líšiť a majú rôzne dopady potom na to. Myslím, že asi taký najznámejší problém je, že už sa to fixlo, ale keď ste mali nejaké takto, libce nie je niečo, čo je štandardne, keď akože máte kontajner, ale on prichádza s imidžom, čiže veľmi rýchlo vpahnete do problému, že tieto kontajnery idú, tieto kontajnery neidú, lebo libce sa tam môže meniť. Niektoré tie base image používali napríklad musl libce, čo je trošku iná implementácia, niektoré štandardné libce, niektoré neviem čo proste a veľmi záleží od toho, čo to tam je, ako to tam je, lebo od toho sa odvíja aj to chovanie. Čiže môžete mať, že kontajnery sa správajú s tým DNS-kom rôzne. Takisto get_info má niečo také, že hints a tam môžu ísť rôzne flagy a je dobre o tých flagoch vedieť, lebo napríklad je flag, ktorý vám zduplikuje requesty, keď máte tzv. Dual stack IPv4, IPv6, lebo on začne posielať aj IPv4, aj IPv6. A to je dobre si pozrieť napríklad, ako dané frameworky alebo tie jazyky implementujú túto metódu. Ona je dosť taká low level a väčšinou k nej neprídete, ale myslím, že aj tu nás Čiech nejaká, som čítal na blogu nejakej firmy, že oni mali zase opačný problém, kde framework vlastne tam nanútil, že posielaj aj IPv4, aj IPv6 requesty, mali čisto len IPv6 stack a vlastne DNS im prestalo fungovať, lebo oni posielali IPv4 requesty. A pointa bola, že chyba bola vlastne v tom frameworku, ktorý využíval a ktorý to tam mal nahardkodované nejakým spôsobom. Čiže, hej. Takže keď si to, tak keď zoberiete všetky tieto pekne problémy, ako sa riešia a teda, tak si môžete urobiť takú rekapituláciu a vlastne to dá celkom taký dobrý obraz o tom, ako ten DNS request vlastne žije v celom tom systéme a to je, samozrejme, začína to niekde v kóde, nejaká aplikácia, moja aplikácia, môj kód chce sa pripojiť niekde. Ten volá get_info v rámci aplikácie. Get_info ide do resolve_confu. Resolve_conf samozrejme v tomto prípade vlastne vygeneruje pakety, ktoré musia ísť do kernelu a riešiť sa cez IP tables. Tam sú prerutované napríklad na ten node local DNS, môže to byť core DNS, whatever. Keď je to interná domena, node local DNS je dobre nakonfigurovať, ale myslím, že defaultne je tak nakonfigurovaný, že on ho zabalí do TCP takto. Medzi aplikáciou a node local DNS je UDP a medzi node local DNS a kubedns už je TCP spojenie, čo má niekoľko výhod. TCP je viac reliable, tých spojení, tam ten kontrakt už mizne a teda. Nevyštvárate toľko requestov. Samozrejme, toto je pre prípad, keď je to nejaká doména v rámci klastra a keď to nie je, tak vlastne ten ide node local DNS ide na resolve_conf toho nodu a tam sa podľa toho zariadí, samozrejme, môže ísť na ten upstream resolver. Alebo ten taký default, keď si zoberete väčšinou default, cluster to má vyriešené tak, že vlastne ten resolve_conf sa odkazuje na ten kubedns, čiže nejaký ten v klastri a ten ide na resolver. Také zaujímavé lesson learned z tohto. Veľmi dôležité, čo aspoň mne sa... To sú moje lesson learned. Ja verím, že každý, kto si prešiel s DNS-kom, má svoje lesson learned, lebo to je... Nikto nenosí tričko I love DNS. Všetci nosíme depresívne trička s DNS-kom, čo sme sa s tým stretli. Veľmi dôležité limity, aké vám cloud providery dávajú. Tie limity skôr či neskôr človek si myslí, že sú štedré, ale nie sú štedré, keď to tam 6x, 10x duplikujete. V GCP je to 1500 queries per second, tuším, v AWS-ku dokonca treba dávať pozor, lebo oni majú limity aj na TCP, kde pre TCP je to 1024 paketov. Problém je, keď už nič, tak vložiť tam tú bodku, tú malú nenápadnú bodku je super nápad. Akože vždy je to dobrý nápad. Nie je to ideálne, nevždy sa to dá, potom sú už len iné riešenia, nevždy ideálne, ale tá bodka vie veľa pomôcť. No a Takto, prevádzkovať Kubernetes znamená prevádzkovať DNS. To je proste, to aj... Na začiatku ja som si stále myslel, že dobre, chcem Kubernetes, tak čo poviete tým zákazníkom alebo tým ľuďom, že pripravte sa, že potrebujete monitoring a teda. Ale dnes by som povedal, chcete prevádzkovať Kubernetes, majte nejakú DNS stratégiu, proste majte to vyriešené, lebo ono ani v tom cloude, že mám nejaký Route 53, to nie je úplne easy, hej. Áno, v rámci jednej VPCčky je to easy, potom príde viac VPCček, viac tímov a teda tam to DNS vie byť, akože DNS je fajn, vyzerá jednoducho, ale je challenging. Hej. Čiže máte nejakú DNS stratégiu a to je pre Kubernetes, keď chcete ten Kubernetes riešiť, lebo on vygeneruje strašne veľa requestov, je super. Takže to je v podstate, neviem, jak som časovo na tom, ale super. Takže to je DNS-ko. Je to jak teplá voda v dome. Pustíte koutík, ide super, nesriešim a v momente, keď sa niečo tak zistíte, že tu je nejaký výmenník a tu je nejaká akože kumulačná nádrž a neviem čo, proste je to tak ako. Takže to je za mňa v podstate všetko. Sú tu nejaké aj otázky. Pri nastavení Windows 2 interné adresy, čo majú majú dve tečky. Takže, jak zvládne DNS resolvovať pri nastavení Windows 2 interný adresy v sobe majú dve tečky. No a to je presne ten problém, ktorý som hovoril, že Windows 2 nie je univerzálne riešenie, ináč by ho tam dali. Jasné, neresolvne to. Respektíve ono to pošle, veď to si môžeme aj skúsiť. Ja mám presne aj dve tečky, ne? Hej. Traffic, SVC. Neviem si vymyslieť takú doménu. Namespace. DNS. A teraz SVC, nie? Uvidíme, čo to spraví. No. Overte si to. Neviem, či som to správne napísal, ale výsledok je takýto. Čiže to je prvá otázka. Prosím? Sorry, hej. Cube, sorry. Človek je nervózny, tak to vyzerá. Kubernetes, SVC, dáme. Kubernetes.s... Ako? Takto, nie? Bože, kto vymyslel tie domény? Hej, ale je to. No tak to úplne išlo tak, kde? No, hej. Keď som správne, ale overte si to, lebo tu halúzim, takže. Ale teória hovorí, že to je ten problém, to je ten case, kedy to nebude fungovať. Split brain, split horizon DNS, reasonable, alebo back practice. Jak vnímate split brain? Ježiš, nedávajte ťažké otázky. Pointa je, ako to je riešené, ako split horizon DNS, na akej úrovni je riešený. Videl som elegantné riešenia, kde to riešili napríklad na node local DNS. Je to akože zvláštne, ale typek tým napríklad pomohol pri migrácii, kde išiel na legacy infraštruktúru, celkom zaujímavé riešenie. Videl som, neviem, väčšina asi z ľudí, čo robia cloud, EKS a teda, tak to budú riešiť práve Route 53 a teda, lebo tam to je dobré riešiť. Takže to je také, že neexistuje dobrá odpoveď. To sú vždy najhoršie otázky. Jen ze zaujímavosti skúšenosti, v relatívnom resolvovaní, úplne jednoduchý resolve, tak vždy použití v Ak niekto vie, ako toto vyriešiť, bez toho, aby som musel prekompilovať zdrojové kódy Kubernetu, tak asi by to bolo fajn. Neviem, či toto tiež nie je jeden z dôvodov, prečo node local DNS to robí práve cez IP tables. input tables. Ináč, local DNS je core DNS, on má takú vec, že autopad, ktorý by to teoreticky vedel fixnúť, ale veľa ľudí rieši to potom, že riešia OOM. Ten autopad, to je plugin do core DNS, ktorý by mal akože zobrať tých veľa domén a urobiť to ako z toho jednu. Problém, čo som videl, že potom ten core DNS začína byť, ako ten node local DNS začne byť dosť memory hungry, až to skončí OOM. Jak funguje Kubernetes reverse resolvovanie? A toto je presne otázka, ktorú som si sám položil dokonca 2 dní dozadu a úprimne nemám ešte na to odpoveď. Ja som toto ešte nepotreboval riešiť. Niekto je na to Zookeeper. To je asi preto, že ja som tak sa obišiel Zookeeper, ako som len vedel. Však odpoveď neviem, je tiež odpoveď, nie? Pardon, to by trebalo fakt ako vyskúšať. Ale takto. Malo by to vybublať na upstream úplne. Takto. Ak používate node local DNS, jeho konfiguráciu viete zmeniť k obrazu svojmu. Je to core DNS, viete si to vyriešiť aj tam. Takže viete si to vyriešiť na kubedns, jeho konfiguráciu viete zmeniť. Viete si to vyriešiť na rôznych miestach rôznou konfiguráciou. Preto je to asi tak ťažké, že neexistuje žiadne univerzálne pravidlo, lebo je veľa miest, kde sa to dá dosiahnuť a záleží na tom use case. Nepoznám správne riešenie, ale určite by som sa pozrel na tieto miesta ako v konfigurácii. Takže tak. Takže ďakujem.
Hello, everybody. Hi. I hope you had a good lunch and you are full of energy for the panel that will follow. We have a very interesting collection of experts in various areas that we'll be talking about. I will ask them to introduce themselves. The topic of the panel is the platform engineering and everything around it. We'll be talking about what is platform engineering, what are its relations to the DevOps, what are the differences, what is new, what is old, about the challenges, about balancing act of security cost, and about some techniques. So without further introduction, I would ask my panelists to introduce yourself. You first, please.
Hey. Hey everyone, glad to be here. My name is Dotan Horowitz, and I'm the principal developer advocate at logs.io, which is a vendor in the DevOps observability space, like providing Prometheus, OpenSearch, Jaeger, OpenTelemetry, and so on as a managed service. I'm also a CNCF ambassador, so if anyone has any questions about the CNCF ecosystem, cloud native and related, also happy to chat afterwards. And I have a podcast on open observability talks if you're into DevOps observability, and also platform engineering. So that's me in a nutshell.
Thank you, Dotan. Hi, I'm Anton Weiss, or people also call me Ant. And if you've written Java 10, 20 years ago, you'll appreciate that. Because once upon a time, there was a build tool that was called Ant. And what do I do? Okay, I've been in the industry for more than 20 years. I started out in coding, in development, and then I went into that gray area doing integration stuff, configuration stuff, release engineering. For a long time, they didn't have a name for it. And then a bit more than 10 years ago, Patrick Dubois invented the word DevOps, and suddenly we all realized that's what we're doing, right? And that's what I've been doing for the last 10 years as a consultant, helping organizations to optimize the way they deliver software, and that's basically what platform engineering is about, right? And right now I'm working with an exciting startup called PerfectScale that does, again, optimization, but specifically for Kubernetes platforms. And we have a talk tomorrow about load testing workloads on Kubernetes with K6. And of course, I also have a podcast that's called DevOps Shorts. Each episode is only 15 minutes long, and I only ask 3 questions, and one of them is about the future. And I think this is a question that's very relevant for all of us, so give it a listen.
Thank you. Hey guys, my name is Jakub Stehlik. I guess I'm the most junior guy here. I've been a DevOps / cloud / platform / buzzword engineer for the past 8 years, ever since university, basically. And right now, I'm working with a really cool company called Labyrinth Labs. We are basically a one-stop shop for cloud, DevOps, and Kubernetes. We help people set up their cloud environments, set up observability, CI/CD, and everything related to DevOps in their cloud environments. And for that, we have a platform called Lara, or Labyrinth Labs AWS Reference Architecture, which helps us to quickly deploy new environments and easily manage it without much operations and too much hassle.
Hi guys, my name is Denko Vrabel, and basically I'm a consultant, senior consultant, what is different name for engineering fluktulant, let's say. But my previous experience is very close to software engineering, programming, but also administering and supporting and maintaining production systems. And also, yeah, I spent some time in this role of platform engineer, yeah, basically. And here I am. And
thank you very much. So our first topic, I would like to clarify. We are talking about platform engineering, which is kind of a new term with not so new content. If you look back, there was this thing called DevOps that was saying pretty much the same thing as what platform engineering is being described these days. So our first topic would be, what is your opinion about what is the actual difference between what we call today platform engineering and what we used to call DevOps? Is there any difference at all? Does the platform engineering bring anything new, or is this just kind of a rebranding of the old stuff? This is a very interesting topic because there are many people with many opinions and many discussions on the internet. So
I forgot to mention, but I have a talk later today at 4:15, which is on this topic of platform engineering and actually about the question of whether it's a real thing or just a rebrand, the fancy rebrand of DevOps. So you're all welcome to join the longer answer today at 4:15 in the other room, 155. But I'll tell you in a nutshell, a teaser for my lecture. I don't treat platform engineering as a separate thing. I think the way that I explain it to people is the following. So we all know DevOps, right? And so DevOps creates tools, creates processes, creates best practices to improve our lives and create automation and things like that. Platform engineering essentially takes these tools, processes, and best practices and productizes them and provides them as services, essentially, for engineers to consume uniformly across the organization. So it's the evolution of DevOps, or if you look at the DevOps standard maturity model that you usually see in books and so on, so it's defined, managed, measured, and optimized. And when you get to these more mature stages, when your organization grows, matures, and scales, and you're in the measured and optimized stages, that's where you'll see when you have multiple teams, multiple product teams, multiple business units, lines of business, and product lines, and so on, then you'll see the need for this productization of DevOps. That's in a nutshell.
Any different opinions? Not a different opinion, of course. Like, Dotan knows his stuff. I think I have a definition. Like, so platform engineering is a method of doing DevOps at scale. Basically, I think that's what Dotan was saying in one sentence. I totally agree with everything
I like that.
Said.
Definitions are good.
Yeah. Yeah, in general, it's an option, okay? Is it the best option of how to implement this at scale? We don't know yet. But right now, it's a discipline that allows to do this, and it's developing, and we'll see what it grows into. I guess this is the idea.
Well, pretty good explanations, guys. Like, this is pretty much the opinion I have. I have two opinions about DevOps and platform engineering. The first is that it's a bloody buzzword. Like, over my career, I've been a cloud engineer, cloud specialist, or whatever we called it. I've been a DevOps engineer, I've been a platform engineer. I've been basically doing the same thing. So, in a way, being a platform engineer or platform engineering from the job point of view is kind of a fad. It's like a new thing. But as Dotan explained, it's a beautiful evolution of DevOps. Like when DevOps came up, DevOps engineers started to create their own tools, and suddenly they realized, hey, we can actually standardize it and we can make it into a product or platform, and that's how platform engineering came up. So they're the same, but a bit different, maybe. So I agree there's an evolution, mainly.
Can I challenge you on that, just to make the panel more interesting? I want to challenge that.
Let's do it.
When I look at platform engineering teams, I don't see that as, okay, DevOps, as you said, they took the DevOps, they renamed his role or her role, and it stays the same. I see platform engineering teams in large organizations having different skill sets. They hire developers coding applications. That's not something that I've seen in traditional, what we could say, traditional DevOps. DevOps were more I don't know, they upgraded, they were more on the operational side. And of course, they created, as I said, all sorts of manifests and you know, Terraform the modules or recipes of this and images of that, but it wasn't, you know, coding, like straight up application coding. That wasn't a skill set. You didn't even see that on the job hires. Now I see job hires having straight up engineers, and they don't know much about DevOps. They have others that characterize and create the spec for the platform, and they implement that, but just like any other product. And sometimes you see back-end and front-end. So I see platform engineering as something slightly different. It's taking, and I will talk about that also today on the talk much, and maybe because in past life I used to be also a product manager, that I'm very sensitive to that, but I look at it as a product. Treat your platform as a product, and you see, when you treat it as a product, you have all the elements of a product, including a product manager or a product owner, and including a back-end engineer and a front-end engineer, depending if there is a UI or just API-based, and so on and so forth. So as much as I can go into the definition, I don't like definitions, I have to say. I like, especially when the question is compare DevOps with platform engineering, I'd rather make it more clear what's the difference. So it is an evolution in terms of the fact that it comes later in the DevOps maturity lifecycle, but in terms of the nature, you're not only developing best practices and processes and tiny tools, CLIs and stuff like that. You're now developing, if you're doing it right, you're now developing a product.
I agree with that. Regarding this distinction, like, it's the same thing. When I sometimes see hiring, as you said, there are different skill sets for DevOps and for platform engineering. I completely agree that you need to have a product mindset and the skills that come with that. But from the side of HR, I don't completely see it, or I don't completely see HR actually getting the difference all the time. So when you hire a platform engineer, it's basically DevOps when you actually come to the company. So I guess it is becoming more distinct, but still not there. People still don't completely grasp like that DevOps and platform can be that different. But those that you mentioned that actually get it, they get it right, I think.
You can share your opinion.
I'm just thinking all about it, and actually I pretty agree that either the platform engineering requires a different skill set. Originally, as I remember, the DevOps, the origin of DevOps comes from frustration of ops people, right? Maybe you remember velocity, conferences, etc. But now we are we are facing to another problem. Now we have a frustration on dev side, actually, because we created some crazy infrastructure stuff, and those people on dev side, they are focusing on delivering the business value. Their goal is not to babysitting infrastructure, actually, because idea of DevOps was somehow, okay, put dev and ops people in one group, and agree with you completely in one thing, that what we are actually on, or what DevOps is missing, is product thinking. Because this is something, originally DevOps people are very skilled technical people, but what we are lacking is not the communication skills, because we can communicate with technical people, but we are lacking in product thinking. We are lacking in build the product for customer. Because this is something, because we were trained to solve problems, but not to build something for somebody. Just my 5 cents.
So after this round of opinion, is there something in platform engineering that is new, that wasn't present or DevOps, or is it essentially just an evolution of what was always in DevOps and is reacting to the new realities of the software development, of the complexity of the cloud? That's my kind of first follow-up question. And the second follow-up question, do you think it is a function of a size of a company? For example, if you have a very small company, then it is very hard to distinguish between DevOps and platform engineering. But if you have a large company with multiple developers teams, it maybe the difference is much, much larger. So what is your opinion on that?
I definitely think that the size matters in this case, and that the need and the urgency of platform engineering becomes much more evident with the size of the company. So I mentioned before that the classic DevOps maturity lifecycle. So with the growth of the company, you move through the stages. And when you get to these stages, when the scale of the company is large enough that you have multiple teams, and as I said, multiple business units, multiple product lines, multiple lines of business, and then you start seeing these pockets of inefficiency because different teams work in isolation, solve the same problem again and again and again. And then when you, as I said, in the maturity lifecycle, when it goes to the measured and optimized phase, someone starts actually collecting data about the efficiency of the DevOps operations and realizing and putting up to the surface these pockets of inefficiency, then it becomes very evident, yes, we need to unify it. We need shared services to augment that. So that's my take.
Yeah, one additional thing, again, like DevOps, the whole movement appeared because, as you said, there was frustration. By the way, I think it was frustration on both sides. Like the devs were also frustrated because, like,
I was developer then. I was frustrated.
Now, what the DevOps ideas said, we need to bring these silos closer together, right? So there was no like specific method. It was like, let's bring them closer together. Maybe let them sit in the same room, let them have the same Kanban board, et cetera, et cetera, et cetera, all kinds of methods. Now, when you do this at scale, you need to have methods. And that's why in platform engineering, we see this much more focus on interfaces, on defining the interfaces and unifying on the interface. And that's why when we talk about platform engineering, we talk about, the developer. I don't like to talk about developer experience because then what about the ops experience? So I'm saying engineering experience in general and APIs, of course. So we're trying to unify on the APIs, internal APIs that we're building, and interfaces, so that we all know how things work and we have understanding what would be the most efficient way to do stuff.
Basically nothing to add. That exactly like when you create a platform, when you go for that platform, that interfaces or the UI and the UX, and actually understanding who is the user of that and who is the maintainer of that should impact the decisions that you make and the tools that you choose for the platform or that you create for that platform. Another major challenge, or another thing that it brought at least to the DevOps field, if we could call it that, is the standardization on the side of these toolings. So when you create that product, you want to maintain it in a standard way, or you want people to interface with it in a standard way. So that's kind of new. When you have clear DevOps, this guy has his own scripts, this guy has potentially his own scripts, another team has their own scripts. And platform brings it together and tries to make it more manageable, I guess.
Yeah, and what was the question actually?
Well,
we have.
What's like the new thing that platform engineering brings to the table?
Thanks. I was catching something about skills, etc. Because yeah, from my point of view, as I mentioned before, probably the most important skill or something new what we need to learn as engineers, DevOps engineers or whatever, is what I see and what I saw as a big problem. What was the big problem for us was this product thinking. Basically, let's call it product thinking. That we want to build a product, and yes, as you mentioned, this product needs to have some interface, not only API interface. Also, we need to communicate it via documentation, for instance. We need to do some advocacy or trainings, etc. I think it's in this book, Team Topologies, Skeleton and Pace, they defined 3 types of interactions between teams. One is API. I don't know the exact terms for that, but it's API, documentation, facilitation, basically. And yeah, that's something what we need to, yeah, what should be the goal of the platform engineer or platform engineering? Okay, probably the goal is a very strong word, but yeah, something what we should focus on. Because traditionally in DevOps or as SRE, we were maintainers, and we basically worked as supporters. Yeah, we have Slack channel where people throwing all those problems. We were basically trying to solve those problems, but now it's a little bit different because we need to bring solution to not let those people to throw all their problems to us, yeah, for instance.
So what you essentially said, it is about self-empowerment of the developers. So
probably yes, yeah.
Yes.
Yeah.
But this is one of the opinions that are out there on essentially the main difference of platform engineering against traditional DevOps was rather than addressing automation and the cultural difference between the two teams, developers and operations, who had very different mind focus. One was change was welcome and desired on developer side, and on ops team, change was dangerous and wanted to be controlled and probably eliminate if possible. And these two conflicts needs to be resolved in a friendly manner so that the evolution of the product is actually faster and smoother. The platform is about how to, does focus more how to empower developers to do more on their own without needing other teams involving. And here is a question from the audience that plays perfectly into that, and it's asking, where do you put the SREs, the site reliability engineering, in this equation, which we could discuss whether SRE is the same thing as ops, yes or no. That could be another panel on that topic, but let's not go there. Let's kind of try to answer the question from the audience. And you can start. We can go back this way.
Actually, a question about SRE, that's a question for somebody who works for Google, because I saw so many SRE definitions that I'm lost. Yeah, somebody is talking, yeah, somebody is mentioning, yeah. For somebody it's more ops, for somebody is yeah. To be honest, I never worked as a SRE, and probably we should ask somebody who worked as proper SRE. Yeah.
A friend of mine had this very oversimplified definition. Do you wear a pager? You are SRE.
Yeah, well, as with all these buzzwords, like each organization calls their ops people something different. The Google way was calling them SREs, and they released book. And if you read the SRE book, it talks about everything, you know, release engineering, managing builds, like things that are not directly related to reliability, or you could say they are, et cetera, et cetera, et cetera. And they're also talking about, you know, these people being actually software developers responsible for building the system. So. In a way, the SRE books have helped define platform engineering as a discipline, I think. They were just another step to the industry going there. Because, for example, in Facebook, they were calling this production engineering for a long time, but it didn't stick on that hard. So, yeah, basically, where do I put SRE in this evolution? I remember a couple of years ago saying at a conference that if you want to have a larger salary and you're still calling yourself a DevOps, you need to rebrand to SRE urgently.
Interesting.
But that was like 2 years ago. Today, maybe platform engineering is the way to go. Depends on how many % you want on top of your current salary.
Yeah. Any comments?
I think they covered nicely. I want to actually comment about something you said, which is empowerment of developers, that you see that. And I want to challenge that as well, just to make it not that everyone agrees on everything, just to make it more interesting so they don't fall asleep after the nice lunch. So empowerment of developers and the engineering is nice. I think platform engineering, or the rationale that drives organizations to adopt platform engineering, is something slightly different. I think it's, on the other side of the equation, cognitive load of developers. developers were very much empowered, but in order to fulfill their empowerment, they needed to know Kubernetes and Docker and Terraform and the admin side of Postgres and the admin side of Kafka clusters and this and that in order to fulfill their empowerment. And it left them not just exhausted, and that's the cognitive load, also very much defocused from dealing with the core business logic and value that they're supposed to be bringing. And it created a lot of churn, to be honest, like engineers becoming very frustrated about that. So I think reducing the cognitive load is actually something that I see much more pressing, at least for the VP engineering that loses is good people and good men and women and so on. That's one. And there was another point that I wanted to say about that. Let me just recap. I lost my train of thought there. So cognitive load on the engineering side is well, I'll grab it on, but just to say, empowerment is nice. I think engineers did not suffer from lack of empowerment, just not having the bandwidth to do that with having all the burden. So
there are two sides to empowerment. One side is to actually have permission, technical abilities of doing things, and the other is to give them an easy way of doing things. So what you are saying is essentially the important part is not to give them abilities, because you can give them admin access to certain things, but they still need to understand how to use those admin privileges without hurting themselves or somebody else.
So it's more of the enablement. So empowerment is nice. I think the enablement was lacking, and they needed to know way too much. I'm talking about the product engineers, not the platform engineers. Needed to know way too much about infrastructure, both the production ones that we gave all the examples, but also the release pipeline. So you need to be expert in how Jenkins works and how Ansible works and this and that in order to also take care of the release cycle. All of that, if you can get as shared services, someone else offering that, and you can take that and then adapt to your needs, becomes much easier. So they're empowered, you're right, to do their things, but with much, much less cognitive load. That's my point here.
Very, very nice.
Yeah, I think an ironic way to look at this, as you said, like DevOps grew out of the ops being frustrated, and then it made the developers frustrated. And now the developers are frustrated, and platform engineering is their way to taking that frustration back to the ops people.
So essentially the evolution...
So this is developers fighting back.
The evolution in this space can be described as passing a token of frustration between various teams in the chain?
Exactly.
Okay.
Like, there is always some pain, but it's not evenly distributed, so you just need to push it away from you.
So when we get to these frustration things, can you comment on what were the biggest challenges from in the area of DevOps/platform engineering from your past experience, what you kind of encountered, or if you were lucky enough that you didn't encounter, please share so everybody in the audience can envy you, okay?
Shall I start?
Yeah.
Well, I think the biggest challenge that I see is actually not technical at all. It's the buy-in within the organization. Getting the buy-in, because as we said, the value of shared services is when the individual product teams will consume, preferably if you have the right product mindset, then you will get the buy-in before even starting to develop to justify the development. So getting the buy-in within the organization, both with leadership, with management, and also with individual product teams, is something that is always challenging. I see that repeating. There are also technical challenges, but I leave it to my colleagues to elaborate on that.
And why is that? Why is getting buy-in so challenging?
So the why is very simple. I'm sure that all of you saw that. You come with the idea, hey, let's build a platform engineering team that will do an internal platform. I just need 2 back-end developers and 2 front-end developers and a DevOps guy and a product owner, and then I will give you the sky. And the CEO, CFO, CTO scratch their heads and saying, okay, you're building all this product for whom? What am I seeing out of that? You're not selling it, it's just for my own engineers, right? So why is that all that effort? Before that, I had a couple of DevOps guys and they did all of the things. So I think the understanding that we were talking about, the pain of how much it costs when you don't have that, how much, as I said, before you reach the point where you're measured and optimized, before you can show the numbers and show the evidence for these pockets of inefficiency, it's spread, it's out there. But they don't see that. They don't see the aggregated effect. It's like organizations liking to work with open source because it's free, and they won't pay for a managed service, but they don't really bother doing the math. I just had a chat out there with someone asking me a few questions about that. They never go about doing the math of how many man-hours, engineering hours they invest in maintaining their own, I don't know, Elasticsearch indices and whatever, Thanos clusters and whatnot. So when you do the math and you see what's the penalty internally, what's the toil, okay, remember that, what's the toil that you pay for re-implementing again and again and again, the same certificate rotation, each team solves the same problem, the same pipeline, the same build mechanism, again and again and again. And someone high up the chain, if once they see the overall cross-cutting picture, then it becomes evident. That's my answer for the why.
Okay, good. So first of all, it's interesting because you were talking about the buy-in, but you're mainly saying the decision makers. You need to get like their buy-in, and I'm also seeing the other side of the equation, the adoption by the developers. Like now you're building a product, you need to sell the product. And that is sometimes also hard because people are, we like developers, you could say that engineers in general are more receptive of change, but still we're humans, and as humans we fear change. And we all know how hard it is to convince somebody to use a new tool. And for the last year, I've been dealing a lot with internal delivery portals, stuff like Backstage, et cetera, et cetera, et cetera. And again, this is something I know throughout my career, but I've heard multiple stories of folks, building portals, building workflows, and then engineers just not using that. And that's like a whole new additional skill that the platform teams now need to acquire, how to understand their users, how to build the things they actually need and are going to use, and if they're not, to understand why they're not using it, how to lure them in, et cetera, et cetera. So that's challenging.
Jakub, what is your experience in Labyrinth Labs with that?
Well, in Labyrinth Labs, it's a bit different because we are mainly consulting. So the challenge for us mainly is to not to persuade our management, but to persuade other companies that having a platform and having it ready is actually useful. But from experience in previous work, exactly, buying or justifying the existence of a platform team is exactly the hardest, not just a challenge, it's basically a hardship, because you need to find someone from management and also from the devs who will actually support you, use your stuff, promote your stuff, and so on. What wasn't the technical aspect of it, like actually making a platform, that was a fun challenge, but what was an interesting challenge was the transition from DevOps to platform. Like suddenly you have to pick up all of these new mindsets. You have to figure out like, what do these users need actually? How much do you give them? What do you hide from them so that you don't overload them with information and with different buttons they can press to configure their stuff, and what should be actually standardized there. So moving on from the typical DevOps mindset of getting it to work to actually making something standard, that was the most interesting challenge, I would say.
Very interesting. Zdeněk?
Actually, I will back to your question because, to be honest, I stepped into the platform engineering water after somebody sold this idea to company and then disappeared. And we need to learn what actually it means. And the biggest challenge basically for us was mind shift, because, as I said, there are a few important, let's say, or challenging things like usually the DevOps teams are full of very technical, skilled people. And it's a curse. We know what you need. Yeah? And this is something, but this completely wrong approach. Yeah? We build platform for somebody and we need to convince him, okay, use it. But usually it's we are not solving their problems. We are solving our problems usually. We think it's a good idea, but this didn't work actually. And what we learned hard way is we actually need to, as guys mentions, some teams are solving same problem but little bit different. And your goal is not to build another solution for this problem. Your goal is probably go ask them how they solve it and pick the best solution. You don't need to invent again some new solution because they will probably refuse it because, yeah, that's the life. But if you take something what they built and make a product from this is much better approach. And yeah, the problem with platform and platform engineering company, what I saw was it's like toilet paper. You need to use it. Doesn't matter how bad it is, you need to use it. Yeah? And that's a challenging. That's the most challenging thing from my perspective. Yeah.
Well, you are essentially trying to define a standard and enforce the standard or convince or buy in on multiple sides the users to support a standard. But what usually happens or often happens is that you have these 3 standards, so you want to standardize, and so you create a 4th standard and since that moment you have to support 4 standards. Until the next round of iteration comes when you will try to standardize what is 4 standards and you create a 5th standard. So, and it really depends of whether you have a group that is willing to let go and adopt the standard. Fortunately, technology makes this natural selection cycle, and some standards are dying off because of the evolution of and which is pretty fast. So it is maybe not as bad. But we have a question when you talk about standards and talk about tooling. There is a question: should platform engineering team choose tooling for another division, for example, QA team? How they will gain expertise to make right choice without hands-on experience? So is the platform team kind of blessed with decision powers over the other teams, or?
This is my subjective opinion. Creating and forcing some standards is always a bad idea. And I guess this is also a bad approach that platform engineering or platform team will do everything for somebody. It's better to keep their freedom as it is. Don't touch their freedom. Let them build whatever they want. But you should somehow abstract or extract, let's say, 70% of use cases. And I'm pretty sure you will find some, in Google call it golden path. And support only this golden path. Don't make it complicated. Don't build a product which will support everything, because it will be complex. And it will be very hard to fulfill all needs. Yeah? But if you will focus on 70% of what the dev teams needs, and the rest will stay as it is, it's perfectly fine and it's working. Yeah. But this is just my subjective opinion.
Well, this is what this panel is about. So, Jakub, any comments?
Well, if the cognitive workload is actually supposed to be redistributed from that team to the platform team and to the people who are supposed to be making the decisions, well, I guess they should have a certain amount of decision making, but it shouldn't be unilateral. Like, it shouldn't be like, I made this tool for you, use it from now on, you can't use anything else. There needs to be communication, there needs to be feedback. You need to actually, the platform team, if it's supposed to work correctly, needs to figure out what the other teams need, what tools are needed, and develop it together. They are the guys that are doing the most of the work, but they need to gather the information and work according to that and not just build, whatever, I'll give it to you, use it from now on, and don't come to me again. So they need to communicate.
And?
Yeah, definitely. I'm just, thinking, we know what needs to happen, but in real life, like, you have 50 developers using one tool, and then other 50 developers, because we just merged within our company, and they're using another tool. So, like, who wins? And who takes that decision? That's much more challenging in real life than what's the golden path.
So, yeah, I'll challenge again. I've been in this space for a few decades, and about a decade ago I was at a startup squarely in this space. It was called Cloudify. It was since acquired by Dell EMC. But it was exactly that, to cloudify your application, to abstract this layer and create a path that you can develop your application over abstractions. And the idea is that, in general, this trend of PaaS, of platform as a service, didn't catch so much. And the reason is, if you ask me, is that it was too opinionated, okay? Things such as Heroku, AWS Elastic Beanstalk, Google App Engine, all of these were very nice. They're very elegant. They abstracted a lot of these things. So you said, I want one database, one message queue, one this, and you composed, and it's very elegant, very simplistic. But we as developers and as engineers needed more flexibility. We run different runtimes, different environment, different deployment models, whatnot. That wasn't flexible enough. So I think one of the differences, and I will speak about that also on my talk much more, but this is, many people approach me and ask me, do you think that platform engineering is just a reincarnation of platform as a service? And I say no. And the reason that I say no, or at least it shouldn't be, so in order for platform engineering to be successful, it needs to be different in several aspects. The aspect that I want to touch here for this question about the opinionated tool chain choice, I think platform engineering should take a more composable and optional choice. And by the way, not just on the tool chain, also on methodologies and other things. Composable and optional. So that different teams can, first of all, they don't have to get a buy-in to all your things end-to-end. They can also say, oh, I like this part of your platform, I don't like that part, so I will just consume that. So first of all, this part, they can choose what to take. And secondly, yes, you provide golden paths, and I'm a strong believer in golden paths, but the golden paths doesn't mean that you need to align with them. It just means that this path will probably be more paved, more well-proven, and more managed for you by the platform engineering team. You want to go down a different path, it's fine. It will mean that you will go back to a larger extent to be independently managing it and with lower level of support from the central platform engineering team. So it's a trade-off. You can make your own trade-off, but it's important. You can take the golden path on one thing, and on the other thing you can decide, the coolest new vector database on the block has just come out. I want to try exactly this vector database on my product. I don't want what you bring out of the box with the platform engineering team. Fine, just do that. So that's my 2 cents on the opinionation side.
So from what I've heard here, it is kind of finding a good balance between two extremes. One is the complete democracy, like developers sort of decide, we like this, we don't like that, and we'll pick that. And on the other side is what Linus Torvalds used to call the benevolent dictatorship. That means, okay, guys, nice try, but I know better, and I will decide what is good for you, and this is what's going to go into the kernel and what is not going to go into the kernel. It used pretty well for Linux, so for quite many years. So do you kind of agree that does this good balance exist, or where do you see, in your opinion, going more towards like the benevolent dictatorship, or more towards like we are democracy and we decide what's good for us?
So yeah, BDFL, Benevolent Dictator for Life, is not he started, but we see that in other open source projects. Being an open source ambassador, I can tell you that. It's something else here, okay? It's open source. When you talk about the core of a project and deciding to go down the benevolent dictator path is a different decision because it's pretty much behind the scenes for most of the end users. That's not the case for platform engineering. Platform engineering, ultimately, he mentioned Backstage and other products. Ultimately, it's white box. It's not black box. The product engineer ultimately will go and select on the inventory, on the catalog, whatnot, say, I want this, I want that, and I'm building my application, and I'm adapting it, and I'm configuring it. So it's not black box. Trying to be too opinionated bring us back, as I said, to what we've seen in the platform as a service ages with Heroku and others. So in this case, my own belief, also seeing what happened, the cycle, software cycle, IT cycle with PaaS, that platform engineering should take, as I said, the more optional and customizable and less opinionated, while providing golden paths that if you do want this one that that are proven, this is good. There's one more element that we haven't talked about, and I'm sure that Ant will have a lot of things to say about that, is the cost. And we see the cost repeatedly being an ever-increasing concern. And part of the fact that each team solves the problem individually makes it, when you look at it globally in the company, more costly. When you have a central team that paves this golden path, and this golden path is not just best practice, it also is backed by contractual agreements with vendors that, assuming that we don't build everything in-house, don't do that, by the way. Platform engineering doesn't mean that you build everything in-house. Actually, reuse as much as possible from the things that are out there and make it as thin as possible, a different topic to discuss. But then, and you can make sure that all different teams will align with that, then you have more bargaining power, then you can come to your vendor, then you can get better pricing, you get centralized control over the cost across the company. Maybe you can do some multi-tenancy within your company to better utilize resources. So a lot of the things are also in terms of when you take this, you can provide better cost visibility and cost management. So just another point in discussion, and again, I will leave it to my colleagues to say more.
Yeah, thank you. So, first of all, to relate to what you said about, flexibility. That's one thing, by the way, we also saw with the internal developer portals. The portals that actually succeed with adoption are those that are managed as inner source projects, where the developers can actually extend the portal, the internal portal, whenever they need. Like they say, I want to integrate like my monitoring solution into that, and they can just write code, submit a pull request, and then the platform team will approve that, make that part of the portal, and then that gives it much higher chance of adoption. Because again, as engineers, we like to be creative. We don't like to just be given tools and told, use that. Okay, and concerning cost, definitely. First of all, from the get-go, building an internal platform is, of course, an economic decision. Okay, so it does solve all kind of, collaboration problems, et cetera, but it's an economic decision. In general, centralizing some functionality in a company is an economic decision, right? Again, we said when you scale, it's not feasible to continue scaling all of the functions in the same with the same scaling factor. So at a certain point, you would say, I want to centralize. Like I don't want to use to have a separate cache for each component in the system. I want to centralize the caches. Et cetera, et cetera. The same with platform, right? So we want everybody to use that same component, and that's why we want to standardize, because the total cost of ownership goes down in that, and the return on investment goes up. So that's another cost. That's the cost of labor that's connected to building platforms. And of course, the cost of resources, which could be cloud resources, or if you're managing this internally, then your hardware costs, of course, that too. Once you have a centralized platform, it becomes much easier to manage. Again, we have different teams using the same resources, sharing resources, even if it's not like a totally elastic, infinitely elastic cloud, even more. Like we have teams fighting for resources, and if they're using the same platform, it's much easier to understand who uses what and to allocate resources accordingly to how much the team earns for the company, for example.
basically. Just my 5 cents to this question is, I will change the flexibility for freedom just for one reason, because freedom without the responsibility is anarchy. And you basically mentioned when the company fall into anarchy, where everybody is doing everything on their own. It's important to it's important to have freedom, but you need to be responsible of what you bring to production as a team, not the platform team, but the streamline team or product team. If you go the way I will build my own, because I don't like what platform team is delivering me. I will build something on my own. You need to be responsible to maintain it as well, because you cannot ask for platform engineers to operate and maintain your thing. And maybe this might bring the balance into this. Just the responsibility. Because, okay, I am the dev team, we are developing something, and we have 2 choices. We will use something what platform team will deliver, or we will go on our own. But when we see, okay, we need to take care about it, do some maintenance, etc., okay, we pick this because they are supporting it. It's quite easy. But don't let platform engineers do support for teams stuff,
Yeah, exactly. That's who owns it after you build it. That's the question. You know, there is this one of the standard examples for Kubernetes application that you find on the net is this wonderful example that you have pods built. Some pods are built in the C#, some are built in Java, some are built in JavaScript, some in Python, some in Ruby, and it's all kind of wired together. And it's just this example that shows, oh, now look how everything works. And which is a great example. It is really good example to demonstrate the power of platform like Kubernetes, but it should be written with a big signs. Don't do this at home. This is not how you are supposed to build your application, because if you do that, then your company, whoever will be maintaining that, will need to have skills in all these ecosystems, not languages, ecosystems. The JavaScript is not a language. JavaScript is an ecosystem. The problem of learning JavaScript is simple. Problem of keeping up to date with the ecosystem is a full-time job. And the same thing comes to Python, same thing comes to Java or whatever you pick. So suddenly your 1-man or 2-man platform team has grown to like 15 people team because you just don't know how to cover that thing. So this is just to underscore this is why I'm kind of pretty much more into the center when it comes to how much flexibility you should allow. But what I'm struggling with, I'm not sure if the platform team is the best team that should define this thing, or it should be kind of a more like a governance. It probably depends on the size of the organization, I guess. So that's the kind of, I don't want to beat the dead horse over and over again. We have 2 questions that are asking about something called push left. And honestly, I'm a little bit unsure what exactly do you mean with that.
I think the shift left, but it's the same. I assume
Yes.
it's the shift left. So both of them can be addressed probably together.
Yes. So whoever feels like you have an opinion about that, please start. So first question is, do you think that we should push shift left even more? Isn't it too much already? And the other is what's the most important thing to consider in the whole shift left movement? So can you maybe describe for the people who are not 100% sure what the question is about?
Yeah, so first of all, shift left. Is there anyone who doesn't know what shift left means, just to make sure that we're on the same page? Okay, so let's start with the shift left. Okay, shift left is a movement that moves more responsibility. If you look at lefty being the engineers, the developers, the source code developers, and right being the ops, shifting left is more responsibility towards the engineering. What responsibility? It could be security related. It could be the operational, like the deployment and post-deployment, day 2. It could be FinOps related. It doesn't really matter. Shift left is the trend of the developer, you build it, you own it, okay? Treat shift left as you build it, you own it. The question is how much of the ownership you shift left, okay?
That's the frustration, moving left.
Well, I have a kind of a mental problem with why developers are left, but okay.
There's no political statement behind that, I think.
It's because of how you draw the pipeline. The pipeline usually goes from from left to right.
To production time. Okay, now it makes sense. Thank you.
No, it's not political. It's just a standard way of showing the pipeline. Anyway, so a lot of responsibility has been shifted to developers. And the thing goes back actually to cognitive load. So developers today have a lot of empowerment thanks to the shift left, but it comes with a lot of a cognitive load because you need to know all these things. So in a way, the question being about isn't it too much already and thing, I think platform engineering actually recognizes that we've taken too much and we've put too much cognitive load on the developers. So in a way, platform engineering in the context of the shift left movement is, and it goes back to the clarification that I did before about your empowerment statement, it's not taking away the empowerment, but it takes away some of the, it enables better. So the engineer doesn't need to now learn self-handedly and maintain the skill set around both Kubernetes and Docker and Terraform and this and that. It's in security and FinOps and then understand how the pricing model of AWS, which is an entirely different beast, and all of that. No, you get something in between that abstracts and masks some of that. The engineer can actually focus more on the business logic. So in a way, in the context of shifting left, I think it has been recognized that it's too much, and platform engineering fixes a bit of that. It is, you can say that some of the empowerment is reduced because of the golden paths and things like that. I think if you strike the right balance in platform engineering, you will still leave the engineers very much empowered, but much more enabled. And still, you can have something centralized around security, FinOps, compliance, best practices, golden paths, and so
on. Yeah. The whole idea of the shift left movement is that the ops people are right.
Just small notes. I really like this term cognitive load, actually. Since the beginning you mentioned, I realized that basically platform engineering, the goal of platform engineering should be reducing the cognitive load. That's all, right? I just want to say that I really like it.
And that's because the engineers are not smart enough, of course.
Grab him after the...
Yeah, with the shift left thing, actually, I think it shouldn't be forced. Like, it should be more of like an enablement and empowerment of, for the developers to actually have the information that they need and the tools that they need when they actually need them. So if actually they need to optimize the costs of their application because it's been somehow from observability determined that their application is costly, so give them the tools to actually be able to make the changes they need to make. But forcing push left, giving them like, forcing them like you build it, you run it all the time, or in a bad way, forcing them to partake in all of these things, cognitive load, it adds a lot more. That shouldn't happen. It should be more optional and more enabling than forceful.
I would like to slightly challenge this kind of empowerment thing because there is this concept of audit and security audit and PCI compliance, which expressly prohibits you to give developers access to certain information in production. So there is kind of a legal framework in multiple areas where you cannot, you need to prove that your developers actually have no visibility to the things that the shift left would explicitly give them permission to, because the whole you build it, you run it means that in order to run it, you need to have reasonable visibility and reasonable control over the whole chain, from starting from your dev environment through some staging or UAT or whatever you name it, up to the eventually the production environment. If the developers should be somehow being able or or responsible for deploying to production when they consider everything is fine, they need to have tools. You can build tools that kind of satisfies both, but it is extremely complex and costly way of doing things, rather what most companies would go for, like, okay, so you have this access, like ops access to production, and if there is a problem, we expect you to find out what's wrong and fix it as soon as possible. So that this essentially eliminates the difference between developers and ops people, and from my experience, there is not a good value proposition for developers. If you do that to your dev team, how do you keep the dev team?
Does anyone else want to know? So, first of all, yes, there's the compliance elements. My company has all the PCIs, etc., compliances, and I can still tell you that the engineers are very much responsible to the release cycle all the way to production. You don't need to access, like, you don't need to give, we're not in the age of, okay, I have the SSH access to the machines. You don't SSH to the machines, even if you're ops, okay? There are more sophisticated ways of monitoring, and my bread and butter is observability. So you can monitor and observe your system and understand what's the state and the functionality without having to be able to log into the machines, access the machines, or even access the raw data. You can redact, you can obfuscate data. The engineer oftentimes doesn't need to see the phone number and credit card number that is within the log line to be able to analyze the thing. So we should separate, I think, the overlap between the concerns that arise from the compliance and the ability to take ownership and responsibility to the successful rollout to production and the deployment post-production and day 2 scenarios should be, if you do it right and if you architect it right, it shouldn't come in a conflict to 99.9% of the cases. That's my experience, but happy to hear my colleagues on other experiences.
I agree. If you do it right, and that takes time, and I don't know what percentage of the industry actually does it right. So that would be a challenging question.
Give your answer to the other part of the industry that doesn't do it.
Yeah, in general, you know, we try our best to find the thin line between the compliance and the security and the creativity and the freedom of access and the ability to do stuff. It's like anything else in life, I guess.
Yes.
Balance. Yeah, it's mostly now like figuring out where to actually put the fence. Like in most cases, even if you are not completely compliant with, I don't know, SOC 2 or whatever, you don't necessarily give developers access to delete the production database, but you need them to view the data in the production database. So this is something that actually platform engineering kind of solves. Like it gives them the right tools in the right places with the right interface so they can do their job. So the shift left can actually happen, and so they can take the responsibility. But it's really difficult to figure out where is actually the balance of putting up the fence. Like, you can do this, you can't do this.
You know, the issue is, if you are advanced enough in automation, in GitOps and stuff, and you ever publish a wrong branch of your Terraform code to Argo, you may be surprised what you can delete. So. Yeah.
But then if you're managing everything with Terraform, it should be easy to recreate, right?
Yeah, well, and if you have up-to-date backups and some your SLA of the restore window is large enough, then pretty much nothing happened. Yeah, I agree.
A lot of ifs. Yes, so it all comes down basically to the level of trust, and that also comes down to the culture of the company, to the size of the company.
Yes, absolutely. Absolutely.
So, like, interesting, like, who here is a developer or works at an organization where developers have direct access to production? Okay, so probably something like, what, 10%?
Yeah. Well, I think we have maybe time for one last question before our time runs out. And the last question is kind of what techniques do you use to, you mentioned selling the idea of platform engineering, of standardization, of empowerment to various stakeholders, upper management, middle management, customers, you name it, depends on your company. So what kind of techniques other than Amazon used successfully recently with EKS when they introduced so-called extended support, which is if you are running EKS version older than 3 versions from the latest, you are paying not 10 cents per hour, you are paying 60 cents per hour, which was an excellent argument for upper management to listen to. And so do you have any other secret tricks to how to sell this idea?
So I would say try to map out the OKRs, the objective key results that your company watches. These are like sort of the top line KPIs that are important for your company. And different companies and in different stages of the life cycle could have different focus areas. And then try to map it to these. So if the focus is on developer velocity, show them how platform engineering will increase the developer velocity. If the company suffers greatly from churn of employees, engineers leaving and moving on and a lot of change, talk to them and show them how platform engineering can help better developer experience that will increase the stickiness. If you have a problem with the compliance and regulations and each team solves separately, independently in a silo, and then we end up with holes that then in an audit they flush it out, show them how the platform engineering will enable you to centralize the compliance enforcement, the regulations, the security elements, make sure that each team will work with static code analysis, with artifact scanning, with the same certificate rotation or whatnot. So depending on the pain point the companies feel from all the benefits that we talked about in platform engineering, try to map it and show them and preferably quantify and show them, hey, this is how much we pay for that. It doesn't have to be dollar sign. It could be dollar sign, by the way. And sometimes, for example, the cost. You can show them, hey, because each one chose a different vendor for the cloud storage or for the archiving or that, we are paying X. And if I consolidate all of that with Amazon for cold storage, then I can get a bargain deal that will reduce it to Y. So in some cases, you can mark it a dollar sign. In some cases, you'll be able to quantify story points and others. But try to make it quantitative as much as possible. This is, from my experience, the best way to do the pitch.
Yeah, base it on data. And if that doesn't work, use brute force.
That's good, thank you.
Like if you're the only person who knows how to manage Kubernetes clusters and they're not receptive of your ideas, you can just say, I'll leave tomorrow, and you'll have to manage this on your own. Ideas?
Being a friend with the CTO, maybe. But yeah, this is basically how a platform team at my previous company came up. Like the guy had pretty good charm, so he actually made it happen without any data. But what I wanted to ask, how, if there is no gathering of data, if management wasn't actually interested in getting the data that you need to decide, how do you get to this point of them being actually interested in the data and interested in gathering the data?
So if you're managing to wiggle it up with qualitative and not quantitative, it's fine. Like if you can tell them, hey, check out how much, and go talk to the engineers and listen to how much time they waste. Let's take a different example, okay? Another example altogether. How much time it takes you, a new employee gets in your company, needs to set up the laptop and the environment and everything to start being able to, he or she, to start coding. How much time does it take? Let's say, who does it within an hour or less in the company? Raise a hand. Okay. 3 hours. And a day. More than a day. Okay. That's my case. Now imagine that you can have that as a shared service, developer environment as a service. So you go, without even qualifying, just ask them, hey, we've been onboarding a few engineers recently, how much time does it take? They see that, that's a value. So try to make it very clear, not just the philosophical discussions that we've discussed. I did mention my philosophy there. Don't go with the philosophy to your upper management. Go with something very tangible. If it's not quantitative, do it qualitative. But do it something that they can actually validate you. They can go to the director of engineering or the VP engineering or a team lead or the new employee that just started a week ago. Ask them and get the sense of the team. Go to the HR and ask them about the churn. How many employees we've lost, and when they asked them why they left, they said, because I'm exhausted by having to juggle all this cognitive load. So try to make it as concrete as possible and get them to feel the pain and translate it, at least in their minds, to what it means to the company. All the change of personnel, all the time wasted on setting up environments, all the time for monitoring and rewriting configurations, and so on and so forth. That would be my advice.
Unfortunately, we are running out of time. Thank you very much, all of you, for taking part of the discussion. I will keep your last sentence, make them feel the pain, remember.
And you're all invited 4:15 in the other room for more discussion about platform engineering. Yes. So if you had fun, do join me, and looking forward to talking some more platform engineering with you.
Please don't hesitate to find out our experts from the panel outside and just to continue one-on-one. I'm sure you couldn't ask all the questions that were going through your heads when hearing this discussion. It was fascinating for me personally. Thank you very much, and have a nice rest of the conference.
Thank you very much.
Thanks all. Thanks for listening.
Thank you, guys.
Thanks.
So hello, and welcome to my session. My name is Rastislav Sabo. I'm a software engineer at Days of Valent, recently acquired by Cisco. And today I'll be speaking about BGP in Kubernetes. Why something like BGP may be useful in Kubernetes, and how can you use BGP in Kubernetes with Cilium. So before going to Kubernetes world, let me just give you a brief introduction into what BGP actually is. So BGP is Border Gateway Protocol. It's a dynamic routing protocol which was designed to form the internet, to exchange the routes between what we call autonomous systems. And it turned out that nowadays is also very popular in the data center networks. It is an INTF standard, so it's highly interoperable, and it has been powering the internet for many decades. The first sketch of the BGP protocol was done in 1999. I was 2 years old at the time, by two engineers on the back of 3 ketchup-stained napkins. This is a pre-production of one of them. So it's a very old but proven protocol. The main use or the main reason for deploying BGP into a network is to exchange routes between routers, between BGP peers. Two routers first needs to form a peering, so they need to connect via TCP, and through the TCP connection, then they can exchange the routes. Those routes can be either IPv4 or IPv6 routes or some other protocol, network layer reachability informations. And those routes can have many attributes attached to them, which can be very useful for some advanced traffic engineering or affecting the packet path towards the way you need it. On the picture, you can see 3 routers. They are paired, so A is paired with B, B is paired with C, and the router A sends an BGP advertisement with the directly connected network to it towards the router B. And then router B can send a similar advertisement with the same network to router C. And conversely, router C can send an advertisement about its directly connected network to router B, and B can forward that to the router A. And this way, the routers learn about the routes, and at this point, all 3 routers know about both networks and how to get to them. Another important aspect of BGP is the notion of autonomous systems. So BGP autonomous system is a group of networks with some common routing policy for connecting to other autonomous systems or the internet. Autonomous system is usually operated by a single organization. It may be some internet service provider, large enterprise, university, government agency, and similar. And between the autonomous systems, we do have something that we call eBGP peerings, external BGP peerings, through which the autonomous systems exchange the routes between themselves. And internally within autonomous systems, there can be iBGP or internal BGP peerings through which the routers within AS can learn about the routes between themselves. And this is basically the way how we form the internet. The only difference is that we have many more autonomous systems than these 3 that you can see on the picture. And how many of them we have on the internet? It's many of them. This is a map of autonomous systems in the Europe's part of the internet, which shows individual autonomous systems and how they are paired together. And this one shows the entire internet. Altogether, right now we have more than 117,000 autonomous systems in the internet. So that's BGP for the internet, but why do we need something like this in our Kubernetes clusters? So let's first talk about data centers. Let's say you are building your own data center, and in the modern data centers, you would nowadays mostly see this kind of network topology. It's called closed network. It It consists of multiple tiers of switches. Here you can see spine tier of switches and leaf tier of switches. And each spine switch is interconnected with each leaf switch here on this picture. This gives us rich connectivity, uniformity, fault tolerance, and easy scaling. It's very easy to add more switches into such topology. If we wanted to achieve even larger scale, we can introduce more tiers, and this way we can achieve almost unlimited scale. But you may have noticed that we are starting to have quite so many links in this kind of network architecture. So how can we deal with them? Let's first think what would happen if we just connected these switches as standard layer 2 switches, right? So if all those links would be just layer 2 Ethernet cables between switch ports. What would happen? On layer 2, we run or switches usually run something that is called spanning tree protocol, which breaks the connectivity matrix to a loop-free tree. Why? Because in layer 2 networks, we cannot have loops. Otherwise, we would soon see broadcast storms. So such kind of layer 2 interconnect between those switches, between spine and leaf switches, would not be very effective because many links would become unused actually. So on this picture, the green ones, for example, would be used and the red ones would be blocked. So not ideal. What's even less ideal is what would happen if one of the links would fail. Then the packet path can become very ineffective or inefficient. If you take a look at this picture, after a link failure between the bottom left server and bottom right server, you would need to go through 4 hops to reach the destination. So how we can deal with these issues? The answer is easy. Instead of layer 2 between the switches, we would use layer 3 interconnection. And we would do routing on each one of the switches, on the spine and leaf level as well. That allows us to have all the links active all the time. And whenever there is a link failure, all the remaining links still become active and we have much higher throughput. But if we need to have a routing between so many switches, we need a routing protocol or too many static routes, but we wouldn't probably use static routes for such deployment. And it turned out that BGP is a very good routing protocol for this use case. Because first, it's relative simplicity. I mean, BGP is a complex routing protocol, but for like simple use case, as in this data center example, it's quite easy to bring it up. Also, another benefit is the scale. So it's proven that it can scale to the internet scales, right? So you won't have that scale in your data center. There are many existing implementation, even in the open source world. And they are all interoperable, so that there is no need to worry about that. And it supports many protocols. So through BGP, you can advertise IPv4, IPv6, and many other protocols, and it's easily extensible. And last but not least, it allows for advanced traffic engineering through path attributes. So that means that we can tune how the packets should flow in your data center very easily. But the question is, what if you still need some layer 2 connection between your routers? So we do have routers on the bottom of these pictures we do have servers on the bottom of this picture with 2 different VLANs. And we still want server on the left side to talk to the server on the right side on the layer 2 level. Let's say you have some kind of legacy application which needs that. how can that work if the links between leaf and spine are now layer 3 links? Well, that's also solvable with BGP. We can bring up VXLAN tunnels between the leaf switches, and via BGP we can actually advertise those layer 2 reachability information as well. So BGP can help also in this kind of layer 2 over layer 3 tunneling. And I think the most important use case of BGP in the data center in terms of Kubernetes deployments is equal cost multipath load balancing. So what it is, on this picture we have one router and we have 3 nodes, and each of the nodes is paired with the router, and each of the nodes would advertise the same virtual IP address to the router. So the router would learn the same prefix from 3 different sources with the same cost. And what the router does when there is an ingress traffic coming to that VIP is that it would start load balancing between them. And this way you can build load balancing in your infrastructure without the need for some specialized appliances, because routers can do that very effectively on hardware. Okay, and now let's think about BGP in the cloud networks. Do we need BGP in the cloud if everything in the cloud is managed by the cloud provider and we don't need to care about it? Well, the answer is yes. There are some use cases for BGP even in the cloud networks, but they are a little bit more advanced. For example, in AWS, you can configure or you can play around with BGP if you are using either AWS Transit Gateway, Direct Connect, or side-to-side VPN. Basically, if you need to interconnect your cloud infrastructure with some on-premises infrastructure, then BGP can be helpful in case that you want to have redundant setup. Similarly, in Azure, there is BGP support on the Azure VPN gateways. Again, if you need to interconnect your on-premises sites with cloud infrastructure, then you can use BGP to build fault-tolerant setups. And again, similarly, in the Google Cloud, you can use BGP on Cloud Router, and you can use it again to interconnect between the cloud and on-prem. Okay, now finally let's go to Kubernetes. So Kubernetes can run either on in your on-premises infrastructure or in the cloud. So let's take a look at BGP in Kubernetes with Cilium. And I'm repeating this slide because this would be the main use case of BGP in the Kubernetes environments. So let's assume that the nodes down here, ABC, are your Kubernetes nodes. Then you can use BGP to advertise either service IPs or pod IPs towards the router and build an ingress load balancing solution for your setup using it. How can you do that? With Cilium, we do have BGP control plane built in the solution. You just need to enable it by one Helm flag. And it's fully integrated with all the Cilium features. So with kubeproxy replacement, all the IPAM modes that Cilium supports. It's Kubernetes native, meaning that you can configure it via CRDs. There is no need for hard-coded IP addresses as much as it is possible. And most of the configuration is driven by labels. And it allows you to advertise Kubernetes-specific routes or prefixes to configured peers. So those can be Kubernetes services or pod siders. On this picture, we can take a look on how you can achieve that. So in Cilium, if you want to configure BGP, you would deploy a CRD called Cilium BGP peering policy. And this CRD is node-specific, meaning that you always need to select nodes to which that policy applies. You do that via node selector, in which you can match nodes by label. On this picture, for example, we have like 6 Kubernetes nodes, and 3 of them are deployed in rack 0, and 3 of them are deployed in the rack 1. And we want to peer the nodes in the rack 0 with the router B, and the nodes in the rack 1 with the router C. So we deploy 2 Cilium BGP peering policies. One is selecting, matching the labels of the nodes in the rack 0, and the other one is matching the labels of the nodes in the rack 1. And inside of the BGP peering policy, you define your peering, your neighbors, your addresses of your peers, and more details about the BGP peering if necessary. Once you have your peering set up, you need to configure Cilium and tell it what kind of routes it should advertise to the router. The simplest thing that you can do is turn the flag export pod CIDR to true, and that would advertise the pod CIDRs of the nodes to the routers. On this picture to one router, but it can be multiple routers in more complex deployments. As you can see, each node uses a different pod CIDR. Pod CIDR is a subnet from which we assign IP addresses to the pods. And each node advertises its pod CIDR to the router so that the router knows where a given pod, where a traffic to a given pod should be routed. But I think the main use case is advertising service IP addresses. So in Kubernetes, you can deploy services for your workloads. And those services can be either load balancer services, cluster IP services, external IP services. All of them we can now advertise with Cilium. And the way you do it is that you configure the Cilium BGP peering policy again with a service selector, which is matching services that you want to advertise to the router. And as you can see on this example, we do have 3 Cilium nodes. Each one is advertising the same service IP to the router because either they do have backends for that service or the service is configured to advertise it unconditionally. And whenever there is an ingress traffic coming to that service IP, then the router applies equals cost multiple path load balancing and load balances between the 3 nodes. Okay, so what I have just shown you was what we call BGP v1 API. That's the BGP control plane API that you would find in Cilium, in the latest Cilium version right now. But in the upcoming Cilium version, we will actually introduce a new BGP API that we call BGP v2. And we are making it a little bit more complex. It will no longer be just a single CRD. This time, there will be 4 CRDs, user-facing CRDs. And the reason is that we need to provide more flexibility for more advanced use cases for which the single CRD approach was not enough anymore. And another reason is that we also want to avoid some repetition that you would need to configure in case of a single CRD. So it looks complex, but it doesn't need to be necessarily that complex for simple use cases. If you just want to configure a simple BGP peering as similar to what I've shown you using BGP v2, then essentially you need to configure at least 3 CRDs. One is called Cilium BGP cluster config, which is like a definition of BGP cluster, BGP instance, ASN number, and the list of peers. And from the peer configuration, you reference another CRD, which is Cilium BGP peering config. That is peering configuration that can be much more complex than what you see here on the slide. But the main reason for this separate CRD is that you can reuse the same peer config for multiple peers. And from the BGP peer config, you reference another CRD, which is called Cilium BGP advertisement. And through that CRD, you control which routes you want to advertise, right? So in this example, we do have one Cilium BGP advertisement, and it tells Cilium to advertise podsiders and attach something that we call BGP communities to those routes. And then we have another advertisement type called service, and it contains some service-specific configuration, matching of the particular services, and again, some additional optional BGP attributes that you can attach to those routes. So basically, you can configure different kind of advertisements for different peers and for different BGP instances. Okay, if you want to try BGP with Cilium, it's quite easy. You don't necessarily need to have a BGP-enabled router. You can go to Cilium.io labs, and there are plenty of labs that can run in your browser, and some of them are actually using the BGP or showcasing the BGP control plane, so you can play around with it. We do not have Cilium BGP v2 lab yet, but it will come soon. And yeah, I think we have some time left, so I would show you a short demo of Cilium BGP v2 and how it works in actual cluster. Is this working? Yes. Okay, so here I have a cluster, quite empty cluster with 2 nodes. And BGP is enabled on both of the nodes. This cluster is now running BGP v2, which we can check by grabbing of API resources. And I've mentioned one of the BGP v2 CRDs is called Cilium BGP cluster config. That's the most important one from which you are starting your deployment. So in the Cilium BGP cluster config, we define a BGP instance, we define what's our ASN number, and we define the peers. Peer IP address, and then with the reference peering config, which is saved in another CRD. So let's take a look at Cilium BGP peering config. Cilium BGP peer config contains the definition of the peering itself. So, for example, here. It is configured as multi-hop BGP connection. We define which kind of advertisements, whether IPv4 or IPv6 we want to advertise, graceful restart configuration, etc. So that is like very specific BGP configuration for the given peer. And the third CRD is Cilium BGP advertisement. And in this one, we configure what IP addresses or prefixes we want to advertise. So we do have this podsider advertisement and service advertisement here. If you just want to advertise them, it can be much simpler than what you see here. This is just to showcase what kind of specific configuration you can put into the advertisement. So here we are putting some BGP attributes on the advertised routes and similar. So if you want to verify that your BGP configuration works, we do have Cilium CLI as well for debugging or working with the Cilium clusters. And there is a command called Cilium BGP peers, which shows you what peers have you configured via CRDs, what are the IP addresses of the peers, what is the state of the session, uptime, and how many routes are we receiving and advertising. And if you want to check what kind of routes are being advertised, there is Cilium BGP route command for that, which shows you per node which prefixes are being advertised. So if I showed you services from this cluster, then we should find some match. For example, this load balancer service is 10.2.53.169, and we see it advertised from this node and this node as well. And I have one router paired with these two nodes. This is FRR routing container, free open source BGP implementation. So I'll show you that the BGP neighbors are configured and BGP peerings are established with Cilium. And if we check show IP BGP, then we should see all the routes received from the Cilium nodes. Okay, so this was a very short demo. I think we can try to answer some questions. Let's take a look. Is Cilium advertising service IP only from nodes where services pods are located? Yeah, this is a good question. The answer is yes and no. It depends on what is the external traffic policy of the service. If the external traffic policy is cluster, then that service is advertised from all the nodes. If it's local, then it's only advertised from those nodes which have the active endpoints for that service. Our network department requires us to make BGP peering within specific VLAN where LB service return traffic needs to be routed back through some VLAN. Can Cilium do that? Yes and no. I mean, it's not built in directly into Cilium, but you could terminate the VLAN on some sub-interfaces on the node, and then let the node to form the peering through that sub-interface, and then the traffic should be entering through the sub-interface as well. So it requires a little bit of manual setup on the nodes, I would say. BGP is known as a slow routing protocol when used for advertising AS. How is it twisted? So it's usable in more dynamic Kubernetes world. Yeah, absolutely it's usable. So BGP has a bunch of timers built in, and those default values for those timers are not really designed for data center use cases. But you can tweak those timers also on in Cilium configuration to just few seconds, and in that case, like the failure detection can be literally within 2-3 seconds. You just need to tweak the timers. The default values for the timers are not really good for data center deployments. You mentioned the close topology. Is there a plan to integrate BGP EVPN extensions? Not that I would be aware of at the moment, but the good news is that with the BGP v2 kind of free ride of the control plane, we have built very solid foundation for such more complex use cases. So if somebody from the community is interested, or if there will be demand for it, it can be done quite easily. Not easily, but it can be done. But no current plans for BGP VPN. What's the relation between Cilium and Cisco ACI CNI? I would say at the moment not a lot of relation, apart from the fact that both are CNIs. They are completely different CNIs. What is the maximum number of peers you can have in BGP cluster config? There is no limit. Your resources of your servers are defining the limit. What I've personally deployed was few thousands of peers, and it was working fine with them. but there are some future plans for addressing large-scale deployments to achieve less, to allow less peering configuration or configuring less peers, but no current like ETAs for that. And is BGP v2 just about configuration separation, or are there any new major features? It's only about configuration. The backend is like the control plane is still Go BGP, but that configuration separation kind of allows for some more features that were not possible in the past. But BGP v2 itself, as it will be released in the upcoming release, which will happen sometime in the summer, will not introduce any new major BGP feature. Only the API, like new API for the same feature set. But future-wise, of course, we've done that for some reasons. And one of the reasons was to be more future-proof and to allow for more extensibility, but not in this release. Yeah, that's it. Thank you.
Tak slyšíme se? Ahoj, já jsem David, tady mám Lukáše a my bychom se vám krátce představili. Já teda jsem pracoval pro společnost, která se zabývala v Ostravě retailem pro velké B2B a B2C společnosti, které prodávaly spoustu věcí, typicky něco okolo potravin. A Lukáši, jestli můžu poprosit?
A ja som zase ten operations človek na tej druhej strane oproti Dávidovi. Pôsobím v Bratislave u takej firmy, ktorá sa sústredí na outsourcing, hlavne tie DevOps roboty. Prezradím, že taká zaujímavosť medzi nami dvoma je to, že my sa vlastne nezvidíme prvýkrát v živote. Ale tuto máte Čech, tuto Slovák, takže na KCD úplne super.
Ano, já myslím, že se to výborně hodí tady na československé setkání, takže máme i československý projekt, protože zákazník, o kterém budeme mluvit, teda působí jako retailer pro B2B, to znamená business to business, velkoobchodník v českém a slovenském trhu, je to teda jinak celoevropská společnost. A to, co bychom vám vlastně chtěli ukázat, je cesta, kterou my jsme nějakým způsobem společně urazili při stavbě a přenosu vlastně e-commerce platformy tady toho zákazníka na Kubernetes. Takže chtěli bychom vás provést vlastně tou cestou od začátku, s čím jsme začali, po to, co jsme se pokoušeli, jak jsme v které chvíli si mysleli, že bychom jako mohli jít vpřed, až po to teda, kam jsme se dostali a co se nám podařilo. A doufám, že vlastně by to mohlo sloužit především jako inspirace, proto pokud třeba máte stejné problémy jako my, ke kterým se dostaneme, malý tým, málo zdrojů a tak dále, tak chceme ukázat, že něco takového vlastně je možné a to je to, co bychom, doufám, vás přesvědčíme, že si z té prezentace můžete odnést. Takže čemu jsme na začátku čelili, byly 4 různé projekty, 4 různé domény, webové adresy a tady potom na druhé straně máte ukázku toho, jak velký byl ten workload. To znamená, bavíme se o tom, že bez nějakých statických souborů máme nějakých 80 requestů za sekundu a na Postgre databázi asi 5000 transakcí za sekundu. Takže já bych řekl něco tak středně velkého, nejsme rozhodně nic extra velkého, ale na české poměry si myslím, že je to trošičku asi větší projekt.
Ja Davida ešte doplním, že bohužiaľ tento zákazník nám nedal povolenie na to, aby sme ho menovali, preto ste tam videli také tie mock-up slajdy. Dobre, keďže David hovoril o nejakej ceste, ktorou sme sa ubrali, tak ak by to bolo vidno, čo si nie som istý, tak tu máte nejakú cestu aj na pozadí tohto slajdu. Ja som tam pôvodne chcel mať taký ten pekný aerial view, kľuka tej cesty, ako viete, že všetko má svoje ups and downs, že aj naša cesta mala ups and downs, ale nakoniec som našiel lepšiu cestu, takú tú typickú slovenskú alebo aj českú, viete, že záplata na záplate, takých tých 50 shades of grey, lebo to vlastne definuje tú našu robotu, taký ten page on page. Čiže takto nejak sme sa hýbali aj v rámci tohto projektu. No a keď už hovorím o ceste, tak trošku sme do toho zabrli aj takým spôsobom, ako Poliaci, keď opravujú mosty. Viete, že oni postavia vedľa starého mostu nový a ten starý potom zbúrajú. A tak vlastne fungoval aj náš prechod do toho Kubernetes sveta. To, čo vlastne ja som zažil niekedy v roku 2015, keď som sa dostal k tomuto projektu, tak určite to budete všetci poznať, také tie klasické standalone servery, kde vám bežia nejaké Apache s vhostami, mod PHP, sessiony na disku, proste niečo, čo nechcete, lebo ako náhle potrebujete robiť nejaký maintenance, tak to automaticky znamená výpadok služby. Pri týchto nejakých starých veľkých korporátoch to nie je taký problém, oni s tým maintenancom nejako rátajú, ale pre vás ako operations to spôsobuje dosť veľký stres a ja ešte musím teda povedať, že tento náš zákazník, tak kantína v budove, kde máme kancle, tak od nich objednáva suroviny, takže keby sme tam niečo pokazili, na druhý deň sme bez obeda, takže to akože o to väčší stres. No ale v roku 2016 sme sa teda rozhodli zlepšiť si nejak toto naše fungovanie a celú tú infraštruktúru prekopať. Tieto servery sme rozbili na množstvo menších či väčších serverov. Taká klasická infraštruktúra, ktorú určite budete poznať, nejaké key lives medzi load balancermi, replikované databázy, sharovaný NFS storage, čo je stále náš obľúbený single point of failure. Veľa vecí sme prepísali do config managementu, my sme si vybrali salt stack. Dá sa povedať, že v tej chvíli už to bolo nejaký taký pokus o infrastructure as a code, aj keď nie, akože stále nie ten 100% infrastructure as a code. Dobre, na ďalšom slajde vidíte asi, ako to celé vyzeralo. proste nič nezvyčajné. Myslím si, že veľa z vás, ktorí niekedy takéto niečo riešili, tak to vyzerá veľmi podobne. No až pár rokov sme takto fungovali pomerne dobre. Na našej strane, ako sme boli celkom spokojní s týmto niečím. Až po pár rokoch u nášho zákazníka sa obmenil vlastne celý tím programátorov, s touto zmenou prišiel aj David. Asi to poznáte, ako to býva, príde nový tím a zrazu povie, že to, čo bolo dovtedy, že to je všetko úplne na houby. No. Takže prišiel David a on našťastie nepovedal, že všetko je na houby, ale povedal, že nerobí sa nám úplne dobre, že vedeli by ste nám s tým nejako pomôcť. No, vedeli, ale David vám teraz povie, že s čím sa vlastne stretol, keď prišiel.
Tak já především tady na tom slajdu bych vám chtěl ukázat, ať se teda naučím tady s tím nástrojem, a zaměřit vás zde, pardon, se mi tak třepe ruka na tu dálku, jsou to FTP adresáře a všimněte si prosím, že jich tu je více. Takže vlastně, už jsem asi dosvítil, pardon. Tak máme každopádně na každém aplikačním serveru FTP adresář. A to je potom jeden z důležitých prvků, když se nasazovala verze. Protože když se nasazovala verze, tak jedna z věcí třeba, se kterou jsme bojovali, byla taková, že jste připravili si svůj deployment na úrovni souborů, které jste změnili, a tyto soubory jste na každý aplikační server nahráli samostatně. Měli jsme tehdy velkou výhodu samozřejmě v nějakých sticky sessions ze strany PHP, takže jsme aspoň jako věřili, že ten zákazník přijde na stejný aplikační server, kde předtím a podobně, ale stejně tohle to příliš nefungovalo. Co bych chtěl ještě ukázat potom tady z toho slajdu je důležité, že Postgre vlastně databáze, tak ty jsme nechali v průběhu celého toho migračního projektu beze změn, to znamená běží samostatně v tom klasickém způsobu primary slave na samostatných VMkách, tečka. Takže, jak už jsem říkal, ta aplikace vlastně je úplně klasický LAMP stack, která na místo MySQL jsme používali už tehdy od jak živa Postgres. To asi jakoby vůbec nikoho nepřekvapí. Chtěl bych zdůraznit, že jsme bojovali s lokálním vývojem, protože když já jsem vlastně k tomu týmu někde okolo roku 2020 přicházel, tak nikdo z těch vývojářů neměl rozchozené to prostředí u sebe. A to bych řekl, že je naprosto jakoby klasická bolístka, co já jsem zažil, takže spoustu těch modulů, třeba na které se nesáhlo častěji, tak jsme prostě si úplně nebyli jistí, jak do nich zasáhnout, nebyli jsme třeba dobře schopni je otestovat. A s tím samozřejmě ruku v ruce šel nějaký staging, který byla tam taková kupa hnoje, jestli to tak omlouvám se, mohu říci, že prostě nedalo se tam nic otestovat a tím, že deployment byl dělaný po jednotlivých souborech, tak podle toho ten staging vypadal, když všechny ty problémy z produkce se tam prostě vršily několikanásobně, všechny ty nefunkčnosti a nějaké mrtvé větve, tohle tam prostě bylo jakoby naprosto běžné. Takže součástí toho projektu, kterému my jsme vlastně čelili, bylo i uklidit si tady ve vlastních řadách, to, že nějaké testy jsme neměli, nebo CI/CD pipeliny, to vůbec nemusím asi zmiňovat. Specialitou tady toho projektu bylo, že jsme vycházeli z více Git repozitářů. Ono to ve skutečnosti bylo ještě trošku horší, protože my vlastně jsme přebírali od dodavatele ve výpovědi, která trvala 12 měsíců ten projekt, a bylo to hodně o tom, že ten dodavatel se bohužel nerozešel s firmou v dobrém a on nám tvrdil, tady máte ty správné Git repozitáře, my jsme říkali, tady to nedokážeme sestavit, chová se to jinak než produkce, a on nám řekl, kde pak, to je určitě správně a tak dále. Takže tam spousta věcí jakoby nezafungovala a jak říkám, tím, že na té produkci jsme vlastně nasazovali po souborech, tak my jsme si nikdy nemohli ověřit ten správný projekt, že funguje se vším všady a nemohli jsme sestavit to prostředí. Zároveň ty soubory měly takovou nepříjemnou vlastnost, že byly zašifrované. Nevím, jestli znáte IonCube, ale v PHP světě to byl nějaký způsob, jak si můžete chránit své zdrojové soubory, protože PHP jinak funguje v plaintextu, takže ty šifrované zdrojové soubory trošičku jsme nevěděli, co nahráváme, a vy jste vlastně přehrávali na tom FTP soubor, který měl nějaké bajty v sobě, vy jste měli připravenou nějakou náhradu, ale úplně jste si jako nebyli jistí, co tam je. Takže to byla další taková trošku bolístka, se kterou jsme bojovali, ale co bych taky chtěl zdůraznit je, že vlastně ten tým velikostně byl 2,5 členný, co se týče počtu úvazků, což je poměrně asi velmi malé na to, co bude následovat. Takže my samozřejmě jsme si položili tu nejdůležitější otázku, jestli bychom neměli ze všeho toho vycouvat. Ta otázka, když asi slyšíte, v jaké to bylo situaci, je trošičku na místě, aniž bych to jakoby nějak adoroval, tak já bych spíše chtěl ukázat jako to, že jsme k tomu přistoupili konstruktivně, že jsme si zkusili vytyčit v té chvíli to, co nás vlastně nějakým způsobem bolí, pálí a s čím chceme nějakým způsobem pracovat. Takže první věc nám byla úplně jasná, že musíme pracovat jinak než dříve. To je celá asi bez diskuze. Chtěli jsme sjednotit Git repozitáře, protože prostě tohle to musí být základ a nebavím se teď o nějakém monoripu nebo něčem takovém, bavím se prostě jenom o to, že vy věříte tomu, že tenhle ten commit je vaše aplikace se vším všady. My v té aplikaci totiž jsme měli celou řadu závislostí na nějakých interfaceových přenosových nástrojích, kronech a nevím čem všem a jednoduše u toho většího projektu prostě ty věci chcete mít pod jedním štítkem verze, když to tak zjednoduším, v našem případě jeden Git repozitář. Chtěli jsme nasazovat ze zdrojových souborů. V běžném světě bych se asi styděl něco takového napsat, ale tady u toho projektu jsem za to velmi hrdý, že se nám to potom podařilo. Chtěli jsme mít CI/CD pipeliny, zase stejná asi reakce, a tehdy někdy okolo toho roku 2020 jsme vlastně věděli, že bychom chtěli mít kontejnery. My jsme nevěděli vůbec, jako co s nima, nebo nevěděli jsme příliš, jakým způsobem to potom provozovat. Tady se asi možná vrátíme jako později, ale ta samotná kontejnerizace bylo vlastně to nejnáročnější, co my jsme pro tu změnu a ten přechod museli udělat. To znamená, samotné vlastně každá z těch technologií, které my jsme čelili, tak byla něčím jako zvláštní a my jsme nemohli najít, vzít nějaké jakoby hotové řešení, kde bychom si řekli, toto je naše platforma, takhle tak to někdo dělá. A spoustu těch věcí jsme si obili o hlavu a v každém tom typu toho jazyka programovacího nebo způsobu nasazení, tak bylo něco speciálního. Takže třeba PHP, když řeknu, tak PHP se vám rozdělí typicky na dva kontejnery, v našem případě Nginx a PHP FPM, ty mezi sebou by měly nějak udržovat stejnou verzi, my jsme sdíleli mezi nimi statické soubory. Java byla třeba specifická pro buildování, to znamená, nevím, jestli znáte Javu, ale zase to, jak si Java stahuje závislosti, tak v CI/CD pipelinách způsobovalo ohromné prodlevy, než se stáhlo všech 200 jarů a tak dál, takže jsme museli hodně řešit cacheování třeba. Krony zase byly specialita a v těch prvních verzích, které my jsme spouštěli, jsme vlastně jako nechápali, jak pořádně s těmi krony pracovat a spouštěli jsme je tím způsobem, že na mateřském operačním systému byl kron, který vlezl do toho kontejneru a tam spouštěl nějaké příkazy. Takže ty krony třeba to byla i věc, kterou my jsme za začátku nepochopili, jak vlastně k ním přistupovat. A stejně tak bych vlastně tady chtěl zdůraznit, že i SSH přístup bylo něco, co ti uživatelé, jakoby naši správci vlastně a ti vývojáři vyžadovali. Takže my jsme vlastně museli u spousty těch programů se zamýšlet nad tím, jaké by mělo být jejich API nebo CLI, když to tak řeknu. To znamená třeba, když máte nějakou integrační pipeline, která vezme jako 100 typů CSV souboru z jednoho místa, nalije je do vaší databáze, tak vy se musíte zamýšlet nad tím, když to dělá ve 3 stagech a tak dále, jak ji vlastně třeba chcete kusově spouštět, když je třeba nějaká havárka a tak dále. Dříve jste vběhli na server, nějak to zařídili. Teď s kontejnerem to je prostě trošku jiná liga. A samozřejmě je tam potom několik aplikací. V našem případě jsme bojovali trošičku s fulltextovým vyhledáváním, které se jmenuje Sphinx a Talent D. A nevím, jestli znáte integrační sběrnici, které prostě nejsou úplně stavěné, bych to řekl, pro kontejnery a měli jsme s nimi už třeba jenom z toho titulu, jak jsou staré a s tím, že zákazník na ně spoléhal, určité komplikace. Když jsme se dokázali dostat do kontejneru, tak jsme měli za sebou už té vývojářské praxe, řekněme, nebo toho objemu práce vývojářského především 80% hotovo, ale zároveň jsme vlastně byli velmi na začátku toho, jak ty kontejnery spouštět, jak s nimi pracovat. To znamená, dokázali jsme třeba se dostat po velkém úsilí do toho, že jsme přes environment konfigurovali kontejnery. Super, že? Jednoduše. Dokázali jsme se dostat do toho, že všechny ty 4 projekty sdílely stejný PHP kód. A zase nic nevypadá to možná jako vznešeně, ale je to věc, která nám extrémně pomohla ušetřit ohromné množství problémů. Potom vlastně následovala ta diskuze, co s produkcí a jakým způsobem bychom měli pracovat tam. A tam jsme zase zjistili, že ten tým, který byl čistě vývojářský a produkci vlastně vždycky jenom někam nahrál, tak tyhle ty znalosti vůbec nemá. No a stále jsme samozřejmě před důležitou volbou.
No jasné, takže David so svojou partou si teda ujasnili, že chcú kontejnerizovať, super rozhodnutie a teraz rozhodnutie, že v čom? Kubernetes, Docker Swarm, čiže dnes nachádzame na evente, ktorý sa volá krásne Kubernetes Community Days, takže každému je jasné, že my sme si vybrali ten Docker Swarm. Super. Či to bolo dobré rozhodnutie? Asi aj áno, lebo akože bežali sme ho bez problémov nejaké 2 roky, aj keď je pravda, že dnes už Swarm nebežíme nikde. Ale v tom čase, keď sme sa rozhodovali, tak to Kubernetes stále bolo niečo, čo vzbudzovalo dosť veľký rešpekt. Ja si vtedy nepamätám, že či už vôbec existovalo niečo ako kubeADM alebo kubespray alebo nejaké iné tieto pomocné túly. Pamätám si, že sa bolo dosť treba trápiť z ATCD a riešiť ručne certifikáty a podobne. A na druhej strane ten Docker Swarm, tak to bolo init join, čo už dnes poznáte z toho kubeADM a bolo to veľmi simple. Takisto si myslím, že aj chalani programátori dosť privítali túto voľbu, lebo už v tej dobe mali dosť bohaté skúsenosti z Docker Compose. Myslím si, že to im dosť veľa pomohlo a teda vybrali sme sa touto cestou.
Takže co, když jsme vybrali Docker Swarm, tak možná já udělám jenom kratičkou odbočku. Kdo z vás nezná Docker Swarm? Je tady někdo takový? Dobře, tak jenom velmi zrychleně vysvětlím. Docker Swarm si představte, že máte Docker Compose, nebo prostě Docker kontejnery, které spustíte přes více serverů. Je to ten orchestrátor z Kubernetes, ale vůbec vám to nenabízí tu persistentní vrstvu, žádná složitější síťová primitiva a mnoho dalšího. Velký rozdíl taky je v tom, že nemůžete vůbec používat ten sidecar model, nemáte pod, ale máte jenom kontejner. K tomu se dostaneme za chviličku, nebo respektive na to můžu rovnou navázat, protože třeba jeden z problémů, kterým jsme čelili, byl způsob, jak nahlížet do kontejnerů. Víte asi určitě, že v Kubernetes je zcela běžné, že vedle kontejneru hlavního nastartujete nějaký exporter, který se dívá do toho hlavního a ten vám sype metriky. V swarmovém světě tohle znamenalo, že my jsme k tomu hlavnímu kontejneru měli ty sledovací ve stejném počtu. Takže když jsme měli jeden Nginx, tak tady vedle toho běžel exporter. Když jsme měli PHP FPM, vedle toho běžel exporter. A třeba jenom ten samotný fakt znamenal, že jsme téměř zdvojnásobili počet kontejnerů, nehledě na další typy a tak dále, které jsme udržovali při životě. Ty sami o sobě měly jiný životní cyklus než ty hlavní kontejnery a tak dál. Ty sami o sobě v Zabixu a v jiných monitorovacích nástrojích potom produkovali samostatné metriky, které my jsme potom museli jakoby nějakým způsobem odstíňovat a tak dále. Takže jenom třeba tato banalita na první pohled byla významná. Co teda ale jsme získali, co bych chtěl zdůraznit, byl Docker Compose, který jsme mohli znovu použít od toho jednoduchého nasazení a to byla fenomenální věc. Našli jsme nástroj, který se jmenuje Portainer, což bylo takové nahlížítko do toho, co se v tom Docker Swarmu děje, UIčko, a to musím říct, že bylo fantastické. Vývojářům totiž poskytlo možnost vlastně dívat se na logy kontejneru, podívat se, jaká verze toho kontejneru běží, dokonce tam je možnost i SSH nebo kubectl exec by se řeklo dneska dovnitř v terminologii Docker Swarmu, to bylo prostě SSH dovnitř a spoustu těch věcí, které dneska by se řeklo, že je na té platformní úrovni, jak jsme tady slyšeli, tak vlastně ten portainer byla ta naše brána tady k tomu směru. Zároveň to znamenalo, že ti vývojáři získali konečně velký jako vhled do toho, co se děje, získali sebedůvěru, že třeba dokáží pohodlně revertnout verzi. Začali jsme se třeba najednou bavit o tématech, která předtím byla nemyslitelná, že dokážeme oddělit databázové migrace od té samotné verze, že je nemusíme spouštět třeba hned na začátku a další témata, která jsme postupně jako mohli prozkoumávat. Určitě nemusím zdůrazňovat, že součástí té cesty velmi nezbytný krok je, abyste měli staging a produkci maximálně podobnou, takže my vlastně v rámci tady toho nasazení na Swarm jsme zahodili všechny staré servery a budovali ten nový most vedle toho a v jedné chvíli jsme prostě přepli, protože s tím starým harampáním jsme prostě nechtěli mít jakoby nic společného. To, co stále jako není dobře dořešeno v téhle situaci, tak je vývoj pro vývojáře. Jedná se především o to, že PHPčkové kontejnery my vlastně musíme kompilovat, což je velmi jakoby náročné, zároveň ti vývojáři tam chtějí další nějaké extensiony, takže ten nějaký developerský zážitek z toho není jako určitě příliš dobrý. Kde ten Swarm přestal stačit? Já bych řekl, že pokud by ten projekt jakoby nerostl a pokud bychom se zastavili tady v těchto místech, takže by nám stačil asi do dnešních dnů a možná bychom tu nebyli, ale přece jenom se nám to nepodařilo. Tak zaprvé říkal jsem, že jsme neměli nějak řešenou v Docker Swarmu dobře persistentní vrstvy. To naše řešení bylo takové, že jsme vzali NF server a ten jsme namountovali na stejnou pozici na všechny ty compute servery. To je moc hezké, pokud ale máte single point of failure, tak dříve či později havaruje, to se nám samozřejmě také stalo, takže byli jsme reálně v situaci, že nám prostě havaroval jenom NF server a kvůli toho bylo všechno dole. To se prostě tak stává. Load balancing v Docker Swarmu je ten nejjednodušší možný, to znamená round robin, kdy přeskakujete každý požadavek na další server nebo na další kontejner v jeho terminologii. je to nedostatečné z mnoha důvodů a měli jsme s tím jako problém nějak lépe jako stýrovat ten trafik, mířit ho na nějaké pody, kde je třeba kontejnery, kde je třeba méně provozu a tak dále. To samé dynamické škálování, vlastně narazili jsme na to, že když chceme nějak dynamicky škálovat, tak zase problém zleva doprava, není to k tomu uspůsobené. Docker Compose svým způsobem byl jakoby i potom omezující, protože nám způsoboval jakoby nějaké problémy definovat právě třeba ty podrobnější vztahy mezi kontejnery, nebo když jsme třeba ten jeden Docker Compose file chtěli sdílet přes více prostředí, tak tam jsme zase narazili na nějaké komplikace a jednoduše není tak bohatý zdaleka, jak třeba jsou dneska ty YAML definice.
No teda Dávid sa rozhodol, že keďže všetky tieto veci mu chýbajú, že chcel by teda niečo viac, a oslovil nás, že neskúsime ten Kubernetes a samozrejme, že prečo nie, veď medzičasom my už sme všetci získali nejaké to ďalšie know-how z tohto sveta. Ja aj David sme si spravili nejaké tie must-have certifikácie z Kubernetes, čiže nám to prišlo ako celkom dobrá výzva. O to lepšie to je, že niekto to mal ochotu zaplatiť, samozrejme. David s nami dosť konzultoval tento prechod na Kubernetes. Ja ešte upresním, že toto celé, čo my tu vlastne riešime, to sa nedieje v žiadnom public cloude, čiže my nemáme k dispozícii žiadne AWS, GCP ani Azure. My riešime nejakú on-prem infraštruktúru, hoci virtualizovanú, ale v podstate on-prem. David, môžeš teda...
Já teda ukážu, jak se vlastně změnila ta naše architektura a jediné, co se změnilo, je tady ten prostřední sloupec, nic významného asi. A ne, dělám si legraci trošičku. Vpředu nám přibylo několik bezpečnostních prvků a tady uprostřed vidíte klasicky prostě Kubernetes cluster. Dole podhoubí máme VMware, ke kterému jsme nakonec dostali nějaký terraformový přístup, abychom dokázali si servery provisionovat skrze Terraform nástroje. Cloud Init a potom uvnitř kubeadm používáme na to, abychom nastartovali ty servery, připojili je dovnitř do toho klastru. V tom klastru jsou jinak nějaké typy těch různých nodů podle toho, co potřebujeme. V tom setupu, který jedeme, tak bych řekl, že dneska asi úplně obvyklý, není tam nic zajímavého, to znamená, jako ingress používáme velmi ověřený traffic, ty aplikace jsou schované jakoby uvnitř, všechno už je plně kontejnerizované, i včetně těch cron jobů, třeba se kterými jsme bojovali a tak dále, jsme na to nějakým způsobem přišli. Některé stateful workloady jsme dokázali dostat dovnitř a dříve třeba jste viděli, že tam na začátku bylo nějaké rozdělení přes styky session na straně load balanceru před vstupem vlastně na ty aplikační servery a měli jsme tehdy jistotu, že třeba ten jeden zákazník chodí na stejný server a my tím pádem můžeme cacheovat nebo držet třeba jeho PHP sessionu uvnitř jednoho aplikačního serveru. To tady s tím řešením samozřejmě není možné, takže přešli jsme na Redis, který používáme tady jak na cachování těch datových záležitostí, tak potom i na správu session na úrovni PHP. No a je tady takový drobná ikonka RUC/CEP, takže ten NFS jsme nahradili tímto monstrem. Nevím, jestli někdo z vás má s tím zkušenosti, ale my asi pro 30 giga statických souborů jsme potřebovali toto nahradit, takže naučili jsme se celý CEP a dokážeme ho teď spouštět, administrujeme ho a řekl bych, že to je vlastně nejnáročnější věc celé té administrace. Mimo to samozřejmě jsme přešli z Zabixu původně na Prometheus a Grafanu a všechny ty věci okolo, používáme Argo CD a vlastně tohle za mě, jenom jsem chtěl zdůraznit, je taková nějaká extenze toho, kdy začínali jsme na Docker Compose, přešli jsme potom do GitOpsu velmi plynulé a potom nějaké další sběrače, třeba logu a tak dále. KubeVIP používáme právě třeba, protože náš poskytovatel hostingu nám nedokáže na některé ty služby nabídnout na hardwareové úrovni nebo běžně by to byla asi cloudová úroveň, takže musíme si pomoci sami. A tohle jenom bych chtěl zdůraznit zase, že je věc, která třeba té naší adopci nepomohla. Byla tady diskuze dříve o cognitive loadu, takže přesně KubeVIP je prvek, který by se dal velmi snadno třeba zamezit, kdyby ho udělal někdo chytřeji za vás. Takže co si z toho vlastně jakoby odnes, nebo co tady na tom může být zajímavé? První bych chtěl zmínit, že ten velikost toho projektu a toho týmu si myslím, že je neobvyklá, protože pokud ten tým 2,5 členy ještě typicky dělal vývoj pro toho zákazníka v průběhu celého tady toho úsilí a nevzal si dovolno, aby se to všechno naučil, tak to si myslím, že je náročné. Bojovali jsme vlastně na všech frontách, to znamená, my jsme museli přesvědčit toho zákazníka, že technologie je dostatečně zralá, my jsme museli potáhnout i toho hostingového providera, tlačit ho, aby nám třeba dal nějaký API endpoint pro VMware a na všech frontách jednoduše jsme museli trošičku bojovat. GitOps, tak to bych řekl, že to byla pro nás láska na první pohled, to bylo super. Mohli jsme při migraci na Kubernetes využít to know-how a spoustu nástrojů, které my jsme si osahali při Docker Swarmu. Takže tím jsme si sami ten cognitive load alespoň trošičku snížili. Pro nasazení používáme Helm charty, o těch bychom mohli diskutovat dlouho, ale s dovolením to přeskočím teď. A poslední bod, možná nevýznamný, my jsme neměli příliš kam se obrátit tady v československé konstelaci asi o pomoc. Omlouvám se, že to říkám takhle před publikem, zrovna na této události, ale je to reálně tak, že když jsme tehdy třeba v tom roce 2022 o tom uvažovali, 2023 připravovali, tak ta reálná zkušenost nebo konzultantství vůbec tady v tomhletom si myslím ještě bylo hodně jakoby v plenkách. Lukáš na to taky jakoby dost narazil.
Určite môžem potvrdiť, len tak pre zaujímavosť, že to, že niekde si môžete butnúť virtuálku, ktorá vám naštartuje za pár sekúnd, tak za to buďte vďační, lebo u nás to vyzeralo asi tak, že chcete novú virtuálku, nech sa páči, máte ju nabutovanú s mountnutým inštalačným ISO, takže nech sa páči.
Ano, to bylo, s čím jsme začínali. Tady jenom přehled technologií, v prvním sloupečku vidíte vlastně to, s čím jsme začínali, takže úplně klasický setup Zabbix, VMware a SaltStack. A v prostředním je to, co se nám podařilo vlastně zanést při Docker Swarmu a ten třetí sloupeček, to je, co jsme rozšiřovali kvůli Kubernetes. Není asi tak úplně podstatné, jaké ikonky tady jsou, ale spíš jsem jenom chtěl zmínit nahoře, že reálně v té produkci nebo pro ten produkční use case si myslím, že každá z těch ikonek vás stojí 2 až 4 týdny života a to je prostě extrémně mnoho. Pokud ještě máte spoustu dalších povinností okolo tady toho. A to za mě celého toho projektu si myslím, že bylo nejnáročnější, že vlastně my jsme ty technologie museli vyměnit úplně kompletně, i když ta aplikace neměla nějaké větší vady, i když stále používáme na konci Postgre a to je ten, řekněme, bottleneck pro případné nějaké škálování na internet scale, tak stále jsme jednoduše museli se tohleto všechno naučit. A jenom přechod z monitoringu Zabbix na Prometheus třeba znamenal, že jsme mohli všechno, co jsme měli připravené, zahodit a vzít si z toho maximálně jako nějaký mentální model.
Dobre, ja mám trochu pocit, že tá naša infraštruktúra akož vyzerá ako tá Lego kačička, čo sme videli dnes ráno, že nie je to zase až také niečo zložité, ale je tam ešte stále dosť veľa vecí, na ktorých by sme chceli aj v budúcnosti zamakať a ktoré nás ešte čakajú. V tom on-prem prostredí je dosť náročné riešiť nejaký node scaling. Aktuálne vieme to riešiť cez Terraform, aj upscalovať, aj downscalovať, ale nejaký autoscaler zatiaľ sa nám tam na to nechytá. Uvidíme možno v budúcnosti. Zvažujeme aj použitie nejakého cluster API alebo crossplane, čiže to sú technológie, ktoré by sme tiež chceli nejak ovoňať. Takisto databázy, ktoré sme síce zatiaľ neriešili, ale to by sme si veľmi radi vyskúšali v Kubernetes pomocou nejakých operátorov. Zajtra Dávid bude mať na túto tému prezentáciu, takže určite vás pozývam na jeho Postgres Kubernetes. A tak, ďakujem, môžeš to asi uzavrieť.
Tak co doufáme, že si odnesete z našeho hovoru, je především to, že Kubernetes určitě už je v této chvíli zralá platforma. Já teda musím říct, že v Česku si pořád to asi spousta lidí nemyslí a tady to asi nemusím vysvětlovat, ale rozhodně tohle je třeba pořád zdůrazňovat a vysvětlovat všem okolo za mě. Určitě bych chtěl zmínit, že ten nedostatek zkušeností s praktickým nasazením, s těmi detaily ohledně toho, jak to potom v provozu vypadá v Česku, na Slovensku za mě stále jakoby je. Já sám osobně bych se velmi jako chtěl zasadit do toho, aby se to nějakým způsobem zlepšilo, takže třeba budeme diskutovat i o Postgres operátorech, o těch složitějších tématech, ať člověk ví, kde může být ten konec, ale jednoduše tohleto si myslím, že je teď hlavní problém celé té adopce. Určitě Argo CD je příjemné překvapení pro všechny, myslím, kdo s ním pracují. Já ho mohu jenom vyzdvihnout a dokázali jsme přesně řešit i vlastně ty nejsložitější situace ve smyslu nějakých závislostí mezi službami a podobně. A možná nejsme úplně v té nejčistší podobě GitOps ve smyslu, že bychom dokázali z nuly nastartovat klaster bez jediného deletu podu a tak, ale myslím, že bychom se tam, kdybychom potřebovali, byli schopni relativně rychle dostat. Takže ten nástroj jako takový a vůbec ten princip, jak vám to potom upraví na GitLabu ty CI/CD pipeliny a jak pracujete, jak i vývojáři potom pracují a ví, že stačí se navrátit třeba v Gitu, tohle to je nesmírně silná věc a tohle to nám hrozně pomohlo a velmi se nám to líbí. Ohledně celého toho projektu bych jenom doporučil, pokud budete podstupovat nějaké podobné úsilí, ať jste maximálně transparentní vůči zákazníkovi. My tam, kde to šlo, kde jsme dokázali mu to technicky vysvětlit, jsme se o to maximálně snažili a tím pádem jsme získávali jeho důvěru, tím pádem on nás nechal udělat tu odstávku třeba i pro nějaké menší celky, kde on třeba neviděl nějakou přidanou business hodnotu a jednoduše jsme si ten vztah tady tím dokázali velmi silně posilovat. Když to řešení už je v provozu, tak mohu potvrdit, že rozhodně není příliš náročné na správu. Asi to není takový ten režim toho, že máte VM, které nainstalujete a na 10 let na něj zapomenete. To v Kubernetes asi není nic, ale kromě toho RUCEPu musím říci, že ta správa je potřeba zcela minimální, pokud bychom neměli ten, nebo možná ho lépe nastavili třeba, tak opravdu to je záležitost, že 3krát do roka upgradeujete Kubernetes. Vývoj a jeho iterace se zrychlily jako násobně, tuhletu zpětnou vazbu jsme dostali od zákazníka, já jsem až byl překvapený, jak i ten zákazník tohleto pocítil, protože to slychá člověk jako v nějakých teoriích, ale opravdu tohleto jsme zažili, můžu jenom potvrdit. Chtěl bych zdůraznit to, že Docker Swarm jako technologie vlastně jenom spouštění na více počítačích kontejnerů nám už vyřešila většinu problémů a stačila nám svým způsobem. To, že my jsme udělali ten překrok z Docker Swarmu na Kubernetes, nebylo nutné. Já si myslím, že do budoucna to má spoustu benefitů, bude mít a teprve se to jakoby ukáže, ale kdybychom to třeba naplánovali za 2-3 roky, nebyl by to žádný problém. Docker Swarm se můžeme bavit, nakolik je třeba mrtvý, nebo jestli má nějaké problémy, ale ten princip, který my jsme potřebovali, tak už jsme si dokázali zajistit tam. No a co je podstatné, tak celému týmu se, myslím, podařilo se nachytřit, získat nějaké nové dovednosti, trochu se potrápit s tím cognitive loadem, co tady zazněl, to krásné sousloví, takže tohle to, myslím, bylo velmi užitečné. Tak, můžeme na dotazy. Ano, chtěl bych říct, že tým stále máme o velikosti 2,5 člověka. Pokud byste se chtěli přidat nicméně, tak si myslím, že pánové se zlobit nebudou a určitě řekněte. Ne, dělám si legraci, ale jenom jestli k tomu velikosti toho týmu můžu říci, tak za mě řešit projekt takové velikosti, respektive tu infrastrukturní část vedle toho vývoje je opravdu mise na dlouhé večery, víkendy a tak dále a je to o tom, že ti lidé nejenom v tom týmu, ale i okolo byli prostě velmi napomocní a dokázali si s tím vším jakoby poradit a dokázali si s tím vším poradit ve chvíli, kdy mnohokrát i ten zákazník jako je vyzýval k tomu, když máte strach, tak to nedělejme, jestli třeba tohleto považujete za nějaké rizikové, pojďme počkat a tak dále. A je to o tom, že kdybychom řekli, počkáme, není problém, tak tady dneska vůbec nestojíme a možná to máme hotové za 3 roky. Takže bylo to taky hodně o tom, že ten tým sám o sobě měl ten tah na branku a dokázal to prosadit, dokázal se zaručit za to, že dobře, teď nasadíme verzi, my budeme, nechci říct vzhůru, protože to spousta těch věcí nebyly noční akce, bylo to prostě v normálních business hodinách téměř, nebo na kraji pracovní doby, takže to nebyl úplně ten případ, ale chtěl jsem spíš jako jenom vyzdvihnout to, kolik ten tým do toho investoval času a jaký to potom mělo efekt díky toho i u toho zákazníka, že on tu důvěru tam dokázal potom vybudovat.
Dobre, poďme na tie ďalšie otázky, nech to stihneme. Začneme to kratšou. Zvažovali ste prechod do cloudu? Určite áno, my by sme veľmi radi prešli do cloudu, ale žiaľ, niekedy to biznisové rozhodnutie nie je na vás. Ten náš zákazník má nejaké ďalšie projekty s našim poskytovateľom a je to vec, ktorá nás v tomto limituje, preto musíme na tom VMware zostať. Ďalšia otázka. Podarilo sa vám CEF v produkcii alebo pri testovaní rozsypať? Dali ste ho dokopy bez obnovovania záloh? Na Kubernetes sme ho zatiaľ nerozsypali, našťastie. Bežíme CEF aj na bare metaloch a tam už sme ho párkrát rozsypali, ale zatiaľ sa ho podarilo dať aj bez tých záloh späť dokopy.
Já možná doplním jenom, že já jsem ho rozsypal tady na Kubernetes, ale ztráta dat byla 1/500 Cetina nebo něco takového. Nevím, jestli znáte CEP, ale tam se to dělí na nějaké placement grupy, tak jednu jsme dokázali historicky ztratit na cvičném prostředí, když jsme s tím dělali opravdu psí kusy, vypínali, zapínali nody a čekali, jak se to dokáže zotavit. Za mě, a jo, ještě, co jsem řekl, to nejdůležitější je, že to bylo v situaci, kdy na tom CEPu jsme měli nastavené, že ty data jsou jenom v jedné replice. Pokud používáte standardní nastavení, že máte 3 kopie těch dat, tak se vám nic takového asi nemůže stát. Já jsem se tomu věnoval velmi intenzivně a abych to zničil a nepodařilo se mi to, pokud jsem vyloženě nešel do těch adresářů, nemazal v těch partitionech něco, tam už to trošku přestávalo fungovat. Ale dobrá určitě otázka, doporučuji, za mě ta technologie je jako velmi stabilní, ale zároveň má spoustu té jako operačního know-how, které vy musíte znát a dám třeba příklad jako use case, který mě tam překvapil, že byl velmi složitý, když vám dojde místo na disku a zaplní se vám celý ten CEP cluster, tak tohle třeba není triviální věc na vyřešení. Ač by to tak mohlo vypadat, přijdu, umažu nějaká data, tak to tak třeba není. Tak, já odpovím s dovolením na RUC CEP anebo jiné řešení persistent storage. My jsme velmi stáli o to, aby nám ten poskytovatel hostingu nabídl cokoliv jiného, my bychom potom hned sáhli, absolutně hned. A to řešení za nás jsme vlastně diskutovali, jestli vezmeme Longhorn nebo CEP. V té chvíli jsme uvažovali o tom, že ten CEP vypadá, že je prověřenější projekt tehdy. Nevím, jestli bychom to dneska hodnotili nějak jinak, ale hlavně u CEPu jsme uvažovali, že bychom do budoucna ho použili i na bloková zařízení, což by určitě měla být jeho silná stránka, co se třeba výkonu. Takže tohle jsem jenom chtěl zmínit, že tu diskuzi jsme měli. Pokud by nám cloud v budoucnu někdy nebo cloud provider, ten poskytovatel hostingu v současnosti nabídl jakékoliv stabilní, vysoce dostupné řešení, bereme ho všemi 10. Přecházíme hned. Jo? Ale to nemyslím spíš jako kvůli negativům jako CEPu, ale spíše právě kvůli tomu cognitive loadu. Pardon.
Ďakujeme za pozornosť.
Moc děkujeme.
We can start? Okay. So you're going to start the timer? All right, it's running. Okay. Good afternoon. My name is Danilovic, and I'm an SRE at Sentinel-1. And yes, we are hiring. But today, I'm going to talk to you about Cattle Notepad. So let's go into this. Cattle Notepad is a term that's been around for a long time, since 2011. Yes, it was first coined by the architect of the SQL Server at Microsoft. And what did he mean by this? He meant that before the clusterization of the SQL servers, his server were a pet. They had a name. He called it Bubale. And Bubale was a great pet. And when Bubale was sick, he was up with him all night. And when Bubale died, they said Shiva on Bubale because they cared about him. But then the SQL servers became clusters, and you didn't have just one Bubale. You had servers from 1 until 20. And if server 5 was sick, do you really care? No. You shoot it in the head and move on. That's the IT way. Did you try turning it off and on again? Yeah, so that's how we moved from pet to cattle. Now, in 2016, the containers came around, and we added an addendum. It was called the chicken addendum. By the way, I love the names. It sounds like my 3-year-old who's playing with dolls named everything. So, what does the chicken addendum say? Let's say that I'm a farmer, and I have my farm, everything is good, and the state takes a part of my land, and the neighbor takes a part of my land. Now I have a really small real estate. What should I do with my real estate? Should I grow one big cow, or do I have a bunch of chickens? Well, of course, the answer is better to have a bunch of chickens. It's simpler, you can get more out of them. The same things with containers. You can have one big monolithic container, or you can have a bunch of simple containers that will do the work for you. Now that we learned about cattle, pet, chickens, and all the farm animals, what do we get out of it? Really simply, we get automation, right? Because when you have a herd of cattle, and let's say that that the cattle is gonna die, do I call you in the middle of the night? No, I have automation that can kill it, bring it back to life. Same thing with scalability. I already get scalability for free. Do I need 200 Bubale? No problem, I just write 200 somewhere. I don't need to stay up all night for this. So that's what we get for this. Now, this is a CNCF talk, right? So let's talk about Kubernetes, what it's relevant for. Why is it relevant for Kubernetes? Because Kubernetes implements it from the start. It's one of the basic paradigms in Kubernetes. And you can see it right there in the infrastructure. Anybody who knows any of the names of his Kubernetes servers, please raise their hands. A room full of pockets. Great, that's what I wanted. And the same thing you can see also in the pods. Yes, you have a bunch of pods, but they're simple. You can cram as many of them as you want, as long as you keep them simple. Nobody brings a big monolithic pod to you. Now, let's talk about the really important thing. Why is this relevant to you? Well, you are the Kubernetes gatekeepers. And now, when someone comes to you and tells you, you know what, I need you to deploy this big monolithic app. You can tell him, sorry, dude, but you're breaking the chicken addendum. I cannot allow this. Or someone comes to you and tells you, you know what, I have a really cool app, but it needs a really specific server for this. And you can tell him, you know what, build your own Bubale, but keep this out of my Kubernetes clusters. Well, this is it. And of course, by the way, the most important takeaway from this is next time you go to an interview, you can talk about chicken and cattle and pets as much as you want and sound really smart about it. Thank you very much, and have a great day.
Perfect. Hello, everyone. I'm going to present Glasscube today, and I start with introducing myself. My name is Philip McGlincy. I'm one of the co-founders of Glasscube. Previously, I started at the Vienna University of Technology, and after that, I was a CTO at an alerting company. And I'm now in the startup journey with Glasscube for over 2 years, and really love building an open source developer tool. When we all first saw Kubernetes, we thought super easy, perfect world, sunshine, but yeah, reality is quite different, right? So you end up with a Kubernetes cluster and you see there is nothing yet. So you need to really take care of all these packages, application, and we saw the cloud native landscape a couple of times a day, and it's full of packages nobody really takes care of. Yes, there is Helm, but we all know it's there since 9 years, and we all have like a love-hate relationship with it. And I really like to make you aware of the DevOps sandwich, right? Kubernetes at the bottom, it's already solved. Cloud provider or VMware takes care of that. And there's your core application at the top, which you have a lot of developers taking care of it. But what about all these super critical applications in the middle of the DevOps sandwich? No one really takes care of. And nobody really wants to optimize deployments, updates, and making sure these work, because these packages need to work in order to make your application work, which is super important. And this is why we started building Glasscube, the next generation package manager for Kubernetes. We don't, at the moment, try to reinvent the wheel. We really want to give you the best possible experiences in installing packages. And under the hood, use like technologies you know, like manifests, Helm charts, and working on OCI images until we come up with the best way to really package these packages and bring them to production. Dependencies and compatibility checks are baked into Glasscube, so you really can reference dependencies on other packages like cross namespace and make sure that your package is compatible with the Kubernetes version you operate. And we have a lot of inspiration from Brew, so we operate one central package repository, so every new package update gets picked up there as a pull request created for it. Our CI/CD tests them through and make sure that if a package arrives in the core repo, it works. And similar to Brew, we also support custom repositories which you can reference in Glasscube. We're also currently working on Renovate integration. So Renovate will be able to make sure Glasscube itself and its custom resource definitions stay up to date, either with Flux or Argo. And all the packages will be also updated very soon. We're working on a custom data source versioning scheme and manager with the Renovate guys. So how does Glasscube work under the hood? We have a client tool with a CLI and a UI. Everything is stored in custom resources, so there's no external database. And the package controller fetches, package info controller fetches the state from the central package repository and makes sure that all the package instructions to build these packages are kept in the cluster, even resolves all those dependencies and user configuration values. So how does it look like? We not only have a CLI, like Glasscube install something, we also have a UI, super simple, super straightforward. You can install your packages and manage them via the UI, but state is still synchronized over all users for your Kubernetes cluster. We also have configuration. So if you want to inject values from other packages, from dependencies, or manual by hand, from secrets, from config maps, you can do all that also without writing YAML files. And yep, in the end, it will end up as a custom resource value. So what are our next steps? We just crossed 1,000 stars on GitHub, see usages from over 250 organizations, and would really love to talk to more users, get your feedback, and working on our next release, next big release, and our Glasscube Cloud version. So you can make sure package management works from everywhere if you want so. So last but not least, I really want to thank our amazing team. So our founding team, most of them are from Vienna, some are from Portugal. And yeah, they're making everything happen. And our community, right? Over at least now 100 people are on Discord. And they're also giving speeches of Glasscube all around the world, from South America to India. So thank you, everyone. Please give us a star. And yeah, talk to me.
Hello, everybody. Can you hear me? Okay. Today I'm going to tell you how reconciliation loop works in Kubernetes in visual representation. My name is Andrei Kvapil, and as about reconciliation loop, this is main pattern how Kubernetes works, and it is used anywhere by any operator, by any controller. Let's see at Kubernetes theme first. We have Kubernetes API server. It should store data somewhere. Mainly it stores data in etcd. And there are a few more binaries, few more controllers, kube scheduler, controller manager, kube proxy, and kubelet. They're controllers, and there's API server. API server stores all the information about Kubernetes resources, and controllers are working with them. Actually, they just subscribing for all the type of resources, and let's see how it works. We will show example how we can start pod and how various controllers, kube scheduler and kubelet, they are also controllers, works with this pod. First, what they do, they run watch for this type of resources, and they subscribing for this. So they use long polling model, and this resource is just connecting, transferring from kube API server to those controllers. We can also simulate controller by running kubectl get pod with W key, and we will the same subscribe and see the same every iteration which is happening with the pod when we trying to start it. In another console, we'll try to create another pod. We just run kubectl create this spec. First, this pod arrive to kube API server, and the API server appends creation timestamp and status, and we see the next iteration. So scheduler finds that there is a pod, it has no node name, I have to assign node name. Then it runs its own reconciliation loop, its own business logic, and assigns node name to the same resource. Then kubelet on the same node, node 1, sees that there is a new pod assigned to this node, and we have to run containers on this node. So it starts running those containers and continuously reporting the state in the same YAML resource, the YAML manifest, described in API server. When pod is created, we see a running state. Nothing is happening until you will decide to delete this pod. When you delete this pod, your request arrives still to kube API server. It assigns deletion timestamp, and the same logic is running for the rest controllers. First, kubelet finds that there is deletion, pod expecting deletion, starts shooting down the containers, continuously reporting the state back to the Kubernetes API server. And after all the containers removed, it removes the pod exactly from Kubernetes API server. That's it. Thank you. That's all I wanted to show you.
Okay, hello everyone. My name is Jirka Kremzer, and today I'm gonna share some thoughts about autoscaling AI workloads in Kubernetes. In particular, it will be generative AI, and we'll be using KEDA, open source KEDA for it. So what I mean by generative AI workloads, I mean pre-trained neural network models. So no training will be performed in here. We'll just take a huge neural network from a web page like huggingface.com, which is simply something like GitHub for trained models. And we'll be putting stable diffusion to production, which is, I think you all may be familiar with it, is a text-to-image model. So what I mean by autoscaling, I mean spawning and killing pods, right, based on the real demand and based on the real traffic. But you may object, why wouldn't we use HPA? And the reason for that is because it can't scale things down to zero, and also it's basically scaling after the fact. It needs to first measure the CPU or memory load, and only then it kicks in and spawns new pods. But we will be treating the GPUs as stable, so we will be not adding new nodes, but this needs to be prepared for our cluster. I've prepared a demo, which this is the architecture of our simple application. There will be basically a web UI, this is the thing on the left, and a message queue that stores the requests. And based on the length on the queue, it's an AMQP queue implemented by RabbitMQ, it will spawn a new jobs for each request. So let's quickly do that. Oops. So here at the top, I will be watching for a pods that I'm running. You can see there is one web UI, and we are using Minio for sharing the results from the worker pods back to the web UI pods to see the images. And this is the actually application. It's exposed on the internet, so you can try it, ai.example.kedify.o. Not now, please. And I can create something. So, okay, wrong clipboard. So, for instance, robotic cat drawing black and white. And I'll be creating 3 images. So if I click on generate, KEDA actually measures the queue length, and it measured that there was 3 new requests, and it spawned 3 new jobs. So now these pods were scheduled on a node with GPU and are doing something. So let me switch back to presentation. What needs to be prepared? Device plugin is also running in this cluster. So this thing installs NVIDIA drivers and exposes the GPU device and registers it with a kubelet. Something called node feature discovery and GPU feature discovery needs to be run in advance. This is deployed as a daemon set, which spawns a job for each node, which does a discovery for each node. And if it finds a GPU, it labels the node with the correct labels. And that helps us for scheduling those AI-intensive workloads to proper nodes. CUDA drivers were also, CUDA was also installed. I'm using GKE, so a lot of this stuff was automated for me, and I also only need to basically say, hey, I want a GPU cluster. But if you want it, if you are on that on-prem environment, you can use GPU operator from NVIDIA that automates a lot of this stuff and make it easier. So as for the scheduling, a node selector can be used. So based on those pre-labeled nodes, you can specify, hey, I want to run this pod on a node with GPU. You can also use resources when you can specify requests and limits, and you can specify the NVIDIA GPU. So here we are saying we want just 1 GPU. And this makes the GPU exclusively available for you. But you can also use something called dynamic resource allocation, which was a new thing to Kubernetes. And it basically generalized the concept of persistent volume claims, persistent volumes for any arbitrary resource, in our case, GPUs. And NVIDIA also provides us their own solution for time slicing, so you can run multiple things on one GPU. So let's check the results. This is our new robotic cat. So the Minio worker sidecar containers sync the pods to the web UI. Till there, can do also AI workloads. GPUs are not that hard if you do some preparation before that, of course. And also human intelligence was used for generating these slides. These are the cats I've drawn by my own hands. Thank you for your attention, and demo is also open source. You can find it on kdfi.examples. Thank you very much.
Need to turn it on, yeah. Okay, so I don't have slides. A disclaimer, our salesperson signed me up for this without talking to me first. It's something we like to do at Perfect Scale, the company. We challenge one another to tasks. But it's a friendly challenge. So basically, yeah, he signed me up. He didn't also discuss the topic of the talk with me, so it's even more challenging. But anyway, it's something that if you've come to our booth, you probably heard me talking about, and it's about pod right sizing. Okay, so the question is, how do you know what's the correct resources, requests, and limits for the containers that you're running on Kubernetes? And we don't have enough time for answers, so just think about it. But basically, every time I ask this question, everybody says, Okay, and there are very few engineering organizations where this is actually a scientific process, right? So developers don't really know how much resources their applications need, and they don't really care, like what we hear from many developers. I don't care about cost. I don't care about performance. Not very much. And the ops people, they do care about this, but they don't know what the code does. So, yeah. So some of us do load testing, and if you're interested in that, and if you're not doing that, and we know lots of us would like to do load testing, but we don't do it. So tomorrow we have a talk about that at 3:20, about how to do load testing on Kubernetes. And for those... First of all, load testing doesn't cover everything, right? Because we're still testing in an environment that's different from production. Stuff happens in production. And basically, the only way to know how much resources to assign to our containers is by actually monitoring this in production and understanding what the resource changes do to them. And why is it very important? Because when I don't know how much resources to assign to something, what's my natural reaction is? Give it as much resources as I can, right? So that shit doesn't explode in production because I want to sleep quietly at night. Now, the trick there is that this doesn't work. Well, first of all, of course, assigning as much resources as possible. We're not running on Kubernetes alone. On a cluster, there are different applications operated by or created by different teams. Everybody wants as much resources as possible, but the cluster is not infinite, even though the cloud provider would like us to believe it is. But we have budget to care about. And then finally we hit some wall, right? And then the competition begins. Which container gets the resources and the other ones don't. Okay, so that means that if we over-provision, that doesn't necessarily mean we promise ourselves the reliability and the resilience that we'd want to have, right? So we do understand that we need to correctly size our containers so that we don't have reliability issues. And we need to correctly size our containers so that we don't incur too much cost. Because if we ask for resources, but then we don't use them, we're just paying the cloud provider for this confidence, for that good night's sleep that we're not getting in the end because things still explode. And that's the case for container right sizing. Yes, it is very important to know how much resources our containers actually need, and that's what right sizing stands for. Provide the requests and limits exactly according to the needs of our application, to its needs when there is a spike, and also to its needs when the traffic is normal or when the traffic is low. And that's not easy, and you need tools for that. And you can, of course, set this up on your own. There are open source tools. There's VPA. There are monitoring solutions. And you can do load testing. And if you don't want to deal with all that, come to our booth, and we'll talk about how to solve this. Thank you.
So this is not a lightning talk. This is a thank you from all of us. This concludes our first day at Kubernetes Community Days Czech and Slovak in Prague 2024. Thank you very much for attending. Big thanks to our amazing speakers. We delivered today over 20 very nice sessions, multiple workshops, and we had great questions. Thank you for being such a good audience and asking these questions. We are not done. We will be continuing tomorrow. Tomorrow, after the day, there will be a... Yeah? Okay, tomorrow after the day, there will be a raffle. So please make sure you will be here because you can win really nice prizes. But before tomorrow, there are 2 more things to look for and 2 more things that you can participate in. One thing is a shared photo. We would like to kindly ask you if you would like to take photo with all the attendees and all the speakers and the people that prepare this conference. We would like to ask you to go out in front of the faculty and take a shared photo with all of us. And also, there is today, not tomorrow, today, there is a social event at 6:30. The restaurant, its name is Na Kotlářce. It's about 6 minutes walking from here. It's a really good restaurant. We tested yesterday. So we still have some tickets. So if you don't have ticket and you want to attend, please talk to some of the organizers. It would be nice to close the first day on a friendly note, networking and talking to each other and having a good time. So thank you very much. And please, let's go out and let's take a photo before we meet at 6:30 at the restaurace na Kotlářce. Okay, so there is a change. Life is changed. We can actually go sooner, so we don't have to wait until 6:30. We can just take the photo and together go to the restaurant. So we can start having good time even before that. Yes. Thank you.